x plus 1 equal to x square. It's a wonderful algebraic question. We want to find 2x power 4. And so we want to find 2x power 4. So we can either find x square minus x minus 1 equal to 0. That means x square minus x plus 1 by 4 equals 1 plus 1 by 4. We take this minus 1 this side and adding 1 by 4 on both sides. X minus half the whole square is 5 by 4. With this we can find x. Right? So our x minus half is plus or minus root 5 by 2. X is half plus or minus root 5 by 2. X is positive, so it is only half plus root 5 by 2. And then we have to find 2x power 4. So even after you found x, finding x square, x power 4, that's going to become trickier. So we're going to think about finding x power 4 algebraically. And we have an x square here, so square this. X power 4 equals x square plus 2x plus 1. Now x square is x plus 1. So x plus 1 plus 2x plus 1 is x power 4. Or 3x plus 2 is x power 4. Or 6x plus 4 equals 2x power 4. We want to find this, we only need to find this. X is 1 plus root 5 whole by 2. We want to find 6x plus 4, where x is 1 plus root 5 by 2. 6 into 1 plus root 5 by 2 plus 4. So this is 3 times. So 3 plus 3 root 5 plus 4. Or 7 plus 3 root 5 or 3 root 5 plus 7. There goes this answer. Key thing here to somehow find x and then write x power 4 in terms of x. If you manage that, this becomes a far simpler question. The value of log root 5 to the base 0.008 plus log 81 to the base root 3 minus 7. What is this equal to? And this can be written in terms of 5. This can be written in terms of 5. These two can be written in terms of 3. Root 5 is 5 power 1 by 2. 0.008 is 2 cube by 10 cube, or this is 5 power minus 3. 1 by 5, 1 by 5 square, 1 by 5 cube, 1 by 125 is this number. I'm going to write this as log root 5 by log 0.008. Write this as log 81 by log root 3. Choose this base to be 5, this base to be 3 minus 7. Log root 5 is 1 by 2 by minus 3. 5 power minus 3 is 0.008. So log 0.008 base 5 is minus 3. Plus log 81 to the base 3 is 4 by 1 by 2 minus 7. This is 8. 8 minus 7 is 1. This is minus 1 by 6. This whole thing becomes minus 1 by 6 plus 1, which is 5 by 6. This is minus 1 by 6. This is 8 minus 7. So minus 1 by 6 plus 1 is 5 by 6. This is a choice we're looking for. 9 power 2x minus 1 minus 81 power x minus 1 equals 1944. Wonderful. I'm going to write this in terms of 9 power x minus 1. So 9 power 2x minus 1 minus 9 square to the power x minus 1 equals 1944. 9 power 2x minus 1 minus 9 power 2x minus 2 equals 1944. This is 9 power 2x minus 2 into 9 minus 9 power 2x minus 2 is 1944. 9 power 2x minus 2 into 8 is 1944. Let's do 1944 divided by 8. We should be through. 2, 16, 34, 4, 32, 3. And so, or 9 power 2x minus 2 equals 243. 243 is 3 power 5. This is 9 power 5 by 2 is 243. Or 2x minus 2 equals 5 by 2. 2x equals 9 by 2. X is 9 by 4. Wonderful question. Manipulate with exponents. Get comfortable with the idea of dealing with exponents. These questions, either we treat this, sometimes we go to a quadratic mode. We'll say 9 power 2x minus 1, let it be y, and then simplify. Or we get something in common. Between these two expressions, 9 power 2x minus 2 is common. Once you get that, this becomes a very simple question. After that, it's just doing a little bit of algebra and keeping it together. Nothing more than that. The number of solutions x comma y comma z to the equation x minus y minus z equal to 25. X, y, z are positive integers. X is less than or equal to 40. Y is less than or equal to 12. Z is less than or equal to 12. Right. Or the maximum values y and z can take are 12. Maximum x can take is 40. Right. So let's think about this. From 40, we subtract this. We subtract something to get 25. From 40, I'm just going to put some numbers here. 40 minus 12 minus 3 equal to 25. 40 minus 15 is 25. X can be 40. Y can be 12. And Z can be 3. Next is 40. This works. And when x is 39, I'm going to go step by step. X equals 40. That means y plus z equals 15. And x is 39, y plus z equals 14. X is 38, y plus z equals 13. And so on. Right? So x is less than or equal to 40, y less than or equal to 12, z less than or equal to 12. How do we simplify this? We can take individual values for x and then find the number of possibilities for y and z. If y plus z equal to 15, y is less than or equal to 12. So y could be 12, z could be 3. And then we have 11, 4. So y can take values 12, 11, 10, 9, all the way till 3. And z can take the corresponding other values. From 12 to 3, this is a set of 10 values. When x is 40, y plus z equal to 15, there are 10 possibilities. Right? Y can go up to 12 and z can go up to 12. So y can take all values from 3 to 12. Here again, y can go to a maximum of 12, and from y can range from 12 all the way till 2. 12 to 2, there are 11 values. Y plus z equal to 13, y can go from 12 to 1, there are 12 values. When x is 37, y plus z is 12, y can go, x, y, z are positive integers, 11 to 1, 11 values. X is 36, y plus z is 11, y can go from 10 to 1, 10 values. Fine. So x is 35, y plus z is 10, y can take from 9 downwards, 9 values. And I'm going to go to the next slide. What we have here, values, the number of values that can be taken. We've done till x equal to 35. I'm going to go from x equal to 34, 33. But the values we have here, 10, 11, 12, 11, 10, 9. 10, 11, 12, 11, 10, 9. X equals 34. Y plus z should be equal to 9. Y can start from 8. We have 8 values. Here we'll have 7 values. 32, 6 values. 31, 5 values. 34 values. 29, 3 values. 28, 2 sets. 27, 1 set. When it's 27, you have only one possibility. So we have 1 plus 2 plus 3 plus 4 all the way till 10, 12 plus 10 plus 11, or 12 into 13 by 2 plus 21. 12 into 13 by 2, 6 into 13, 78 plus 21, which is 99. This is what they're looking for. going step by step, plugging in x equal to 40, 39, 38, all the way till 27. X cannot be less than 27 because y and z are positive integers. They have to be at least 1. How many integers n will the inequality n minus 5 into n minus 10, which is n square minus 15n plus 50 minus 3n plus 6 less than or equal to 0 be satisfied? I'm going to see if we can factorize this first. N square minus 18n plus 56 less than or equal to 0. 14 into 4, n minus 4 into n minus 14 less than or equal to 0. So n should lie between the roots. It is less than or equal to 0. So n can take values from 4 to 14, 4, 5, 6, 7, 8, all the way till 14. This is 11 values. Very simple question. Take this, simplify this, factorize it. There's a quadratic equation with 2 positive roots and it should be less than or equal to 0. N should lie between the 2 positive roots, between 4 and 14. How many integers are there with between 4 and 14, including 4 and 14, because there's a less than or equal to 0 sitting here. f1 of x is x square plus 11x plus n. f2 of x is x. Then the largest positive integer n for which the equation f1 of x equal to f2 of x has 2 distinct real roots. These two should be equal. Then we have x square plus 10x plus n equal to 0. This should have equal to distinct real roots, or the discriminant should be greater than 0. Discriminant is b square minus 4ac, which is 10 square minus 4n greater than 0. 100 minus 4n greater than 0, or 25 minus n greater than 0, or the maximum positive integer n can take 24. If n were 25, this will have equal real roots. Anything more than 25, this will have no real roots. If you want 2 distinct real roots, n has to be less than 25. Largest positive integer less than 25, that is 24. Equate these two, get to the quadratic, and then put discriminant greater than 0. Done. A, B, C, D are integers such as a plus b plus c plus d equal to 30. The minimum possible value of a minus b whole square plus a minus c whole square plus a minus d whole square is, remember, all three are positive. And so we need to minimize the difference between a and b, a and c, a and d. And so we can try to have all 4 numbers as equal. Put this as 0, put this as 0, put this as 0. But that's not possible because 30 is not a multiple of 4. Remember, whenever there's a difference, the difference is going to be an integer, but they're all integers. And you square an integer, the larger the difference is, the larger the square is going to be. So we should find a to be as close to b, c, d as possible. And all 4 numbers to be very close to each other. 30 by 4, 7.5. So a, we should peg it at 7 or 8. All 4 at 7 or 8. We have 2 7s and 2 8s, this will work. 7, 7, 8, 8. A minus b whole square be 0. A minus c whole square is 1. A minus d whole square is 1. 0 plus 1 is 2. Wonderful. So this looks like this will be the minimum. Let's convince ourselves. Fine. So if the difference is more than 1 anywhere, that just that different square is going to be 4. So we cannot have 0 plus 0 plus 4 or 0 plus 0. We have one difference being 2. We cannot go lower than this. So all the maximum should be 1. So better than 0, 0, 1, we should look for 0, 0, 0, 1, 1. We should look if there is a possibility 0, 0, 1. A equal to B equal to C, and D being slightly further away. And so 8, 8, 8, 6 doesn't work. 7, 7, 7, 9 doesn't work. 7, 7, 8, 8 is the best possibility, or the least is 2. Done. The shortest distance of the point half comma 1 from the curve y equal to mod of x minus 1 plus mod of x plus 1 is, think about the point half comma 1, right? From the point half comma 1 to this point. Let's put half into this. If you put x equal to half, modulus of half minus 1 plus modulus of half plus 1. This is 1 by 2 plus 3 by 2. Y should be 2. Half comma 2 is a point on this line. It seems to be a very interesting curve. Y will be entirely positive. That much we know. I'm going to imagine and draw this curve, even if it takes a while. This is going to be, y is entirely positive. It's going to be a set of straight lines. I'm going to put a bunch of values. Let's say we put x equal to 0. Then y will be 2. 0, comma 2. When x equal to 1, when we put x equal to 1, we'll have 1 minus 1, 0, 1 plus 1, 2, 1 comma 2 is a point. X equal to minus 1, that will be a point here. And so x equal to 1 by 2, half minus 1 is modulus is 1 by 2, 3 by 2, y equal to 2, minus 1 by 2, that will also be a point. So think about this, a wonderful graph. And so I'm going to break this into 3 segments. When x is greater than 1, this will be x minus 1 plus x plus 1. We're talking about 2x. When x is less than minus 1, this will be 1 minus x minus 1 minus x. It will be minus 2x. And so this will be a line like this here and a line like this here. Between minus 1 and 1, it will be 1 minus x plus x plus 1. It will be 2. So there's a point like this. It is 2 from minus 1 to 1, and then a curve with step 2x here and a slope of plus 2 here, slope of minus 2 here. Curves going up. You're looking at a point half comma 1. So half comma 1. The shortest distance will be this perpendicular distance, which will be 1 unit. Draw the graph. The key points here, if you're given just modulus, you're going to deal with straight lines. Keep that in mind. Best way to go about it, find points. Find the scenarios where put x equal to 0 and see if y can be 0. We can see where it meets the x-axis. Whenever you have modulus, break it along the modulus lines. What do I mean by that? X greater than 1, x less than minus 1, between minus 1 and 0. F of x equal to mod x. This means f of x equal to x when x is greater than 0, equal to minus x when x is less than 0, equal to 0 when x is equal to 0. You can put either of this as greater than or equal to or less than or equal to. Imagine that modulus equation like that, reconstruct that, and then you're through. Anytime you have only modulus come in, remember you're dealing with a set of straight lines. That is very crucial. That helps. Imagine the diagram. You put a bunch of points, you can connect them with straight lines, then we are good. If the square of the 7th term in an arithmetic progression with positive common difference equals the product of the 3rd and 17th terms, then the ratio of the first term to the common differences. 7th term of an arithmetic progression, a plus 6d whole square equals a plus 2d into a plus 16d. Then we need to find a by d. A square plus 12d plus 36 equals a square, 12ad plus 2ad plus 16ad plus 32d square. A square gets knocked off. This is 36d square, sorry. So 36d square, 32d square. So this is 4d square plus 12ad minus 18ad equal to 0, or 4d square equals 6ad. Common difference is not 0. 4d equal to 6a. We want to find a by d. This is 4 by 6, which is 2 by 3. We're told we're dealing with positive common difference. I'm just thinking about why that should have been the case. I'm going to the total positive common difference. I'm just thinking why that should be the case. Are we cancelling a d square somewhere? Cancelling only a d somewhere, and we're dealing with equal to. So the ratio should be 2:3. F of x equals 5x plus 2 by 3x minus 5. G of x is x square minus 2x minus 1. X minus 1 the whole square minus 1. G of f of 3. I'm going to find f of 3 first. 5 into 3 plus 2 by 3 into 3 minus 5. 15 plus 2, 17 by 9 minus 5, 4. So that is f of 3. We want to find f of 3, or we want to find f of 17 by 4. It is 5 into 17 by 4 plus 2 by 3 into 17 by 4 minus 5. This is 85 plus 8 by 4 by 51. 3 into 7 is 51 minus 20. Wonderful. So this is 93 by 31, which is 3. Brilliant. F of 3 is 3. So we need to find g of 3. G of 3 is can be written as x minus 1 the whole square minus 2. This is 2 square minus 2, which is 4 minus 2, 2. Or x square, 3 square minus 2 into 3 minus 1, 9 minus 6 minus 1, which is 2. Just substituting, being very careful about the numbers. Luckily enough, we get a 3 here. You're through. Let a1, a2, a3 till a3n be an arithmetic progression with a1 equal to 3, a2 equal to 7. So the common difference is 4. And then we have a1 plus a2 plus a3 all the way till a3n equal to 1830. What is the smallest positive integer m such that m times a1 plus a2 plus a3 till an is greater than 1830? And we can find n and then simplify and find this. It's probably going to be the simplest method, but I think the first 1/3, second 1/3, third 1/3. And so you can reimagine it slightly differently. We might be able to solve this quickly. I think the answer would be 9 or 10, but I'm going to do this step by step. And so sum of n terms of this AP, common difference, I'm going to forget n, put 3n equal to k. And sum of k terms of the AP, k by 2, 2a plus k minus 1 into d is 1830. K by 2 into 2 into 3, 6 plus k minus 1 into 4 is 1830. K by 2 into 6 plus 4k minus 4 is 1830. This is 2 plus 4k, 1 plus 2k. K into 1 plus 2k is 1830. And we can solve this. 2k square plus k minus 1830 is 0. 1830, we need to factorize it between k and 2k plus 1, between two numbers reasonably close by. And so let's divide this by 6. This can be written as 6 into 305. That's far away. 305 is 61 into 5. So 30 into 61 works. So k is 30. 3n is 30 or n is 10. And we need to add this till 10 terms. Let's do that. 10 by 2 into 2 into 3 plus 9 into 4. And 2a plus n minus 1 into d. So this is 5 into 6 plus 36. 5 into 42, which is 210. 210 into m should be greater than 1830. 21 into m should be greater than 183. 21 into 9 is 189. 9 works. So I'm just doing it methodically, finding 3n, then finding n, then substituting and finding m. 21 into m is greater than 189, so m equal to 9 works. Ratio of a square and b square. It's a wonderful question. A and b are integers of opposite signs, such that a plus 3 whole square is to b square is 9:1. A plus 3 whole square by b square is 9, or a plus 3 by b is plus or minus 3. Likewise, a minus 1 by b minus 1 whole square is 4, or a minus 1 by b minus 1 is plus or minus 2. Okay. Or a plus 3 is 3b or minus 3b. Right. If a plus 3 is 3b, a minus 1 is 3b minus 4. A is 3b minus 3 or minus 3b minus 3. So a minus 1 is 3b minus 4 by b minus 1, or minus 3b minus 4 by b minus 1. This is equal to plus or minus 2. This is equal to plus or minus 2. Why are we solving all of this? Because we're given squares. So what are we trying to do? We're going to find the ratios for all of these. Fine, and then see the scenarios where a and b are integers and of opposite signs. And so let's start with the first one. This one, 3b minus 4 by b minus 1. Right, so I'm going to 3b minus 4 by b minus 1 is 2, or 3b minus 4 is 2b minus 2, b equals 2. And if you put b equal to 2, then b minus 1 whole square is 1, a minus 1 whole square is 4, a is 3 works. In this case we have substituted a is 3b minus 3, b equal to 2 gives us a equal to 3. These are integers, but they are not integers of opposite signs, so this doesn't work. If we put 3b minus 4 by b minus 1 is minus 2, we get 3b minus 4 is minus 2b plus 2, or 5b is 6, b is 6 by 5. This doesn't work because we want b and a to be integers and of opposite signs. The other equation, minus 3b minus 4 by b minus 1 is 2. So minus 3b minus 4 is 2b minus 2. Minus 3b minus 2b is minus 2 plus 4. Minus 5b is 2. b is minus 2 by 5. That doesn't work. The last variant, hopefully this will work. Minus 3b minus 4 is minus 2b plus 2. But take this as minus 2. Or minus 3b plus 2b is 2 plus 4, which is 6. b is minus 6. And b is minus 6. In this case, we have made the assumption that a is minus 3b minus 3. A should be minus 3 into minus 6 minus 3, which is 18 minus 3, 15. Fine, so a is 15, b is minus 6 works. 15 plus 3 square is 18 square, minus 6 square is 6 square. This is 9. 15 minus 1 is 14 square, is 2. Minus 6 minus 1 minus 7 square, this is 4. This works. 15 and minus 6 works. A square is to b square is 15 square by 6 square, which is 5 square by 2 square. 25 is to 4. This is the answer choice we're looking for. Very doable question, just that this ratio could be plus or minus 3 when you take the square root. A plus 3 by b could be plus or minus 3. A minus 1 by b minus 1 could be plus or minus 2. Plug in all 4. Only one combination where we get integer values for a and b and of opposite sign. That's the value of a and b. Plug in a square is to b square. We got 25 is to 4. Log x to the base 3 is a. Log y to the base 12 is also a, where x and y are positive numbers. If g is the geometric mean of x and y, the log g to the base 6 would be log x to the base 3 would be a, or x is 3 power a. Log y to the base 12 is a, or y is 12 power a. Geometric mean is square root of xy, which is square root of 3 power a into 12 power a, which is square root of 36 power a. And square root of 36 power a, this is square root of 6 power 2a. 6 power 2a whole power 1 by 2, which is 6 power a. So the geometric mean is 6 power a. Log g to the base 6 be a. And go back to the idea of expressing in terms of exponents, go from logarithms to exponents, and then we are through. Log x to the base 3 is a, or x is 3 power a. This is step 1 in logarithms. Be very comfortable with that. But 90% of the questions start and end with this. Nothing more than that. X is 3 power a, y is 12 power a, x into y is 36 power a, which is 6 square whole power a. And or square root of that is just 6 power a, and then you're through. If x is a real number such that log 5 to the base 3 is log 2 plus x to the base 5, and log 5 to the base 3 is log 2 plus x to the base 5, then which of the following is true? Log 5 to the base 3 is greater than 1. Log 3 to the base 3 is 1. 3 power a number more than 1 is this. Log 5 to the base 3 is less than 2. Log 3 to the base 3 is 1. Log 9 to the base 3 is 2. We want to find a range of x. So log of 2 plus x to the base 5 is greater than 1. Log of 2 plus x to the base 5 is less than 2. Or 2 plus x is greater than 5. 2 plus x is less than 5 square. Or x is greater than 3. 2 plus x is less than 25, or x is less than 23. 3 less than x less than 23. We're going to get a narrower range than this. Log 5 to the base 3 is much more than 1. So probably x is not just greater than 3, x is probably greater than 5 or 6. And log 5 to the base 3 is much less than 2. So x is probably less than 20 even. X might lie in a narrower range, right, between 5 and 20 or 6, and we can find the precise value of x. Right? But so this is one range as a starting point. If this range satisfies, there's only one of the answer choices fitting this range, we are through. If that's not the case, then we'll have to revisit this. And 0 less than x less than 3, that doesn't work. 23 less than x less than 30, that doesn't work. If x is more than 23, this side will become more than 2. X greater than 30, that doesn't work. This should work. This is precisely this range. We're done. Just substituting two nice endpoints, and then we are through with this question. F of x equal to x square and g of x equal to 2 power x. What is the value of f of g of x plus f of g of x plus g of f of x at x equal to 1? We're looking for let's find f of g of x plus g of f of x at x equal to 1. Then we'll worry about finding f of this. Right? So g of 1 is 2 power 1, this is 2. F of 1 is 1 square, which is 1. This number becomes f of 2 plus g of 1 at x equal to 2, at x equal to 1. When we're substituting x equal to 1, g of 1 is 2, f of 1 is 1. Right? Now f of 2 is 2 square, which is 4. G of 1 is 2 power 1, which is 2. So this sum at x equal to 1 is 6. We need to find f of 6. F of 6 is 6 square, 36. Done. Juicy, wonderful, easy question. So we would love it if all our questions were like this. Substitute x equal to 1, find this expression, be careful with the math. That's it. Nothing more than that. Sum of squares of roots. The minimum possible value of the sum of the squares of the roots of the equation is the roots p and q. The two roots, a quadratic. We want to find the minimum value of p square plus q square. We know the sum of the roots and product of the roots formulae. Sum of the roots p plus q is minus b by a, which is minus of a plus 3. PQ is c by a, which is minus of a plus 5. P square plus q square, we want to write this in terms of p plus q and pq. It will be p plus q whole square minus 2pq. This will be p square plus q square plus 2pq minus 2pq. Or this expression is going to be minus of a plus 3 the whole square minus 2 times minus of a plus 5. Or this is a square plus 6x, a square plus 6x plus 9 plus 2a plus 10. And or this is a square plus 8a plus 19. So now we want to find the minimum value of a square plus 8a plus 19. The best way to do it would be the completion of squares. A square plus 8a plus what would make this a square? Something of the form a plus k the whole square. A square plus 8a plus 16 will work. This a square plus 2ax plus 2ak plus k square. So it should be 4. So a square plus 8a plus 16 plus 3. This is 19. So we write this 19 as 16 plus 3. Or this is a plus 4 the whole square plus 3. The minimum value this can take is 3. That is when a is minus 4. Or the minimum possible value is 3. Super. We want to find 9 power x minus half minus 2 power 2x minus 2 equals 4 power x minus 3 power 2x minus 3. 9 power x minus half is 9 power x by 9 power half minus 2 power 2x by 2 square equals 2 square whole power x minus 3 power 2x by 3 cube. And so 9 power x by 3, which is 3 power 2x by 3 minus 2 power 2x by 4 equals 2 power 2x minus 3 power 2x by 27. I'm going to bring the 3 powers to one side, 2 powers to one side, see where that takes us. So 3 power 2x by 3 plus 3 power 2x by 27 equals 2 power 2x plus 2 power 2x by 4. And so this is 9 times 3 power 2x plus 3 power 2x by 27 equals 4 times 2 power 2x plus 2 power 2x by 4. 3 power 2x into 10 by 27 equals 5 into 2 power 2x by 4. This 5 gets knocked off. We have a 2 here. This becomes 3 power 2x into 8 equals 2 power 2x into 27. And so think about this. This is 3 power 2x minus 3 equals 2 power 2x minus 3. This is possible only when both of these are 0, or 2x minus 3 should be 0, x should be 3 by 2. Wonderful question. A bunch of simple ideas to keep in mind. A power 9 power x minus half is 9 power x by 9 power half. Something power half is square root. And then manipulate with exponents rules, you'll get to the answer. It's a very doable question, but it will be very methodical and understand the rules of exponents very clearly. Log of 2 power a into 3 power b into 5 power c is the arithmetic mean of log of 2 square into 3 cube into 5, log of 2 power 6 into 3 into 5 power 7, and log of 2 into 3 square into 5 power 4. Or this expression is this plus this by 3. And so, or 3 times log of 2 power a into 3 power b into 5 power c is log of 2 square into 3 cube into 5 plus log of 2 power 6 into 3 into 5 power 7 plus log of 2 into 3 square into 5 power 4. Or 2 power 3a into 3 power 3b into 5 power 3c equals 2 square into 2 power 6 into 2 power 1 into 3's into 5's. We need to find only a, so forget about 3's and 5's. 2 power 3a is 2 power 9. 3a equals 9, a equals 3. It's 2 square, 2 power 6, 2 power 1. That will become 2 power 9, which is 2 power 3a. A is 3. Done. Because we don't need to find b and c, we don't worry about powers of 3 and powers of 5. A1, A2, A3, A4, A5 be a sequence of 5 consecutive odd numbers. So A1, A2, A3, so I'm going to call this as n, A3 as n minus 2, n minus 4, n plus 2, n plus 4. Consider a new sequence of 5 consecutive even numbers ending with 2a3. So this is a3 ending with 2a3. 5 consecutive even numbers. If sum of the numbers in the new sequence is 450, so I'm going to think about the new sequence as m plus 2, m plus 4, m minus 2, m minus 4. 2a3 is the last number, that happens to be m plus 4. Fine. Now adding all this we get 450, or the middle number is 90. 5m is 90, so 92, 94. 94 is 2a3. 2a3 equals 94, or a3 is 47. This is 47, 49, 51. So a5 should be 51. The key learning here, or the only big learning here, the only important point here, if you have 5 terms in an AP, anchor it around the middle term. Average of any number of terms in AP is the middle term. Median, mean, both are the middle term. So 5 terms in AP, 5 times the middle term is sum of all terms. So sum of these 5 terms is 450, middle term is 90. Middle term is 90, that means the last term is 94. Last term is 2a3, 2a3 is 94, a3 is 47, a4 is 49, a5 is 51. How many different pairs a comma b of positive integers are there such that a is less than or equal to b and 1 by a plus 1 by b is 1 by 9? So beautiful question. A is less than or equal to b, 1 by a plus 1 by b equals 1 by 9. Think about this. Let's simplify this. If we have 2 numbers adding up to 1 by 9, and so we cannot have either number to be, we're talking about positive integers, we cannot have either number to be greater than 1 by 9. Very simple idea. We know that a and b are both greater than 9. And very simple idea. And so 1 by a plus 1 by b is 1 by 9. We cannot have 1 by 2 plus a positive term to be 1 by 9. That's impossible. A and b, we're talking about positive integers. A and b should both be greater than 9. Right? So the simplest idea to think about is 1 by 18 plus 1 by 18. This is 1 by 9. So a and b can be 18 comma 18. That is one possibility. Half and half equal 18 comma 18. Now a is less than or equal to b. So this number 1 by a will be high, 1 by b will be lesser. A is less than or equal to b, so this works. 1 by 18 plus 1 by 18 is 1 by 9, or a should be less than or equal to 18, b should be greater than or equal to 18. If I increase a and b, the total will become smaller. If I decrease both a and b, the total will become greater than 1 by 9. I want 1 by a plus 1 by b to be 1 by 9. That means one number equally split is 1 by 18 and 1 by 18. So we cannot have both less than 1 by 18. We cannot have both more than 1 by 18. Or this number should be, that a should be less than or equal to 18. B should be greater than or equal to 9. We know a and b are both greater than 9. Right? That much we know. Right? So a should be less than or equal to 18. A should be greater than 9, or a can take values 10, 11, 12, 13, 14, 15, 16, 17, 18. 2, 3, 4, 5, 6, 7, 8, 9 possibilities. Of this, 18 works. Fine. Now we can think of 1 by b as 1 by 9 minus 1 by a. So 1 by 9 minus 1 by any of this, wherever it will become a nice 1 by b, where b is an integer. We are through. Straight away you can sense that 17 won't work. 1 by 9 minus 1 by 17. 17 minus 9 by 17 into 9. This doesn't, it won't factorize. That's out. 1 by 18 minus 1 by 9 minus 1 by 16. Nothing in common. Be 7 by something. Doesn't work. 15 could work. 1 by 9 minus 1 by 15. So the denominator could be 45. 5 by 45 minus 3 by 45. 2 by 45. Funnily enough, that doesn't work. 14, not likely to work. 1 by 9 minus 1 by 14. 14 minus 9 by 14 into 9, not possible. 13, 1 by 9 minus 1 by 13, won't work. 12 might work. It has to have something in factor with 9, in common with 9. 1 by 9 minus 1 by 12. 36 is common. 4 minus 3 by 36. 1 by 36. Yep, that works. A equal to 12, B equal to 36. That is a possibility. So 12 works. 11, 1 by 9 minus 1 by 11 is 2 by 99. Doesn't work. 10, 1 by 9 minus 1 by 10 is 10 minus 1, 1 by 90. That can work. 10 works. A equal to 9, B equal to 90 works. So 18, 18 works. 12, 36 works. 9, 90 works. Nothing else can work. A cannot be 9, B being infinity, that's not possible. So 3 pairs work. So wonderful question, tough question. A little bit of math, a little bit of trial and error. Key thing to notice here is to start with 18, 18 works. And after that, one of A and B has to be less than 18, other has to be more than 18. So A is less than or equal to 18, B is greater than or equal to 18. A cannot be less than 9. It cannot even be equal to 9. So from 10 to 18, that's a set of possible values A can take. Go step by step. We can forget about primes. We can forget about numbers that have nothing in common with 9. All those will just weed themselves out. Worry about the remaining. We are through. F of A comma B is f of A into f of B for all positive integers A and B. Then the largest possible value of f of 1. See, f of A into B is f of A into f of B. It's A into B. I'm going to put B as 1. F of A into 1 is f of A into f of 1, or f of A is f of A into f of 1, or f of A into f of 1 minus 1 is 0. There are two possibilities here. Remember this. Either f of A is 0 or f of 1 is 1. Either this could be a constant function where f of all values is 0. Then f of A into B will be equal to f of A into f of B. In which case, f of 1 will also be 0. Or f of 1 is 1. In which case there are different values possible, but f of 1 is 1. That much we know. The largest possible value of f of 1 is 1. When f of 1 could either be 1 or it could be 0. If the constant function f of A equal to 0, then f of 1 will also be 0. If that is not the case, then f of 1 is 1. The largest possible value of f of 1 is 1. Let f of x equal to 2x minus 5 and g of x equal to 7 minus 2x. Then modulus of f of x plus g of x equals modulus of f of x plus modulus of g of x, if and only if. So let's worry about this. This is easy to form. Modulus of 2x minus 5 plus 7 minus 2x equals modulus of 2x minus 5 plus modulus of 7 minus 2x. 2x minus 5 plus 7 minus 2x is modulus of 7 minus 5, just mod 2, just 2. Modulus of f of x plus g of x is 2. We need this to be 2. Now, modulus of 2x minus 5, modulus of 7 minus 2x. This breaks at 5 by 2. This breaks at 7 by 2. What do I mean by that? Greater than 5 by 2, we'll call it as 2x minus 5. Less than 5 by 2, we'll call it as 5 minus 2x. Fine. Likewise, 7 minus 2x goes to 0 at 7 by 2. So we'll worry about the expression being 7 minus 2x and 2x minus 7, depending on that range. 5 by 2 and 7 by 2 are our pivotal points. So our answer choice is going to be anchored around that. And so now think about this. We have 0 here, 5 by 2 somewhere here, 7 by 2 somewhere here. X is greater than 7 by 2. X is less than 5 by 2. X sits between 5 by 2 and 7 by 2. Those are our three possibilities. Right? Less than 5 by 2. If X is less than 5 by 2, X is say 2. Then this will be 2 into 2 minus 5, which is minus 1. Modulus of minus 1 is plus 1. So here there will be 5 minus 2x plus modulus of 7 minus 2x. If x is less than 5 by 2, this will stay as 7 minus 2x plus 7 minus 2x. This will be 12 minus 4x. And I'm just breaking it into three ranges. Fine. So 0 to 5 by 2, the expression will be like this. Fine. So when x is less than 5 by 2, modulus of 2x minus 5 is of the form 5 minus 2x. When x is greater than or equal to 5 by 2, modulus of 2x minus 5 will be 2x minus 5. Likewise, when x is less than 7 by 2, modulus of 7 minus 2x will be 7 minus 2x. When x is greater than or equal to 7 by 2, modulus of 7 minus 2x will be 2x minus 7. Fine. So this is how this function breaks. Therefore, if you're looking at 0 to 5 by 2, 5 by 2 to 7 by 2, greater than 7 by 2. And 0 to 5 by 2 we have done. Now we're going to think about not 0 to 5 by 2, less than or equal to 5 by 2. Then this expression becomes 12 minus 4x. We're going to talk about 5 by 2 less than x less than 7 by 2. In this range, the expression will be x is more than 5 by 2. This will be 2x minus 5. X is less than 7 by 2 plus 7 minus 2x. This is 2. X is greater than or equal to 7 by 2. This will become 2x minus 5 plus 2x minus 7, which is 4x minus 12. So here it is 2. Fine. In these two ranges, it doesn't work. Fine. So the answer looks like it is this, but we have to be very careful here. When x is equal to 5 by 2, 12 minus 4 into 5 by 2 is also 2. That's equal to 7 by 2, 14 minus 12. That also works. So this right here is not the answer choice. This is the answer choice. X could be 5 by 2. X could be 7 by 2. Both are possible. So x lies between 5 by 2 and 7 by 2, all right. But it is close to interval 5 by 2 to 7 by 2. Both of those values are indeed possible. So worry about this. Don't do all this and mark this as the answer choice. It's a wonderful, wonderful question. So 5 by 2 less than x less than 7 by 2. That works. This range works. That is if x is there, but only if, then you have to mark this. Because x could be 5 by 2, x could be 7 by 2. That possibility also needs to be considered. So keep that in mind. An infinite geometric progression a1, a2, a3 has the property that an equals 3 times an plus 1 plus an plus 2 and so on. Infinite terms. For every n greater than or equal to 1. a1 plus a2 plus a3 all the way till 32. Sum of infinite terms of a1 is 32, or the first term being a by 1 minus r is 32. Fine. A equals 3 times a2 plus a3 and so on. This is also an infinite sequence. In this expression, I am putting n equal to 1. a2, this is geometric progression with the first term being ar and the sequence being 1 minus r, or this is a equals 3 times a into r by 1 minus r, or 1 minus r equals 3r, 1 equals 4r, r equals 1 by 4. a by 1 minus r is 32. A equals 32 into 1 minus 1 by 4. A is 32 into 3 by 4, which is 24. We want to find A5. A5 is AR power 4. A5 equals AR power 4. A is 24. R power 4 is 1 by 4 whole power 4. So this is 24 into 1 by 4 into 1 by 4 into 1 by 4 into 1 by 4. 24 by 4 is 6. This is 2, 3. This is 3 by 2 into 4 into 4, 3 by 32, wherever that choice is. A1 is 1 by 2 into 5, A2 is 1 by 5 into 8, A3 is 1 by 8 into 11, all the way till A100. And so, how do we do this? This is going to be something of this form. Finally, you have to sense this: A minus B plus B minus C plus C minus D, all the way till something. So a bunch of terms are going to get cancelled, and we're going to be left with something in the end. The method, getting a sense of the method is very important. We're going to somehow fall back into the idea of partial fractions. And so if you can sense that, that is brilliant. Fine. So first step, we need to find the 100th term. This is 1 by 2 into 5, 5 into 8, 8 into 11. We're going plus 3, plus 3, plus 3. So A1 is 2 into 5, A2 is 5 into 8. So I'm going to define AN as 1 by n plus 1 into n plus 4. So A2 is, 5 into 8. This goes up in steps of 3. 1 by 3n minus 1 into 3n minus 3n plus 2. This is AN. First term is 1 by 2 into 1 by 5. Why 3n? Because this goes up in steps of 3. So these are anchoring around multiples of 3. I'm going to link A1 to 2, A2 to 5, A3 to 8. What is this sequence? This is 3 minus 1, 6 minus 1, 9 minus 1. So this first term is 1 by 3n minus 1. Second term is this plus 3, 3n plus 2. Fine. And so on. So 100th term will be 1 by 3 into 100 minus 1. 3 into 100, 300 minus 1, 299 into 302. That's the 100th term. We're going to break this open using the idea of partial fractions. How so? Start with, I'm going to go back to this. Let's get back to pointer mode. 1 by 2 into 5. So I'm going to think about it as 1 by 2 minus 1 by 5. LCM is 2 into 5. Numerator is 5 minus 2. 3 by 2 into 5. 1 by 5 minus 1 by 8. 5 into 8. 8 minus 5, which is 3 by 5 into 8. Or imagine this like this: 1/3 of this will be 1/3 of this, which is 1 by 2 into 5. 1/3 of this will be 1/3 of this, will be 1 by 5 into 8. Or this giant expression can be written as 1/3 whole of 1 by 2 minus 1 by 5. Plus 1 by 5 minus 1 by 8 plus 1 by 8 minus 1 by 11, all the way to 1 by 299 minus 1 by 302. Fine. Just like how we had outlined, A minus B plus B minus C plus C minus D plus D minus C, all the way till one final term. Bunch of things get cancelled. This will get knocked off, this will get knocked off, this will get knocked off. Everything will get knocked off till there. Or we are looking at 1 by 3 times 1 by 2 minus 1 by 302. 302 and 2, LCM will be 302. This will be 151. So this is 1 by 3 times 151 minus 1 by 302. This is 1 by 3 times 150 by 302. This is 50 by 302, or 25 by 151. Just this choice. Fine. Key thing here, you're looking at partial fractions. You're looking to break these into fractions such that you have a bunch of terms that get cancelled. 1 by 1 into 2 is 1 by 1 into 1 by 2. 1 by 2 into 3 is 1 by 2 minus 1 by 3. 1 by 3 into 4 is 1 by 3 minus 1 by 4. Likewise, 1 by 2 into 5 is 1 by 2 minus 1 by 5. 1/3 of this. The numerator becomes 3. So I'll have to knock that off. So this whole expression becomes 1/3 of 1 by 2 minus 1 by 5, 1 by 5 minus 1 by 8, 1 by 8 minus 1 by 11, all of those added. So a bunch of terms will get cancelled. We'll be left with 1/3 of 1 by 2 minus 1 by 302. That is what 151 by 302 minus 1 by 302, or 150 by 302, 1/3 of that. 50 by 302, which is 25 by 151. P cube equal to q power 4 equal to r power 5 equal to s power 6. The value of log of PQR to the base s. These kind of questions I would usually like to plonk this as equal to k power something, so that everything we can get in terms of k, and then this we can rewrite it as log PQR by log s, both to the base k. That is the approach. You get that, you're through. Equal to k power what? That is the key thing. We want this to be a multiple of 3, 4, 5 and 6. LCM of 3, 4, 5 and 6 is LCM of 4, 5 and 6. LCM of 4 and 6 is 12. 12 and 5 is 16. Or P equals k power 20, Q equals k power 15, R equals k power 12, S equals k power 10. Log of PQR to the base k by log s to the base k. So it's log of k power 20 into k power 12 into k power 15. P, R and Q, I've written it incorrectly, by log of k power 10 to the base k. This is simple. 20 plus 12 is 32. 32 plus 12 is 47. 47 by 10. This is the answer. The moment we plonk it like this, then we get everything in terms of one variable. An old trick, suppose you're told 2a equals 3b equals 4c equals 5d. Plonk this all to be equal to 60 k, and then get everything in terms of k. Nice whole numbers, nothing to worry about, you're done. Fine. So it's an old trick for simplifying variables. If given bunch of equations, assume a new variable, life becomes simple. The area of rectangle and the square of its perimeter are in the ratio 1:25. L into B is to 2 times L plus B whole square is 1:25. I'm going to write down this equation and then figure this out. LB is to 2 times L plus B whole square is 1:25. We need to find the ratio B is to L, shorter to longer side. And so L is to B, L into B equals 4 times L square plus 2LB plus B square is 1:25, or LB is to 4L square plus 8LB plus 4B square is 1:25, or 25LB equals 4L square plus 8LB plus 4B square. 4L square minus 17LB plus 4B square is 0. Can be split as 16 and 1. We're going to get a ratio 1:4. And so 4L square minus 16LB minus LB plus 4B square is 0. 4L into 4L minus 4B minus B, sorry, 4L into L minus 4B minus B into L minus 4B is 0. So 4L minus B into L minus 4B is 0. 1:4 or 4:1. Shorter to longer is 1:4. And just plain old-fashioned writing of equations, simplifying that. We're looking to solve for b by l. If you want to deal with only one variable, you don't like factorizing like this, divide by l square throughout. So you'll get 4 minus 17b by l plus 4b by l whole square equal to 0. b by l is what we want to find. We'll have 4 minus 17x plus 4x square equal to 0. X is what we need to find. You can simplify and find that. If you don't like dealing with a quadratic equation that has L and B, then create a B by L by dividing by L square throughout, and then you're done. You're dealing with only one variable. 4 power n is greater than 17 power 19. I'm going to write this as 4 square power n by 2 is greater than 17 by 19. 16 power n by 2 is greater than 17 power 19. We want to find the smallest n. I'm going to think about n that doesn't work. If I put n, 16 power 19 is not greater than 17 power 19. 16 power 38 by 2 is not greater than 17 power 19. N cannot be 38. 38 does not work. N has to be greater than 38. So 33 doesn't work, 37 doesn't work, 35 doesn't work. Bam, we've got this. We need to now think that 16 power 39 by 2 is greater than 17 power 19. Fine. It should be, I'm not saying it is not. This is 4 into 16 power 39 is greater than 16 power 19 is greater than 17 power 19. 4 is greater than 17 by 16 whole power 19. This could be tough to prove. It should be. That's what the question is telling us. But we do not have to worry about it. We know that 38 doesn't work. If the 39 and 40 had been in the choices, then we are worried. We are in trouble. It's not. So this becomes an easy question. 39 works. N cube minus 11n square plus 32n minus 28 greater than 0. The smallest integer n. See, n cube is powerful. So if you put 100, or then n cube will kill everything else. These are reasonable coefficients. And n cube is very powerful. So if n cube is positive, n cube is way more powerful than n square, way more powerful than n. So if you put n cube as 7, 8, 9, 10, 11, the larger you take n cube to, the more dominant the cube idea will become. So this is going to become bigger and bigger the higher n gets. And it's a curve that's open-ended. It's going to become larger and larger with increasing n. We can sense that. And there are multiple ways of doing this. One would be to just plonk in a value of n and then go from there. My favorite is probably n equal to 10, which is 1000 minus 1100 plus 320 minus 28. 1000 minus 1100 minus 100 plus 320 minus 28. So this works. Now maybe 9 will work, maybe 8 will work. I would like to skip to 8 and then come back and check 9. If 8 works, then I can go lower. So this is 512 minus 11 into 64 plus 32 into 8 minus 28. So 512 minus 704 plus 32 into 8. This is 256 minus 28. So 512 plus 256 is 867. 704 plus 28 is 732. So 512 plus 256 is greater than 704 plus 28. So 8 works. Already I'm beginning to sense that 7 won't work. And so 8 works. This is this close. So the more dominant n is, n cube is, larger number should be higher. 8 works, and 8 is this close, so 7 probably won't work. Let's check it out any which way. So 343 minus 11 into 49 plus 32 into 7 minus 28 greater than 0. Is this true? 49 into 11, 490 plus 49 is 539. So 343 539, 28, 32 into 7, 7 2s are 14, 4, 1, 7 3s are 21 plus 1, 22. Let's add these through. 3 plus 4 is 7, 4 plus 2 is 6, 567. I have a gut feeling this will be 567. So 7 is equal to 0. 8 works. An increasing sequence. So the smallest integer that works is 8. The other way of thinking about it is substituting small values and seeing if it can something factorize it. So p of x by x minus a remainder is 0. So we can look to factorize this if we can manage to find a factor. So we have n cube minus 11n square plus 32n minus 28. If you put n equal to 1, 1 minus 11 plus 32 minus 28. This adds up to 39, it adds up to 33, doesn't work. 2, 8 minus 44 plus 64 minus 28. 72, 72, yeah, this works. So this number, n cube minus 11n square plus 32n minus 28 is a multiple of n minus 2. We can factorize this. N square goes here, n cube minus 2n square. So minus 9n square plus 32n minus 9n minus 9n square plus 18n. We'll have 14n minus 28 plus 7. Sorry, plus 14. This is 14n minus 28, or our expression is n minus 2 into n square minus 9n plus 14, or it is n minus 2 into n minus 2 into n minus 7. When will this be greater than 0? When n is greater than 7. When n is 7, it will be greater than 0. When n hits between 2 and 7, it will be negative. What happens when n is 1? Very interesting. When n is 1, this 1 cube minus 11 plus 32 into 1 minus 28. 1 minus 11 plus 32 minus 28. This is 33 minus 39, which is minus 6. This doesn't work when n is 1. When n is 3, 4, 5, it won't work. When n is 1, these two are negative, this is negative. All three are negative, it doesn't work. Between 3 and 7, it doesn't work. These two will be positive, this is negative. The smallest integer that will work for is the integer 8. So sum of the squares of two numbers is 97. Then which of the following cannot be their product? A square plus b square equals 97. Fine. Very interesting. Here we're talking about AB. And very interesting. So think about this. A square plus b square and AB. That's a very powerful link. If you think about 2 times AB. AB is 64. That means 2AB should be 128. 2AB should be minus 64. 2AB should be 32. 2AB should be 96. Why am I doing this? Because I can think about a square plus b square plus 2AB, a square plus b square minus 2AB. A square plus b square plus 2AB should be greater than or equal to 0, because this is a plus b whole square. A square plus b square minus 2AB should be greater than or equal to 0. This is a minus b whole square. 97 plus 128 works. 97 minus 128 does not work. It cannot be 64. The rest it can be. Quite simply put, a square plus b square should be greater than or equal to modulus of 2AB. A square plus b square should be greater than or equal to 2AB. It should be greater than or equal to minus 2AB. That's the condition. A square plus b square by 2 is greater than or equal to a into b. Modulus of a into b all the time. And so this idea is very important, very useful. So here it is summing up to 97. So 2AB has to lie between 97 and minus 97, or AB should be less than 97 by 2, greater than minus 97 by 2. All of these work, this one doesn't. So that's all we need to keep in mind for this question. If A and B are integers important, such that 2x square minus ax plus 2 is greater than 0, and x square minus bx plus 8 greater than or equal to 0, for all real numbers x, very vital point, is always greater than 0. Then the largest possible value of 2a minus 6b. It's a complicated sounding question. I'm going to do this by a wonderful method called as completion of squares. What do I mean by that? Let's take this one. 2x square minus ax plus 2 greater than 0. I don't want to deal with 2x square. I'm going to think of this as x square minus a by 2x plus 1 greater than 0. We know that x minus k the whole square, x square minus 2kx plus k square. And here we have an a by 2, right? That is equal to 2kx, or we're talking about k equal to a by 4. That's when this will match. That means k square should be a square by 16. What do I mean by that? Suppose this were x square minus a by 2x plus a square by 16. This is x minus a by 4 the whole square. And I cannot just add on one side. So I'll add a square by 16 this side also, and then bring this plus 1 this side as minus 1. Or x minus a by 4 whole square is greater than a square by 16 minus 1. Now remember, this is always true. This will always be true only if this is negative or 0. And so this always holds good. That means this expression has to be negative or 0. X minus a by 4 whole square is greater than 4 will not always hold good. X minus a by 4 whole square is greater than minus 3 will always hold good. Or a square by 16 minus 1 should be less than 0. It cannot even be equal to 0. Because if this were equal to 0, then x minus a by 4 the whole square is always greater than 0. That won't hold good, because if x is a by 4, this will become 0. And this number should be negative. Or a square is less than 16. A is in the range minus 4 to plus 4. Fine. So we want the largest possible value of 2a minus 6b. So a has to be as high as possible. A cannot be 4, or a should be 3. So I'll jump in and do the same thing for b. X square minus bx plus 8 is greater than or equal to 0. Wonderful. This is greater than or equal to here. This is x square minus bx plus b square by 4 greater than or equal to b square by 4 minus 8. Why are we adding b square by 4? B square by 4 is b by 2 whole square. 2 times b by 2 is b. So this becomes x minus b by 2 whole square is greater than or equal to b square by 4 minus 32 by 4. Remember, this always holds good for all real values of x. That means b square should be less than or equal to 32. Here it is less than or equal to, but that doesn't matter because you're looking only at integers. That means b square can go from minus 5 to 5. But it's greater than 5, it will become 36. Minimum of 36. If it's less than minus 5, it will be minimum of 36 again. So minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. All of these will work. We want 2a minus 6b to be very high, or we want b to be very small. The smallest integer b can take is minus 5. 2 into 3 minus 6 into minus 5 is the largest possible value of 2a minus 6b. 6 plus 30, which is 36. The key takeaway here, the most important point here, is the idea of completion of squares. You might be given any quadratic equation, x square plus 5x plus 11. You should be able to write it as x plus a whole square plus b. find suitable A and B such that this becomes like this. Be it with numbers or variables, it doesn't matter. Any quadratic, you should be able to write it as a square plus a constant, an adjusting term. You should be able to do that. That is very vital. Add that to your list of skills today. Do it a lot of numbers. Anything, x square plus 23x minus 139. Write it as some x minus k the whole square plus m. Or if you have x square plus px plus q, write it as some x plus something the whole square plus an adjusting term. That skill is vital. A is 6 power 2n minus 35n minus 1, n equal to 1, 2, 3, and B is 35 times n minus 1, n is 1, 2, 3. And which of the following is true? Neither every element of A is in B, nor every member of B is in A. Every member of A is in B, and at least one member of B is not in A. Every member of B is in A, B is a subset of A. At least one member of A is not in B. Whereas A is not a subset of B. Right? This says A is a subset of B. Before we go further, I want to write down and see a few numbers. I want to put n equal to 1. So 6 square minus 35 minus 1, which is 0. We put n equal to 2. 6 power 4 minus 70 minus 1. N equal to 3. 6 power 6 minus 105 minus 1. There are going to be some numbers. I can already sense that A becomes larger and larger the more we put, because it goes 6 square, 6 power 4, 6 power 6, 6 power 8. A runs away from us, becomes bigger and bigger. And B, when n equal to 1, B is 35 times n minus 1. 35 times 0. B would be, B, the first element will be 0. When n is 2, it is 35 into 1, 35. When n is 3, 35 into 2, 70. B is more predictable. Every multiple of 35 from 0 onwards, every positive multiple is there in this set. Now, this question just opens up because of this. Neither every member of A is in B, nor every member of B is in A. Every member of B is in A. This is wrong. 70 is not in A. A is galloping away. At least one member of A is not in B. So all multiples of 35 are sitting here practically, including 0, all positive multiples. All we've got to think now is, are these numbers multiples of 35? That's all we need to think. And they have to be. Why so? Think about this. A is 6 power 2n minus 35n minus 1. I'm going to write it as 6 power 2n minus 1 minus 35n. This is 36 power n minus 1 power n minus 35n. 36 power n minus 1 power n will be a multiple of 36 minus 1. So every element in A is a multiple of 35. B lists all multiples of 35, including 0. So every element of A is in B. And at least one member of B is not in A. 70 is not in A. 105 not in A. A jumps across multiples of 35. After 0, it goes to a large number, and then a much larger number, and then a giant larger number. B lists every multiple of 35. So B is a superset. A is contained within that. There's A like this and B like this. Every element of A is in B, and at least one member of B is not in A. There are plenty of members in B. 1 by log 100 to the base 2 minus 1 by log 100 to the base 4 plus 1 by log 100 to the base 5. And all of this, I'm going to rephrase this. 1 by log A to the base B is log B to the base A. This is log 2 to the base 100 plus minus log 4 to the base 100 plus log 5 to the base 100, etc, etc, etc. Or, I'm not going to write everything down because I'm already sensing this. Log A minus log B is log of A by B. Everywhere the base is going to be 100, or we are looking at log of 2 into 1 by 4 plus 5 into 1 by 10 plus 20 into 1 by 25. Sorry, 2 into 1 by 4 into 5 into 1 by 10 into 20 into 1 by 25 into 50. 50 all to the base 100. 50 by 25 is 2. 20 by 10 is 2. 2 into 2 is 4, which disappears with this, or this is log 10 to the base 100, 1 by 2. Done. Very simple idea. Log a to the base b is 1 by log b to the base a. That's all we are using, nothing more than that. And log x minus log y is log of x by y. F of x is maximum of 5x and 52 minus 2x square. Maximum of this. So this is a curve, this is a curve, this is a maximum of this. The minimum possible will be the time when the two curves intersect. Or 5x equals 52 minus 2x square. 2x square plus 5x minus 52 equal to 0. 2x square plus 5x minus 52 is equal to 0. This is what we get. We need to factorize this. 2x square, 2 into 52 is 104, so 13 and 8. 2x square minus 8x plus 13x minus 52 equal to 0. 2x into x minus 4 plus 13 into x minus 4 is 0. Or x is either minus 13 by 2 or 4. And one of these two is the answer. There are 2 points this intersects, these two curves intersect. So let's put x is minus 13 by 2. So 5 times x is 5 into minus 13 by 2, which is minus 65 by 2. 52 minus 2 times 13 by 2 minus 13 by 2 the whole square, or this is 52 minus 2 into 169 by 4. This is 2. 52 minus 169 by 2, that should be minus 65 by 2. I need not have done all this. The two values are equal. So when x is minus 13 by 2, we get minus 65 by 2. That is f of x. When x is 4, 5 times x is 20. 52 minus 32 is 20. F of x will be 20. So when at 4 and minus 13 by 2, they are equal. At minus 13 by 2, the value of f of x is minus 65 by 2. That's the answer we are looking for. How many two-digit numbers with a non-zero digit in the units place are there, which are more than thrice the number formed by interchanging the positions of its digits? xy, yx. We're told this is not 0. This is definitely not 0. Otherwise, it won't be a two-digit number. The two-digit number xy is greater than 3 times the two-digit number yx, or 10x plus y is greater than 3 times 10y plus x. 10x plus y is greater than 30y plus 3x, or 7x is greater than 29y. X is greater than 29 by 7y. 29 by 7 is a little more than 4. So x is greater than 4y. Right. So we're looking at two digits where x is greater than 4y, little more than 4y. So we'll have to be little careful with the numbers. If you put y equal to 1, x greater than 4y, x could be 5. So we could have 51. One number being 51, other number being 15. 51 is greater than 3 times 15. This works. 61, 3 times 16. This will work. 71, 81, 91. All of these will work. Let's just check 41 as well. 41 and 14. 14 into 3 is 42. This doesn't work. These 5 numbers work. We could put y equal to 2. 4 times y is 8. 82 and 28. 82 and 28 does not work. 28 into 3 is 84. 92 and 29, that works. With y equal to 2, there's only one possibility. 92 greater than thrice 29. Y could be 3, but if y is 3, x should be more than 4y. That's not possible. Or there are 1, 2, 3, 4, 5, 6 numbers. This is what we are looking for. Find f of 10. F of x plus 2 is f of x plus f of 1. F of x plus 1. So we put for all positive integers x. F of 11 is 91. 15 is 617. We need to find f of 10. F of x plus 2 is f of x plus f of 1. So f of 1 plus f of 2 is f of 3. F of 2 plus f of 3 is f of 4. F of 3 plus f of 4 is f of 5. That's how this goes on. We know f of 11. So let's start with f of 11. F of 11 plus f of 12 is f of 13. F of 12 plus f of 13 is f of 14. F of 13 plus f of 14 equals f of 15. We know this is 91. Let's say this is x. This will be 91 plus x. This is x. This is 91 plus x. This is 91 plus 2x. This is 91 plus x. This is 91 plus 2x. Adds up to 617. Or 91 plus 91, 182 plus 3x is 617. 3x equals 617 minus 182, which is 5. 11 minus 8 is 3. 5 minus 1 is 4. 3x is 435. X is 435 by 3, which is 1, 4, 5. 145. So x is 145. We need to find f of 10. F of 10 plus f of 11 is f of 12. So this number plus 91 equals 145, or this number is 145 minus 91, which is 54. F of 10 should be 54. I'm going to do a very quick check. F of 10 is 54 plus 91 is 145. 91 plus 145. F of 11, F of 12 should add up to F of 13. 6, 3, 1, 236. 145 plus 236 should be 6 plus 5 is 11, 1, 1, 4 plus 4, 8, 2 plus 1, 3. 236 plus 381, 7, 1, 6, 17. This works. Obviously, we don't need to do this. In an exam point of view, we should be confident enough to mark 54 and then move on. I'm just doing this because we can verify. Nothing more than that. While multiplying three real numbers, let's say A, B, C, Ashok took one of the three numbers as 73 instead of 37. Say C, he takes as 73. He should have taken it as only 37. The product went up by 720. So AB into 37 is what he should have done. AB into 73 is what he did. The difference is 720. Or A into B into 36 is 720. A into B is 20. Then the minimum possible value of the sum of the squares of the other two numbers. So minimum possible value of A square plus B square. AB is 20. A square plus B square by 2 is greater than or equal to AB. Arithmetic mean of two numbers is greater than or equal to geometric mean. A square plus B square is greater than or equal to 2AB. Or A square plus B square is greater than or equal to 40. The minimum possible value of the sum of the squares is 40. A square plus B square has to be greater than or equal to 40. A square plus B square is greater than or equal to 2AB. This is because A minus B whole square is greater than or equal to 0. And wonderful question. First up, finding this 20 is easy. Product of two numbers is 20. Right? So it could be 1 and 20, 2 and 18, 2 and 10, and so on. And then we find A square plus B square. Right? So it will be best when they are root 20 and root 20. A square plus B square will be 20 plus 20, 40. The trial and error method, that is another way of thinking about this. Again, a wonderful question, very challenging question. Fine. So if x is a positive quantity such that 2 power x equals 3 power log 2 to the base 5. We're dealing with exponents and we're dealing with logs. One of my favorite tricks for question like this is take log on both sides. Log of 2 power x is log of 3 power log 2 to the base 5, or x log 2 is log 2 to the base 5 times log 3. We can choose any base and this rule will work. I'm going to choose the base as 3. Why so? Because log 3 to the base 3 is 1, or x times log 2 to the base 3 is log 2 to the base 5. Fine. Or x by log 3 to the base 2 is 1 by log 5 to the base 2. Or x is log 3 to the base 2 by log 5 to the base 2. In other words, our number x is log 3 to the base 5, which is not this, which is not this. It should be one of these two. Let's see this. Let us 1 plus log 3 to the base 5 minus log 5 to the base 5. This choice will become 1 plus log of x by y is log x minus log y. Log 3 to the base 5 minus log 5 to the base 5. This goes away. Log 3 to the base 5, which is what it should be. Choice B. Wonderful question. Very tough question. Very interesting question. The choice also is interestingly phrased. Key point, whenever you're given log and exponent, it helps to simplify by taking log on both sides. Once you have taken log on both sides, choose a suitable base. Find the right base in order to be able to simplify that. Wonderful question. Again, a very, very tough question. So let's discuss this seriously. So log 81 to the base 12 is p. Then 3 times 4 minus p by 4 plus p is equal to log 3 to the power 4 base 12 is p. 4 times log 3 to the base 12 is p, or log 3 to the base 12 is p by 4. A big question, because we've got something in terms of p. We can get p in terms of logarithms and then simplify. But this p by 4 is a very interesting number, because this can be written as 3 times 4 minus p by 4 by 4 plus p by 4, or 3 times 1 minus p by 4 by 1 plus p by 4. This is wonderful, because we know p by 4 is log 3 to the base 12. So this number becomes 3 times 1 minus log 3 to the base 12 by 1 plus log 3 to the base 12. So it's 3 times 1 minus log 3 to the base 12 is log 12 to the base 12 minus log 3 to the base 12 divided by log 12 to the base 12 plus log 3 to the base 12. This is 3 times log 4 to the base 12 by log 36 to the base 12, which is 3 times log 4 to the base 36, or it is log of 64 to the base 36. So it is not this, this is not this, it is one of these two. 64 to the base 36, is it 16 to the base 6 or 8 to the base 6? This is log of 8 square to the base 6 square, which is nothing but log 8 to the base 6. Very, very tough question. Got to manipulate this on multiple iterations. It is time consuming, and you've got to pick the right logic. So you need to be able to rephrase p, not just directly substitute p here and simplify. So it's got to be very careful with the computation. U square plus u minus 2v minus 1 the whole square equals minus 4vu plus v. It's a very tough question. When just u and v and only one equation and a quadratic thrown in for good measure. But if you look at the choices, these are all numbers. So there's something here that we need to crack. Right? So first up, let's expand this. A plus b plus c whole square is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. If you didn't know this also, we could have just multiplied it and got to the answer. This is not a deal breaker, right? So let's plug this in. The left hand side is u square plus u square plus 4v square plus 1. U into minus 2v is minus 2uv. So minus 4uv minus 2u plus 4v equals minus 4vu minus 4v square. So minus 4uv minus 4uv gets cancelled. So this is 2u square plus 4v square minus 2u plus 4v plus 4v square plus 1 equal to 0. I'm bringing everything onto the same side. And so now the interesting part here, straight away, the moment you see this and see the choices, you've got to have a sense of the method. The method here is completion of squares. Fine. Straight away, I've got to say I'm going to deal with two quadratic in some form, either a u plus v whole square or a u minus 2 plus v plus 2 the whole square. There's a uv term, you're dealing with u plus 2v or u minus 2v the whole square, something like that. There are no uv terms. The u's come together, the v's come together, and then we try to simplify. And that's important to kind of register that. Otherwise, it becomes an impossibly tough question. Right? Now think about this. So let's carve out the u together. So it is 2u square minus 2u. Let's carve out the v together. 8v square plus 4v. Added together, these add up to minus 1. Right? So 8v square is not anything square. Right? 2v the whole square is 4v square. U square is root 2u the whole square. So I'm going to take out a 2 from here and a 2 from here and then try to simplify this. So what have we got here? 2 times u square minus u plus 2 times 4v square plus 2v equals minus 1. Right? U square minus u is part of u minus 1 by 2 the whole square. U square minus half into 2 into u, which becomes u. So this is u square minus u plus 1 by 4. So there are plus 1 by 4 sitting inside. Then this becomes a nice square. I'm adding 1 by 4. So I should add 1 by 4 this side as well. It's not just 1 by 4, it's 1 by 4 into 2. So I'm adding that 1 by 2 here. Exact same funda here. We have 4v, that is 2v plus something, the whole square is 4v square plus 2v plus something. 2v into 1 is 2v. So 2ab term will have 4v. We have only a 2v here. So this should be plus 1 by 2 to have a 2v term here. Once again, we are adding 1 by 4. 1 by 4 inside like this. That means it's a half. I add a half. Wonderful. I completely relish the fact that this boils down to 0. You'll see why. This is nothing but 2 times u minus half the whole square plus 2 times 2v plus half the whole square equal to 0. Something square plus something square is 0. A square cannot be negative. That means this is equal to 0. This is equal to 0. Or u is half. V is minus 1 by 4. 2v is minus half. V is minus 1 by 4. So we want to find u plus 3v, that is 1 by 2 minus 3 by 4, which is minus 1 by 4, which is this value. Absolutely wonderful question. First up, we'll need to expand and simplify. Bring everything to one side equal to 0. Pick the idea that we're dealing with completion of squares. Whenever you're dealing with quadratic, the completion of squares idea should be there at the back of your mind. Right? So anytime you have quadratic expressions, there are only two tricks, major tricks in your rule bag. First one is factorizing. . 2nd one is completion of squares. . 3rd one is factorizing. 4th one is completion of squares. 5th one is completion of squares. 6th one is factorizing. 7th one is completion of squares. 8th one is completion of squares. 9th one is completion of squares. 10th one is completion of squares. 11th one is completion of squares. 12th one is completion of squares. 13th one is completion of squares. 14th one is completion of squares. 15th one is completion of squares. 16th one is completion of squares. 17th one is completion of squares. 18th one is completion of squares. 19th one is completion of squares. 20th one is completion of squares. 21st one is completion of squares. 22nd one is completion of squares. 23rd one is completion of squares. 24th one is completion of squares. 25th one is completion of squares. 26th one is completion of squares. 27th one is completion of squares. one of these two will come of use generally. If you cannot square factorize, look to complete the squares. And so if we complete the squares, this giant expression is nothing but this. And then you're through. Incredibly tough question. You're probably better advised skipping this question in the exam, which is something I did not do. I spent time trying to crack it. I knew fully well I was looking for something like this. Messed up my algebra, so didn't get it, and then lost a lot of time. Otherwise, wonderful question. Let x, y, z be three positive real numbers in geometric progression. Lovely. Positive real numbers. That usually simplifies questions. In a geometric progression such that x less than y less than z. Y by x equals z by y. Xz equals y square. This is a common ratio. 5x, 16y and 12z are in arithmetic progression. So 5x, 16y, 12z. 16y minus 5x equals 12z minus 16y. 16y plus 16y equals 12z plus 5x. 32y equals 12z plus 5x. Now we need to find the common ratio. So I'm going to assume the common ratio to be r. If assuming the numbers as x, xr and xr square, I'm going to anchor around y. So the first term would be y by r. Second term, the third term would be yr. X is y by r, z is yr. So we can simplify this. We can say 32y equals 12yr plus 5y by r. Cancelling y, we'll get 32 equals 12r plus 5 by r. Multiply by r, 32r equals 12r square plus 5. 12r square minus 32r plus 5 equal to 0. 12r square minus 30r minus 2r plus 5 equal to 0. 6r into 2r minus 5 minus 1 into 2r minus 5 is 0. 6r minus 1 into 2r minus 5 equals 0. R is either 1 by 6 or 5 by 2. Now this comes into the picture finally. X less than y less than z. So it's an increasing GB. So the terms become larger and larger. That means the common ratio should be greater than 1 because we're dealing with positive real numbers. A positive real number multiplied by a number greater than 1 will become bigger. If it is multiplied by a number less than 1, it will become smaller. Right, so x less than y less than z, that tells that the common ratio is not 1 by 6 but 5. F of x equal to minimum of 2x square and 52 minus 5x, where x is any positive real number. And the maximum possible value of f of x. F of x is minimum of these two. We want to find maximum value of f of x. Simplest way to do it is to equate this. 2x square equals 52 minus 5x. 2x square plus 52 2x square plus 5x minus 52 is 0. 2 into 52 is 104. This is 2x square minus 8x plus 13x minus 52 is 0. 2x into x minus 4 plus 13 into x minus 4 is 0. 2x plus 13 into x minus 4 is 0. X is some minus 13 by 2 or x is 4. Talking about positive real number, x should be 4. Substitute that. You're talking about x as being minimum value of 2 into 4 square, comma 52 minus 5 into 4. This is 32. This is 32. Or the value we are looking for is 32. Now think about this. I'm going to dive deeper into this minimum idea. 2x square is a graph like this. 52 minus 5x is a line like this. So if f of x is a minimum of these two, we're talking only positive territory, so we completely forget this. F of x would be like this till this point, and then take this. It'll take one arc till a point, and then the other arc after that. This will be the maximum value f of x can take, which is why we find a meeting point of the two arcs. Another fabulous question and very tough question. Another question that I tried during the exam and did not get right and spent a lot of time kind of doing some utterly random stuff. X power 2018 into y power 2017 is 1 by 2. X power 2016 into y power 2019 is 8. Whenever you have equations of form 2x plus y, 2x minus 5y, stuff like that, then adding or subtracting equations works. Whenever dealing with x square into y cube, x by y, then multiplying or dividing works better. So either we multiply these two equations or we divide one by the other. So the powers get added, that makes life simpler. If we multiply these two, it will become x power 4034 and y power 4036. Two different parts. I don't like that. Suppose we divide one by the other, this becomes x square by y square. Both same part. That is lovely. So let's divide one by the other. X square by y square equals 1 by 16. X plus y, the whole square, is 1 by 16. X by y is 1 by 4. For a second, I'm going to pretend that minus 1 by 4 is not possible, and then worry about that later on. When x by y is 1 by 4. Now, simplifying, this gives us y equals 4x. Now let's substitute that in one of the two equations. Let's substitute in the second one. X power 2016 into 4x power 2019 is 8. X power 2016 into x power 2019 into 4 power 2019 is 2 cube. Getting this 2 cube, I'm going to write this as 2 square. X power 2035 into 4035 into 2 power 4038 is 2 cube. Lovely. But this has an x power 4035. If I take this side, we'll get x power 4035 equals 2 power minus 4035, or x equals 1 by 2. Y is 4 times this, or y is 2. X square plus y cube is what we need to find. X square plus y cube. So x square is 1 by 2 whole square, which is 1 by 4. Y cube is 2 cube, which is 8. 8 plus 1 by 4. 32 by 4 plus 1 by 4. 33 by 4. Now for the negative part, we know that x power 2018 is positive. X power 2016 is positive. So y has to be positive. But x could have been technically plus half or minus half. Remember, we're not dealing with x, we're dealing with x square, so it doesn't really matter. This will continue. This is a and b and log, and we want to find a plus b. Just seemingly tough question, but it's not so. This is a very simple, very nice question. We need to know that log p to the base q is r. Log of something to the base 2 is 3, or that something is 2 cube, which is 8, or log a to the base 3 is 8 minus 5, which is 3, or a is 3 into 3, which is 27. Likewise, for this part, log something to the base 5 is 3, or that something 4a plus 12 plus log b to the base 2 is 5 cube, which is 125. 4a is 27 into 4. 27 into 4 is 108. 108 plus 12 is 120, plus log b to the base 2 is 125, or log b to the base 2 is 5. Sorry, log b to the base 2 is 5. B is 2 power 5, which is 32. A is 27, b is 32. A plus b is 27 plus 32, 59. A1, A2, A3 are all in AP. What is this equal to? Wonderful. This is a classic question where we rationalize the denominator. 1 by square root of A1 plus square root of A2 into root of A2 minus root of A1 by root of A2 minus root of A1. Why am I writing it as A2 minus A1? Because I know A2 minus A1 is D, the common difference. Wonderful. So this is square root of A2 minus square root of A1 by A2 minus A1 plus square root of A3 minus square root of A2 by A3 minus A2, all the way till square root of an plus 1 minus square root of a1 by an plus 1 minus an. Brilliant. This denominator is equal to common difference. So we have 1 by common difference into a2, root a2 minus root a1 plus root a3 minus root a2 all the way till here. This gets cancelled with this. This will get cancelled with something all the way till here. So we'll have 1 by d into square root of an plus 1 minus square root of a1. But we don't have d. So what do we do? How do we simplify this? We need to find a common difference. Now an plus 1 is a1 plus n times d. We add common difference n times, will go from here to here. So an plus 1 minus a1 equals nd, or d equals an plus 1 minus a1 by n. We want 1 by d is n by an plus 1 minus a1, or our expression is square root of an plus 1 minus square root of a1 into n by an plus 1 minus a1. This by this, again an plus 1 minus a1 can be written as square root of an plus 1 plus square root of a1 into square root of an plus 1 minus square root of a1. So this part will get cancelled with this one, or we'll get n by square root of an plus 1 plus square root of a1. N by square root of an plus 1 plus square root of a1. Just this answer. Choice A. Consider the function f of x plus y equals f of x into f of y, where x and y are positive integers. F of 1 equals 2. F of a plus 1 plus f of a plus 2 plus f all the way till f of a plus n is 16 into 2 power n minus 1. F of a plus 1 equals f of a into f of 1. F of a plus 1 is f of a into 2. F of a plus 2 is f of a plus 1 into f of 1, which is f of a into 2 into 2. Oh, brilliant. We've got this. F of a plus 1 is f of a into 2. F of a plus 2 is f of a into 2 square. F of a plus 3 is f of a into 2 cube. F of a plus n is f of a into 2 power n. So what are we adding? We're adding f of a into 2 plus 2 square plus 2 cube all the way to 2 power n, or 2 times f of a into 1 plus 2 plus 2 square all the way to 2 power n minus 1. This is a GP. First term is 1, common ratio is 2, number of terms is n, product is a into r power n minus 1 by r minus 1. R minus 1 is 1. 2 times f of a into 2 power n minus 1. 2 power n minus 1. 2 times f of a into 2 power n minus 1. This is 16 times 2 power n minus 1, or f of a is 8. F of 1 is 2. F of 2 is f of 1 into f of 1, 4. F of 3 is f of 2 into f of 1, 8. Or f of 3 is 8. A is 3. Wonderful question. First you have to identify that this effectively becomes a geometric progression. Then simplify and find f of a. And know that f of 1 is 2, f of 2 is 4, f of 3 is 8. That is the sequence we're talking about. F of a is 8, or a should be 3. .55 to the power x equals 0.555 to the power of y equals 1000. It's an absolutely wonderful question from exponential and logarithms. 1 by x minus 1 by y. What is this? Fine. I tried and struggled in this exam and didn't get it right. It took me a long time and I didn't get it and I got lost. I should have probably been better at handling this. And how do we do this? There's a 1 by x and a 1 by y. That should be a giveaway. Dealing with x, I want to deal with 1 by x. How do I simplify? 5.55 is 1000 to the power 1 by x. 0.555 is 1000 to the power 1 by y. The moment you rewrite it like this, you're through. How are we through? Divide one by the other. This is 10. So 5.55 by 0.555 is 10. This equals 1000 to the power 1 by x minus 1 by y. A power x minus a power y is a power x minus y. The same idea here. Brilliant. We are through. 1000 power 1 by x minus 1 by y is 10. What is 10? 10 is 1000 to the power 1 by 3. This is 1000 to the power 1 by x minus 1 by y, or 1 by x minus 1 by y is 1 by 3. Did all kinds of complicated logarithm stuff. The key to unlocking this, my question is asking for 1 by x and 1 by y. Don't somehow contrive to form 1 by x and 1 by y. You have to have a root to 1 by x instead of dealing with x. If you simplify this and say x, y minus x by x, y and all that becomes complicated. Try to find x, try y, complicated. My answer is calling out for 1 by x. So I want to see 1 by x somewhere. I want to write an equation where the 1 by x is seen and then you're through. Let x and y be positive real numbers. Positive real numbers. I really missed this one. In the exam, I missed out on this one funda. I don't think in this question, but something else. And then I got it wrong. Log x plus y to the base 5, x minus y to the base 5 is 3. X plus y into x minus y. So this is log of x square minus y square to the base 5 is 3. Or x square minus y square is 5 cube, which is 125. Log y to the base 2 minus log x to the base 2. That is log of y by x to the base 2 equals 1 minus log 3 to the base 2, which is log 2 to the base 2 minus log 3 to the base 2. Log y by x to the base 2 is log 2 by 3 to the base 2, or y by x is 2 by 3. Wonderful. We have x square minus y square is 125. Y by x is equal to 2 by 3. So x is 3 by 2 y. And so substitute that 3 by 2 y whole square minus y square is 125. So it's 9 by 4 y square minus 4 by 4 y square is 125. 5 by 4 y square is 125. 125 by 5 is 25. Y square is 100. Y is 10. Wonderful. Y is 10. Y cannot be minus 10. Therefore, we know that 5 by 4 into y square is 25. Y is 10. We know that x is 3 by 2 y, or x is 15. X into y is 15 into 10, which is 150. Key things here, using the product formula to simplify this, writing this 1 as log 2 to the base 2. With this, we'll get x square minus y square is something. The second one gives us x in terms of y or y in terms of x. Simplify and find out. We are through. A regular question should be solved. I got this one wrong. I got this one so wrong that it was embarrassing. Fine, so I'm going to do this. I'm going to say mod x into 6x square plus 1 is 5x square. We have mod x and x. Remember, mod x whole square is the same as x square. I'm going to say mod x equal to y. So I call this as y. 6y square plus 1 equals 5y square. X square is mod x a whole square. So this way we can cancel a y. 6y square plus 1 is 5y. 6y square minus 5y plus 1 equal to 0. Number of solutions. Brilliant. We break this. 6y square minus 5y plus 1. 6y square minus 3y minus 2y plus 1. So it is 3y into 2y minus 1 into 2y minus 1 is 0. 3y minus 1 into 2y minus 1 equals 0. Y is 1 by 3 or 1 by 2. Brilliant. Now y is mod x. So x could be 1 by 3 or minus 1 by 3. 1 by 2 or minus 1 by 2. All of these will work. So there are 4 values for this. Brilliant. Theta is 4 and I did this and I got a minus 1. Why? Because at step 1 we have cancelled this y. We're cancelling y on both sides. So y equal to 0 will work. Y is 0, x is 0. X is 0 is a trivial solution. You can look at this and say, put x equal to 0, both sides go to 0. So there are not 4 solutions, 5 solutions. Every time you cancel on both sides, you've got to keep in mind that you simply cannot cancel 0 on both sides. That means you cancel, you're saying this cannot be 0. So you have to worry about the time where it becomes 0 and then account for that solution. So x is 1 by 3 minus 1 by 3, 1 by 2 minus 1 by 2 and 0. 5 possible values exist. a1 plus a2 plus a3 all the way till an is 3 times 2 power n plus 1 minus 2 for every n greater than or equal to 1 and a11 equal. Let's find a1. Be 3 times 2 square minus 2. 3 times 4 minus 2, 2 which is 6. Let's do a1 plus a2. That's 3 times, putting n as 2, 2 cube minus 2, which is 3 times 8 minus 2, 6, which is 18, or a2 is 12. Let's do a1 plus a2 plus a3. This is 3 times 2 power 4 minus 2, 16 minus 2, 14, 3 times 14, which is 42. a3 is 42 minus 18 minus 6, 42 minus 18 minus 6, 42 minus 24. Sorry, this is a1 plus a2. 42 minus 18. 6, a1 and a2 are 6 and 12. a1 is 6, a2 is 12. Add these two, we get 18. a3 is 42 minus 18, 24. You can clearly see the pattern. a4 will be 48. a5 will be 96. This is 3 into 2 power 5. 3 into 2 power 4, 3 into 2 cube. a11 is 3 into 2 power 11. a1 is 3 into 2 power 1. a2 is 3 into 2 square. a11 is 3 into 2 power 11. 2 power 10 is 1024. 2 power 11 is 2048. 48 into 3 is 144. 6144. The other more mathematical way of doing it, a1 plus a2 all the way till an is 3 into 2 power n plus 1 minus 2. a1 plus a2 all the way till an minus 1 is 3 into 2 power n minus 2. Subtract one from the other, all of these disappear. We have only an, which is 3 into 2 power n plus 1 minus 6 minus 3 into 2 power n plus 6. This is 3 into 2 power n plus 1 minus 3 into 2 power n, but 3 into 2 power n into 2 minus 1, which is 3 into 2 power n, which is exactly what we got by filling in a few numbers. Population of towns. It's a delightful question, very tough one. I kind of went from answer choices and fudged and got to the answer in the exam. So I'm not going to do that. I'm going to try to solve this algebraically. And so assume that we don't have these wonderful choices. The choices are present. This question becomes very simple. And I'm going to assume this is not present. Then type in and try solving this. The population of a town is P in the beginning of any year. Then it becomes 3 plus 2P in the beginning of the next year. The population at the beginning of 2019 is 1000. Then the population at the beginning of 2034 will be 2019 is P. 2020 will be 2P plus 3. 2021 would be 2 into 2P plus 3 plus 3. 2022 would be 2 into 2p plus 3 times 2 plus 3 plus 3, and then so on. I'm going to expand this. This is 2p plus 3. This is 4p plus 9. This is 4p plus 9 into 2, which is 8p plus 18 plus 3, 21. So next term would be 16p plus 45. Term after that will be 32p plus 93, and so on. This into 2 plus 3. Fine, so it's a nice, interesting question. The first pattern we notice is this goes as 2p, 4p, 8p, 16p, 32p. That part is simple. Fine, very nice, very simple. Fine, so this is going to be 2 power 1 into p, 2 square into p, 2 cube into p, 2 power 4 into p, 2 power 5 into p, so on. From 2090 to 2034, there are 15 years, 15 jumps. So finally, we've got to have a 2 power 15 into p. In our case, p is 1000. We'll worry about that. Plug that in the end. And that part we have solved. Next part, this is 3. It becomes 9. Why 9? 3 into 2 plus 3. Right? Now, what does it become? The next step, it becomes 3 into 2 into 2 plus 3 into 2 plus 3. Think about this. This 21, how does it come about? That is 3 plus 3 into 2 plus 3 into 2 square. This one will be 3 plus 3 into 2 plus 3 into 2 square plus 3 into 2 cube. Or if I extract a 3 outside, with 1 plus 2 plus 2 square. This one, if you this 9, 3 outside, 1 plus 2. We're getting somewhere here. There's a geometric progression sitting here, a beautiful geometric progression. In year 1, we just have 3 into 1. In year 2, we have 3 into 1 plus 2. In year 3, we have 3 into 1 plus 2 plus 2 square. Next, we'll have 3 into 1 plus 2 square plus 2 cube. Or, we keep on doing this. This is year 1, year 2, year 3, and so on. Finally, what will you get? Think about this. In year 3, there are 3 terms. 1 plus 2 plus 2 square. In year 15, there will be 15 terms. 3 into 1 plus 2 plus 2 square. All the way till 2 power 14. This we know it is 3 into 2 power 15 minus 1 by 2 minus 1, which is nothing. Or the total population would be 2 power 15 into p plus 3 into 2 power 15 minus 1. Or 2 power 15 into p plus 3 minus 3. P is 1000. So 2 power 15 into 1003 minus 3. This one. Going from answer choices is far simpler. We see there's a progression sitting in. We know there is 15 years. We know this 2 power 15 has to sit somewhere. This is out. This is out. This is the answer. Going from answer choices, this is very simple. But look, in the exam context, you can do answer choices. But for learning, it's better to see the textbook method. Because the next time the idea will come up. The product of the distinct roots of x square minus 6 equals x plus 2. X square minus x minus 6. So this could be x square minus x minus 6 equals x plus 2. Or minus of x square minus x minus 6 equals x plus 2. Two possible solutions. In this case, x square minus x minus 6 should be greater than 0. In this case, x square minus x minus 6 should be less than 0. First, let's solve. Then we'll worry about the roots part later on. It becomes x square minus 2x minus 8 equal to 0. This is x minus 4 into x plus 2 equal to 0. X is 4 or minus 2. Fine. When x is 4, x square minus x minus 2 is 16 minus 4 minus 6. X square minus x minus 6. 16 minus 4 minus 6, which is 6. X equal to 4 works. X equal to minus 2. Minus 2 whole square minus of minus 2 minus 6. So 4 plus 2 minus 6 is 0. this side is 0, x equal to minus 2 also works. This side, minus x square plus x plus 6 equals x plus 2. It gets knocked off. Minus of x square is 2 minus 6 equals minus 4. X square is 4. X is plus or minus 2. Minus 2 works. We need to think whether plus 2 would work. Best way to plug it in is to plug it in the equation. 2 square minus 2 minus 6. Modulus of 4 minus 2 minus 6. Modulus of 4 minus 8. Modulus of minus 4, which is 4. This side is 2 plus 2, which is 4. So x equal to 2 also works. X equal to 4 work. X equal to minus 2 work. X equal to 2 works. So product of the distinct roots, 4 into minus 2 into 2, minus 2 into 2, minus 16. Once again, I made the mistake in this one. I completely forgot that this solution was possible, messed it up and got a wrong answer. So don't rush through, solve it methodically. What I did is factorize this. I made it as modulus of x minus 3 into x plus 2 equal to x plus 2. Then cancel this and said modulus of x minus 3 should be 0. And then went nowhere with it. Fine, so x square minus x minus 6. Solve it methodically. Don't be in a hurry to cancel stuff off. So modulus of x minus 3 should be 1. Then got 2 roots and I completely forgot what I was cancelling, got into trouble. Fine, so don't cancel a number and a modulus. Don't worry. Don't ignore that when you're cancelling something, that root disappears. X plus 2, if you're cancelling on both sides, that means you're not worrying sufficiently about x plus 2 being 0. And that is a possibility here. And that's what I forgot. I forgot that if you're cancelling x plus 2 on both sides, you have to account for the fact that x plus 2 can be 0. That could work. So x equal to minus 2 is a very important solution, which I glossed over. Don't. Real roots. The number of real roots of the equation 2 cos x times x plus 1 is 2 power x plus 2 power minus x. Wonderful, wonderful, wonderful. To start with, I'm going to not think of this as an equation. Think of it as a left-hand side and a right-hand side separately. Should know this. 2 power x plus 2 power minus x is like y plus 1 by y. 2 power x is y, 2 power minus x will be 1 by y. Now, any expression, the form y plus 1 by y, is either greater than or equal to 2, or y plus 1 by y is less than or equal to minus 2. Think about it. 3 plus 1 by 3, 5 plus 1 by 5, root 2 plus 1 by root 2. Y plus 1 by y will be 2 when y is 1. Y plus 1 by y will be minus 2 when y is minus 1. Here 2 power x cannot be negative. So this part we don't have to worry about. So we can say 2 power x plus 2 power minus x is greater than or equal to 2. Wonderful. Now 2 cos anything is less than or equal to 2. Cos of something is less than or equal to 1. 2 cos anything is less than or equal to 2. Wonderful. So we've got this completely nailed on. This part has to be less than or equal to 2. This part has to be greater than or equal to 2. When is it possible? When this is equal to 2, this is equal to 2. So 2 power x plus 2 power minus x. When will it be equal to 2? When x is 1 or minus 1. When x is 1, this will be 2. Sorry. When 2 power x is 1, not x is 1. When 2 power x is 1 or when x is 0. 1 plus 1 is 2, not x is 1. When x is 1, it becomes 2 plus 1 by 2. When x is minus 1, it becomes 1 by 2 plus 2. That doesn't work. X has to be 0. 2 power 0 plus 2 power 0 is 2. Right? So x equal to 0 works. Now let's go to the cos part. 2 cos 0 into 0 plus 1 is 2 cos 0, which is 2 times 1, which is 2. Now this will be 1 even when x is minus 1. But when x is minus 1, this part won't be equal to 2. 2 cos minus 1 into minus 1 plus 1 is also 2. That is fine. But 2 power minus 1 plus 2 power minus of minus 1 is 5 by 2, not 2. So only one value works. The value that x is equal to 0. M and n are integers. Again, very delicious question. But if you know exponents, you're walking through this. Straight away, I'm going to look at this question and say, okay, I'm going to compare powers of 2, powers of 3. That's it, 2 and 3. And then put them together. So square root of 2 power 19 is 2 power 1 by 2 whole power 19 into 3 power 4 into 4 square is 2 power 4. 9 power m is 3 power 2m. 3 square power m into 8 power n is 2 power 3n equals 3 power n 2 power 4 whole power m into 2 power 6 whole power 1 by 4. 2 power 19 by 2 into 2 power 4 into 2 power 3n into 3 power 2m plus 4 equals 3 power n into 2 power 4m into 2 power 6 by 4, which is 3 by 2. 3 by 2, 19 by 2, divide this by this. 19 by 2 minus 3 by 2, 16 by 2, which is 8. So 2 power 8 into 2 power 4 into 2 power 3n into 3 power 2m plus 4 is 3 power n. This is 2 power 12. So 2 power into 4 power into 2 power 4m, just to complete it. 2 power 3n plus 12 into 3 power 2m plus 4 is 3 power n into 2 power 4m. 2m plus 4 is n. 3n plus 12 is 4m. Let me write this again. 2m plus 4 is n. 3n plus 12 is 4m. We want to find m, substitute n in terms of m. 3 times 2m plus 4 plus 12 is 4m. 6m plus 24 equals 4m. 24 equals 4m minus 6m, which is minus 2m, or m is minus 12. Just methodically combine powers of 2, powers of 3, put them together, and then simplify. It's a routine question. You should be nailing this in the exam. For any positive integer n, f of n is n into n plus 1 if n is even. So f of 2 is 2 into 3, 6. And f of n is n plus 3 if n is odd. F of 1 is 4. 8 times f of m plus 1 minus f of m equal to 2. Now, if this will vary, the equation will vary based on whether m were an odd integer or an even integer. So I'm going to break it into 2. M is even, m is odd. If m were even, f of m would be m into m plus 1. F of m plus 1 would be m plus 4. 8 times m plus 4 minus m into m plus 1 equal to 2. If m were odd, then m plus 1 is even. 8 times m plus 1 into m plus 2 minus of m plus 3. If m is odd, f of m is m plus 3. 8 times f of m plus 1. F of m plus 1 will be m plus 1 into m plus 2. 8 times this minus of m plus 3. This is equal to 2. Now, a little bit of a gut feel. The product of two numbers. M is odd. The product of two numbers will be 1 into 3. M is odd. It means the smallest value it can take is 2 into 3. 8 into 2 into 3 minus 1 plus 3, 4. This is way more than 2. This is the product of two conjugated numbers that will keep on going bigger and bigger vis-a-vis this. So gut feel tells me that this is not going to work out. This will probably work out. 8m plus 32 minus m square minus m equals 2. 8m minus m is 7m. 32 minus 2 is 30. Minus m square is 0. or m square minus 7m minus 30 is 0. M minus 10 into m plus 3 is 0. M is 10 or minus 3, 10 works. Further, 10 works for the assumption that m is even. Otherwise, you would have had to worry about that. When m is even is when this is coming true. So m is even and m is 10. That works. So m equal to 10 works. So 10 is the even number for which this will be satisfied. M equals 10. We don't have to simplify for the other number. If 2n plus 1 plus 2n plus 3 plus 2n plus 5 all the way till 2n plus 47 is 5280. And so isolate this, we're done. 2n plus 2n plus 2n. You're going from 1 to 47 but counting only odd numbers. There are 24 terms. Plus 1 plus 3 plus 5 plus 7 all the way till 47. 24 terms. This is 2 minus 1, 4 minus 1, 6 minus 1, 8 minus 1, 48 minus 1. Each term is an even number minus 1. This is 24 into 2 minus 1. 24 terms equals 5280. Odd numbers, the first 24 odd numbers will add up to 24 square. 1 plus 3 plus 5 is 3 square. 1 plus 3 plus 5 plus 7 is 4 square. 1 plus 3 is 2 square. And so, or 2n into 24 equals 5280 minus 24 square. This will be a multiple of 24. Let's cancel out 124. 2n equals 5280 by 24 goes 2 times 48 is 2 times 228 minus 24, or n equals 110 minus 12. 110 minus 12 is 98. 1 plus 2 plus 3 plus 4 till n is n into n plus 1 by 2. 98 into 99 by 2. 99 into 49, whatever that turns out to be. 9 9s are 81, 1 8, 9 4s are 36 plus 8. 441, 441, 1 5, 4851. When you're just breaking this, keeping the 2n terms separate, keeping the 1 3 5 terms, the sum of first n natural numbers is n square. It's totally worthwhile remembering that. So we subtract that 24 square from this, equated to 2n into 24. And then let a be a real number. The roots of the equation x square minus 4x minus log a to the base 2 equal to 0 are real and distinct. Real and distinct if discriminant is greater than 0. Discriminant is b square minus 4ac. So minus 4 the whole square minus 4 into 1 into minus log a to the base 2 is greater than 0. 16 plus 4 times log a to the base 2 is greater than 0, or 4 plus log a to the base 2 is greater than 0. Log a to the base 2 is greater than minus 4. If log a to the base 2 were equal to minus 4, a would be equal to 1 by 2 power 4, which is 1 by 16. Log a to the base 2 is greater than this, or log a to the a should be greater than 1 by 16. a1, a2 be integers such that a1 minus a2 plus a3 minus a4 all the way till an is n for n greater than or equal to 1. These kind of questions become wonderful. You say a1 is 1, a1 minus a2 is 2, a1 minus a2 plus a3 is 3. a1 is 1, 1 minus a2 is 2, or a2 is minus 1. 1 minus a2 is 2. a2 is 1 minus 2, which is minus 1. Till here adds up to 2. Once you put this, it is 3. This is 2. You add this, you get 3. That means a3 is 1. Till this is 3. 3 minus a4 is 4, or a4 is minus 1. Very simple pattern. This is just 1 minus 1, 1 minus 1, 1 minus 1. Odd number terms are plus 1. Even number terms are minus 1. And now let's come to the question. A51, 52, 53, all the way till A1023. A51 is 1, minus 1, 1, minus 1, 1, minus 1. Finally ending with a plus 1 because A1023 is an odd numbered term. We need to add all of this. In pairs, they'll get knocked off. The final plus 1 will remain, or the total is plus 1. A51 to A1023, there are an odd number of terms. So there is one more odd term than even term. Each odd term will cancel with each even term. The extra odd term is going to be 1. So the total is 1. F of mn equals f of m into f of n for every positive integer m and n. If f of 1, f of 2 and f of 3 are positive integers, f of 1 is less than f of 2 and f of 24 equals 54. Wonderful. F of 1 is less than f of 2. F of 2 equals f of 2 into f of 1. Either f of this tells us that f of 2 minus f of 2 times f of 1 is 0, or f of 2 into 1 minus f of 1 is 0. Either f of 1 is 1 or f of 2 is 0. If f of 2 were 0, then everything would become 0. Then f of 1 and f of 2 would be equal. That's not possible. So f of 1 is 1. They're positive integers. So f of 2 is greater than 1. That much we know. And it's a positive integer greater than 1. Right? F of 24 is 54. This is f of 3 into f of 8, or f of 3 into f of 2 into f of 4, or this is f of 3 into f of 2 whole cube. This is 54. F of 2 is a positive integer greater than 1, or f of 2 is 2. F of 2 is 3. 54 is 2 into 3 cube. Quite simply, from this we know that f of 2 is 3, f of 3 is 2, f of 1 is 1. F of 18 equals f of 2 into f of 3 whole square. 2 into 3 into 3, which is 3 into 2 square, which is 12. 5 power x minus 3 power y is 13438. 5 power x minus 1 plus 3 power y plus 1 is 9686. When there's 5 power x, there's 5 power x minus 1. So I'm going to say let 5 power x minus 1 equals k. There's 3 power y plus 1. Let 3 power y equals m. This is 5k minus m equals 13438. This k plus 3m equals 9686. Brilliant. Multiply this by 3. We get 15k plus minus 3m equals 1348438 into 3. 3 8s are 24, 4 2, 9 plus 2 11, 1 1, 12 plus 1 13, 3 1, 9 plus 1 10, 0 1, 3 plus 1 4. Fine. Now we add these two, we'll get 16k equals 6 plus 4 10, 0 1, 9 plus 1 10, 0 1, 7 plus 3 10, 0 1, 9 plus 1 10, 0 1, 50,000. 16k is 50,000. 50000. We can divide this by 16 wonderfully. 10,000 by 16. This is 10 power 4 by 2 power 4 is 5 power 4, 625. Or k is 625 into 5. This is 3 power 5. 5 power, sorry, this is 5 power 5. 5 power x minus 1 equals k, or x is 6. Brilliant, we have found x. Now we still need to find y. So that let's take this equation. K plus 3m is 9686. X is 6. 5 power x minus 1 is k. So 5 power 5. 5 power 5 plus 3m is 9686. 3m equals 9686 minus 3125. 6 minus 5 is 1. 8 minus 2 is 6. 6 minus 1 is 5. 9 minus 6. 6561 is 3m, or m equals, dividing this by 3, 2, 1, 26 is 8, 2, 1, 8, 7. 3 power 1 is 3, 3 square is 9, 3 cube is 27, 3 power 4 is 81, 3 power 5 is 243, 3 power 6 is 729, 3 power 7 is 2187. M is 3 power y. 3 power y is 2187, or y is 7. We got x to be 6. X is 6, y is 7. X plus y is 13. I struggled long and hard for this question. For a long time I struggled with this question. It's a beautiful question. A square plus b square is 25. X square plus y square is 169. Ax plus by is 65. What is ay minus bx? Right? Looking at the choices, greater than 5 by 13, there's a subtraction thing here. Right? Generally, a and b are symmetric, x and y are symmetric. That means you swap x and y values, a and b values, everything should hold good. And that's what this is telling us. Correspondingly hold good. What that means, you cannot say it is greater than 5 by 13 because there's a subtraction involved here. And so this looks dicey to me. This looks very possible. These two also look reasonable. But we need to find some smart way of figuring this out. How do we do that? There's going to be some form of comparing a square plus b square with 2ab involved. A square plus b square minus 2ab, a square plus b square plus 2ab, something like that. Right, so now think about this. This is 5 square. This is 13 square. This is 5 into 13, the whole square. If I square this and multiply these two, I should be with the same. A square plus b square into x square plus y square is equal to ax plus by whole square. Not algebraically. This is 25, this is 169, this is 65 square. Numerically, in this particular question, I'm not saying algebraically they are same. In this particular question, if you multiply these two, you should get this square. Right? There's something special about that 65. That is 5 into 13. So if we expand this, we get a square x square plus a square y square plus b square x square plus b square y square equal to a square y square plus a square x square plus b square y square plus 2ax by. This gets knocked off with this. This gets knocked off with this. A square y square plus b square x square equals 2ax by. It's a wonderful expression, especially if you write it like this. A square y square plus b square x square minus 2abxy or axby is equal to 0. Make sense of this and then we are through. Can you make sense of this? Can you think about this and make sense of this? This is nothing that but ay minus bx the whole square. Ay minus bx the whole square is equal to 0, or ay minus bx is equal to 0, k is equal to 0. Delightful question. It was very, very, very tough question. You need like lots of comfort with algebra. But the key thing here, you're given a 5 square and a 13 square and a 5 into 13 here. Therefore, we might be able to do something with that. Right? So keep that in mind. Be switched on about it, but otherwise a very tough question. I took a long time to crack this. Totally not worth doing in the exam. The way I mulled around and fooled around and got lost in algebra, all that I did a square plus b square greater than or equal to 2ab, x square plus y square greater than or equal to 2xy. I squared this, I multiplied this and this for some reason. Didn't go anywhere with all that. Then came around to this method. The real roots of the equation, 2 power 6x plus 2 power 3x plus 2 minus 21 equal to 0. All of these questions, idea is to convert this into a quadratic. Fine. So 2 power 3x the whole square is 2 power 6x. So if we call this as y, this is y square. What is 3 power 3x plus 2? That is nothing but 2 power 3x into 2 square. Or this equation becomes y square plus 4y minus 21 equal to 0. Once you crack this, we're pretty much through.
2 power 3x plus 2 is 2 power 3x into 2 square. 2 square is 4. So this is y square plus 4y minus 21 equal to 0. This is nothing but y plus 7 into y minus 3 equal to 0. This 4 we are splitting as 7 and minus 3. Y equal to minus 7 or plus 3. 2 power 3x cannot be negative. Y is 2 power 3x, remember. Or this is quite simply 2 power 3x equal to 3. Some log is involved. Right away we take log to the base 2 of 2 power 3x is log 3 to the base 2. This is 3x equals log 3 to the base 2, or x is 1/3 of log 3 to the base 2. Log 3 to the base 2 by 3. That is the right answer. First step, convert this to a quadratic equation. Get two roots. One of the roots does not work out. Take the other root. Bring back x into the system. 2 power 3x is equal to 3. Then take log on both sides. You're through. Number pairs. How many pairs m comma n of positive integers satisfy the equation m square plus 105 is n square? To start with integers and positive integers. We're talking about natural numbers. First step, we write this as 105 equals n square minus m square. We know these are positive integers, so n is greater than m. This can be broken as n plus m into n minus m. So product of two natural numbers is 105. 105 can be written as 3 into 35. 3 into 5 into 7. And so that's 8 factors. It can be broken up in 4 different ways. So it can be written as 1 into 105, 3 into 35, 5 into 21, 7 into 15. Each of those will give us one pair of integers. Remember, n plus m has to be greater than n minus m. N and m are natural numbers. N is greater than m. This has to be greater than this. So we need to worry about only 105 into 1. We don't have to worry about 1 into 105. Likewise, 35 into 3, 21 into 5, 15 into 7. 4 different combinations. Each of them will yield a pair of positive integers. So 4 pairs. The quadratic equation x square plus bx plus c equal to 0 has two roots, 4a and 3a, where a is an integer. Which of the following is a possible value of b square plus c? Brilliant. Sum of the roots, that is 4a plus 3a equals minus b. Product of the roots is 4a into 3a. This is c. Sum of the roots is minus b by a. Product of the roots is c by a. So 7a is minus b. 12a square is c. b square plus c. b square is 49a square. c is 12a square. If we add these two, b square plus c is 49a square plus 12a square, which is 61a square. So our answer should be a multiple of 61 and should be a perfect square. Perfect square into 61 should be one of these. And so 61 into a square cannot be 361. 361 is not a multiple of 61. 549, 427 and 549. 427 by 61. 61 into 7 is 427. It's a multiple, all right, but into 7. 7 is not a perfect square. This doesn't work. 549 is 61 into 9. 540 plus 9. This works. 9 is a perfect square. A could be 3. This is a possible value. 3721 by 61. I'm just verifying this. In an exam, I'm probably not doing this. This goes 6 times. 366 and 61. 61 times 61. 61 is not a perfect square. This won't work. Only this works. Brilliant. Done. Because a is an integer. If x is a real number, then square root of log of 4x minus x square by 3 to the base e is a real number if and only if. Square root of a number. So straight away we know log of 4x minus x square by 3 to the base e should be greater than or equal to 0. Brilliant. Only then we can find square root. Or now let's go to the next step. Log of something is greater than or equal to 0, or that something 4x minus x square by 3 should be greater than or equal to 1. Log 1 to the base e is 0. Anything more than 1, the log of that number will be greater than 0. So 4x minus x square should be 4x minus x square by 3 should be greater than or equal to 1, or 4x minus x square minus 3 should be greater than or equal to 0. So this minus 3 comes over this side, or x square minus 4x plus 3 is less than or equal to 0. X minus 1 into x minus 3 is less than or equal to 0, or x should lie between 1 and 3, including 1, including 3. 1 less than or equal to x, less than or equal to 3. That is the answer we are looking for. What is the largest positive integer such that n square plus 7n plus 12 by n square minus n minus 12 is also a positive integer? It's a delightful question. Anytime you have a quadratic by a quadratic, don't deal with two quadratics, deal with one. How so? Call this as n square minus n minus 12 plus some adjustment term divided by n square minus n minus 12. Brilliant. Now this works. What is the adjustment term? 8n was minus n plus 8n is 7n plus 24. So this becomes 1 plus 8n plus 24 by n square minus n minus 12. Now let's look at this. If the whole thing has to be an integer, this has to be an integer. 8n plus 24 is 8 times n plus 3. N square minus n minus 12 is n minus 4 into n plus 3. N cannot be minus 3, so this can be knocked off. 8 by n minus 4 has to be an integer. So the best case scenario, this is equal to 1. That's when n will be as high as possible. If you put 8 equals n minus 4, n is 12. N were any more than 12, 13, 14, 15, 16, this will become a proper fraction, a positive proper fraction, and it will not be an integer, or the largest value n can take is 12. Another way of doing this, factorize this, n plus 3 into n plus 4 by n plus 3 into n minus 4. N plus 4 by n minus 4 should be an integer. What is the maximum value n can take? 12 plus 4 by 12 minus 4 works. 16 by 8 is 2. Then you can simplify. The smaller this integer is, the larger value n can take. Put it as 2, simplify, we are through. Let us be the set of all points xy in the xy plane such that mod x plus mod y less than or equal to 2. Wonderful. Mod x plus mod y less than or equal to 2. I know this shape, mod x plus mod y equal to 2. Put x equal to 0, y has to be plus 2 or minus 2. Put y equal to 0, x is plus 2 or minus 2. This region is a set of straight lines. Zero comma 2, 2 comma 0, 0 comma minus 2, minus 2 comma 0. And mod x is greater than or equal to 1. Mod x equal to 1 will happen when x is 1 or minus 1. And so mod x is greater than or equal to 1. That is, mod x equal to 1, x equal to 1 would be a line like this. X equal to minus 1 would be a line like this. Mod x greater than or equal to 1 would be either this region or this region. Mod x plus mod y less than or equal to is the square, which is tilted and makes look like a diamond. Then the area in square units represented by s. Represented by s is this. What are the points here? This point will be 1 comma 1. This will be 1 comma minus 1. Will be minus 1 comma 1, minus 1 comma minus 1. This region. If you find one area, we can find the other. This distance is 2. Height is 1. So we have a triangle with base 2 and height 1. Area would be half into 2 into 1. Just 1 square unit. Here there is one square unit. Here there is one square unit. The area in square units represented by S is 2 square units. Wonderful question. You need to be comfortable with drawing the diagram. F of 5 plus x equal to f of 5 minus x for every real value of x. F of x equal to 0 has 4 distinct real roots. Then the sum of these roots is a wonderful question. Right? So I tried some algebraic methods of solving it and then went nowhere with it. Right? F of 5 plus x equals f of 5 minus x. And so think about this. You draw the graph. F of 5 plus x is equal to f of 5 minus x. So f of 6 is f of 4. So you have 6 and 4. F of 7 is equal to f of 3. 7 and 3. If f of 6 were here, f of 4 would be here. If of 7 were here, f of 3 would be here. Whatever value in between, it will be like that. So some curve like this, some curve like this, some curve like this. It's going to be a graph. You can imagine a graph like that. And so I just want to dwell on this. I tried this, but then it didn't take me anywhere. It looks like it is symmetric around 5. Yeah, so what? And it has 4 distinct real roots. So let's break this framework. Let's assume that it cuts somewhere here and then cuts somewhere here. 2 roots. Therefore, it will cut here and cut here. 4 roots. Now we are on to something. There are 4 roots. Think about it. If f of 12 were 0, assume that 12 is a root. That means f of 5 plus 7 is a root. That means f of 5 minus 7 should also be a root. F of minus 2 should be a root. From 5, if you move some number of units to get a root, you should move the same number of units this side to get another root. Now we are on to something. So navigating from 5, this side if there is a root, that side there is a root. Maybe you navigate 7, maybe you navigate 12, maybe you navigate 15. Forget that. Idea here, suppose this and this are roots. If you add these two, they'll be of the form 5 plus k and 5 minus k. 5 plus k plus 5 minus k is 10. Roots come in pairs. Sum of any one pair is 10. There are 4 roots, 2 pairs, 20. The roots have to be of the form 5 plus k and 5 minus k. They have to come in pairs. 5 plus k plus 5 minus k is 10. 2 such pairs, 20. Log 5 to the base 4 equals log y to the base 4 times log root 5 to the base 6. Take this side, we are through. Log 5 to the base 4 by log y to the base 4. This is nothing but log 5 to the base y. This is log root 5 to the base 6. Let's call this as k. 6 power k is root 5. Y power k is 5. Square this. 6 power k is root 5. 6 power k whole square is 5. Y power k is 5, which is nothing but 6 power k the whole square. Or this is 36 power k is 5, which is nothing but y power k, or y equals 36. Log root 5 to the base 6 is same as log 5 to the base 36. The number of real valued solutions to the equation 2 power x plus 2 power minus x is 2 minus x minus 2 whole square. Beautiful question. You think about this. 2 power x and 2 power minus x are both positive. Fine. The minimum value this can take, this is of the form y plus 1 by y. The minimum value it can take is greater than or equal to 2. If it were negative, it will be less than or equal to minus 2. If it is positive, it is greater than or equal to 2. So this side is greater than or equal to 2. This side, this is greater than or equal to 0. Or this part is less than or equal to 2. From 2, you're subtracting a non-negative number. The maximum value the expression can be is 2. We're done. This has to be greater than or equal to 2. That has to be less than or equal to 2. The only possibility is if both are equal to 2. Be equal to 2 when x is 0. Put x equal to 0. 2 power 0 plus 2 power minus 0. This is 2. But if you put x equal to 2 here, we get 2 minus, x equal to 0 here, 2 minus 2 square. 2 minus 4 equal to minus 2. It doesn't work. This will go to 0 when x is 2. At that time, this is not 0. So there's no case where this is equal to 2 and this is equal to 2, or we'll have 0 real valued solutions to this. X equals 4096 to the power 7 plus 4 root 3. Which of the following equals 64? Now there's a bunch of things where being numerically comfortable is very helpful. 64 square is 4096. This is 2 power 6. This is 2 power 12. That is helpful. So this square root idea involved here somewhere. And so x can be written as 64 square whole power 7 plus 4 root 3. Wonderful. So that could be helpful. Fine. The second thing, which of the following equals 64? So we still don't know how to get to 64 from here. And so we can say square root of x is 64 to the power 7 plus 4 root 3. Or square root of x to the power 1 by 7 plus 4 root 3 is 64. 1 by 7 plus 4 root 3. 7 plus 4 root 3 is a beautiful number. Because 7 plus 4 root 3 into 7 minus 4 root 3 is 7 square 49 minus 16 into 3 48, which is 1. The reciprocal of 7 plus 4 root 3 is 7 minus 4 root 3. Or square root of x to the power 7 minus 4 root 3 is 64. How do we get there? Okay, this is x power 7 by 2 by x power 4 by 3. This is x power 7 by 2 minus 4 by root 3. Sorry, it should be 4 root 3. It's given incorrect. It should be 4 root 3. No, 4 by root 3. 4 by root 3. That doesn't work. 4 by root 3. It's tough to reconcile. This is x power 7 minus 4 root 3. This is also incorrect. It should be square root of x power 7 minus 4 root 3. This is x power 7 by 2 minus 2 root 3. Yep. This is x power 1 by 2 whole power 7 minus 4 root 3. This choice works brilliantly. Choice A, if it had been 4 root 3, we would have exploded. It is 4 by root 3. So we don't have to worry about it. Choice C takes us to 7 x power 7 by 2 minus 2 root 3, or x power half whole power 7 minus 4 root 3. Numerical friendliness, being friendly with picking that 7 plus 4 root 3 and 7 minus 4 root 3 are reciprocals. 4096 is 64 square. That really pays off. So it's a cruel question if you can't pick that. X plus 1 by x the whole square minus 3 times x plus 1 by x plus 2 equal to 0. Simple. Let's say x plus 1 by x equal to y. Y square minus 3y plus 2 equal to 0. Remember, y is greater than or equal to 2, or y is less than or equal to minus 2. Anything of the form x plus 1 by x, you should know this again. This is y minus 1 into y minus 2 equals 0. Y is 1 or 2. Y cannot be 1. X plus 1 by x cannot be 1. So y has to be 2. X plus 1 by x equal to 2 has x plus 1 by x equal to 2 has only one solution, x equal to 1, or this has one real solution. X square minus 7x plus 11 whole power x square minus 13x plus 42 is 1. Sounds like an incredibly tough question. But think about this. Any number power 0 is 11. So this could go to 0. Fine. If you have a number 1.6 over anything apart from 0, it cannot be 1, because if it's 1.6 power positive number, it will keep going higher and higher. Negative number will keep going less than 1. It can be equal to 1 only if it were 0, or the only time a non-zero power can give us 1 is 1 power something is 1. It's very simple. So x square minus 13x plus 42 equal to 0, or x square minus 7x plus 11 equal to 1. Solve these two, you're good to go. X minus 6 into x minus 7 is 0, 6 or 7. We need to substitute that to verify, but in both cases it's going to be some integer. We can even say it will be a positive integer. So 36 minus 42 plus 11, yeah, positive, nothing to worry. Substituting works. Or here we have x square minus 7x plus 10 equal to 0. X minus 2 into x minus 5 equal to 0. X is 2 or 5. You put 2 or 5, you put 2 square minus 26 plus 42, again nice positive integer, nothing to worry. You put 5, also will get a positive integer, nothing to worry. 2, 5, 6, 7, all of these work, 4 values. Hang on. There's one thing we have missed completely. We can even get 1 as minus 1 per an even number will give us 1. We'll have to verify that. How do you verify that? X square minus 7x plus 11 equals minus 1. X square minus 7x plus 12 equal to 0. X minus 3 into x minus 4 is 0. X could be 3 or 4. Minus 3 power, if you put x is 3, minus 1 power some number, could be 1 if that power is even. So put x is 3, 9 minus 39 plus 42. 9 minus 39 is minus 30 plus 42. This is 12. So x equal to 3 works. Put x equal to 4. That will definitely work. 16 minus 13 into 4, 52 plus 42. 16 minus 10, this is 6. That's also an even number. We get minus 1 per 6. So 3, 4 could work as well. So 2 and 5 could work. 6 and 7 could work. 3 and 4 could work. Or there are 6 possible values. I missed this one and I got 4 because I completely forgot the minus 1 par 4 thing. So beautiful question. You'll have to worry about this going to 0, this going to plus 1, this going to minus 1 in the time when this is an even number. The area of the region satisfying the inequalities mod x minus y less than or equal to 1, y greater than or equal to 0, y less than or equal to 1 is beautiful. Let's draw this one. Y greater than or equal to 0. This is this. Y less than or equal to 1. Y equal to 1 is this region. We're talking about this band. Mod x minus y less than or equal to 1. Okay, mod x minus y equal to 1. Or y equals mod x minus 1. Now, y equal to mod x is a curve like this. Mod x minus 1 will be a curve like this. Shift it down by 1. So this is 0, 0. This is x-axis. This is a line y equal to 0. This is a line y equal to 1. We're talking about this band here. On top of, inside that band sits this y equal to mod x minus 1 line. So this point will be minus 1, 0, minus 1. Put x equal to 0, y will be minus 1. This point, when will y be 0? When x is 1, 1, 0, or x is minus 1, minus 1, 0. When will y be 1? So 1 equals mod x minus 1. Mod x should be 2, 2, 0, or minus 2, 0. Or this distance is 4. This distance is 2. We're talking about a trapezium of height 1 and sides, parallel sides 4 and 2. Half into 4 plus 2 into 1. Half of 6, 3 square units. Okay. Let's look at this one. If y is a negative number such that 2 power y square log 5 to the base 3 equal to 5 power log 3 to the base 2. And so, very often in these kind of log questions where an exponent is there and log is there, a simple trick in the book is take log on both sides. That might simplify something. And so I'm going to try to do that. Take log on both sides and we'll try to do this. So this becomes y square log 5 to the base 3 times log 2 is equal to log 3 to the base 2 times log 5. This is 5 power log 3 to the base 2. So this will be log 3 to the base 2 times log 5. Log 5 to the base 3 here and a log 5 here. So we can choose the base to be 3. It's in our hands. We can choose any base. If we do that, then this log 5 to the base 3, this log 5 to the base 3, these two get cancelled. So we have y square here equal to log 3 to the base 2 by log 2 to the base 3. Log 2 to the base 3 is 1 by log 3 to the base 2. So this is nothing but y square equals log 3 to the base 2 whole square. Or y should be log 3 to the base 2. But the problem here is we know y is negative. It's been given very clearly that y is negative. So y is not log 3 to the base 2. It is log 3 to the base 2 times minus 1. Minus of log 3 to the base 2. Log 3 to the base 2 and minus of log 3 to the base 2 is nothing but log 1 by 3 to the base 2. 2 power something is 3. 2 power minus of something, minus of the same thing will be 1 by 3. So minus log 3 to the base 2 is nothing but log 1 by 3 to the base 2. We're looking for a choice that says that. It's just this. Beautiful question. Nice, wonderful, challenging question. What you're looking for here when you're combining exponents and log, that first step of unlocking, that is take log on both sides. That's a beautiful trick. So keep that in mind. The moment you take log on both sides and you're plugging that in, now the second trick is there is a log 5 to the base 3 here. We can choose any base. Choose the base to be 3. That means you put a base 3 here and a base 3 here. These two get cancelled, knocked off. After this, log 3 to the base 2 and log 2 to the base 3 are just reciprocals of each other. Final thing, when you come here, we have to keep in mind that the question clearly states that y is a negative number. That's something to keep in mind. So the answer is log 1 by 3 to the base 2. The number of pairs of integers x comma y satisfying x greater than or equal to y greater than or equal to minus 20 and 2x plus 5y is 99 is. These kind of questions, find one solution and then build from there. Find one solution and then build from there. Fine. 2x plus 5y is 99. This is going to be an even number. So from 99 subtract an even number and then find a multiple of 5. So if it's from 99 you subtract an even number, you'll get an odd number. Find an odd multiple of 5. The best case I can think of is when y is 19, 95 comes about. So the one solution that I can think of is x equal to 2, y equal to 19. This works. Fine. X greater than or equal to y greater than or equal to minus 20. We can't count this. Fine. This is not a right solution. X is 2, y is 19, does not work for us. Fine. But this is one solution. We've got one solution. After this, what we do, you keep increasing x, y should decrease. Or if you keep decreasing x, y should increase. That much we know. X is multiplied by 2, y is multiplied by 5. Think about this. You have to find something to go up in x that should be offset by a fall in y. And so any increase in x will increase this by multiples of 2. Any change in y will change this in multiples of 5. Or if you change x by 5, you'll change y by 2. What does that mean? If you put x equal to 7, y will be 14. You increase this by 5, sorry, y will be 17. Decrease this by 2. The total goes up by 10, the total falls by 10, it gets cancelled out. So x equal to 7 gives us 2 into 7, 14, plus 85 is 99. That works. Next one, x will be 12, y will be 15. X will be 17, y will be 13, and so on. And so we've now got a pattern for all the values. Now let's put that condition. X greater than or equal to y greater than or equal to minus 20. Here x is not greater than or equal to y. Here x is not greater than or equal to y. Here no. This one works. You keep decreasing x and increasing y. Y is 21 and x is minus 3. None of those will work. So we're looking for solutions below this. 17, 13 is the first starting point. After that, this becomes 22, y becomes 11. This becomes 27, y becomes 9. 27 into 2 is 54, 9 into 5 is 45, they add up to 99. Right? So the first condition, x greater than or equal to y, works. Right? Now we have to think about y greater than or equal to minus 20. this keeps on going down. You go 9, 7, 5, 3, 1, minus 1, etc., 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 etc. But then till what point? It starts at 13, 11, 9, 7, 1, minus 1, minus 3, minus 19. It can't go any further. It can't go below minus 19. It becomes minus 21. That condition won't get satisfied. All we need to do is figure out how many are there in this count. We're good to go. And so minus 1 to minus 19 is 10 sets. 1, 3, 5, 1, 2, 3, 4, 5, 6, 7. 7 plus 10, 17 values are there. And very interesting set. These kind of questions, find one solution and then think about how x and y will move such that one offsets the other. So you have a pattern. After we find the pattern, look at the other conditions that are sitting there. So x greater than or equal to y greater than or equal to minus 20. In some cases, it could be mod x greater than y. It could be x and y both positive. Some x and y are natural numbers, something else. Find one solution and then you find the pattern. And then you think about how many numbers, how many pairs will satisfy the other condition. The value of log of a by b to the base a plus log of b by a to the base b for 1 less than a less than or equal to b cannot be equal to. Let's look at this. Let's first, we know log of a by b is log a minus log b. So this one will simplify it as log a to the base a minus log b to the base a. This one we can split as log b to the base b minus log a to the base b. This is 1, this is 1. So this 2 sitting here, 2 minus of log b to the base a plus log a to the base b. I'm going to call it as x plus 1 by x. Why am I writing like this? If log b to the base a were x, then log a to the base b would be 1 by x. Log a to the base b is just a reciprocal of log b to the base a. Right? So it cannot be equal to, is what we are saying. It cannot be equal to. First of all, this is a beautiful function, x plus 1 by x. Simple idea is either always greater than or equal to 2, it's greater than or equal to 2, or it is less than or equal to minus 2. This cannot lie between minus 2 and plus 2. Right? So if it were 2, this will be 0, so 0 is possible. If it were 3, it can be minus 1, so this is possible, this is possible. If it were minus 2.5, it could be minus 1.5, that's possible. For this expression to be 1, x plus 1 by x should be 1, that's not possible, that's what we are looking at. One aspect here we are looking at is logarithm property being manipulated a little bit. The second idea here is very powerful. X plus 1 by x is either greater than or equal to 2 or less than or equal to minus 2. It cannot sit between minus 2 and plus 2. That's the one idea we're plugging in here. So if it were 2, the expression will be 0. If it were 3, expression will be minus 1. If it were 2.5, expression will be minus 0.5. Expression can never be equal to 1 because then it will mean x plus 1 by x has to be 1. That's not possible. Let's do this one. Let the mth and nth terms of a geometric progression be 3 by 4 and 12 respectively, where m is less than n. If the common ratio of the progression is an integer r, then the smallest possible value of r plus n minus m is. Right? So we are having 3 by 4 here. Then we go to 12. Right? So m is less than n. So this is the mth term. This is the nth term. Straight away we know that n minus m is positive. Right? We may take a certain number of steps to go here. Put 4, it could be 5. We don't know that. Right? So we know that r is an integer. Right? So if r were an integer, r power some k will take us from 3 by 4 to 12. Right? So or r power k is 12 by 3 by 4. 12 by 3 by 4 is 12 into 4 by 3, which is 16. R is an integer. 16 can be written as 2 power 4 or 4 square. When we are looking for r to be an integer and k to be an integer, 2 power 4 or 4 square, one of these two. So r is 2 or r could be 4. K is nothing but the difference between n and m. We figure out, substitute, simplify, find this. There's one catch here, keep this in mind. R can be negative. So r can be minus 2, whole power 4 is also 16. R can be minus 4. We want r plus n minus m to be minimum. So definitely choose r to be negative. That doesn't change life. So we're looking at either minus 2 whole power 4 or minus 4 whole power 2. This number is k, which is effectively n minus m. From m, how many terms do we have to jump to the nth term? So either r is minus 2 and n minus m is plus 4, or r is minus 4 and n minus m is plus 2. We want the smallest possible value of this. So we'll have to choose r is minus 4, n minus m is plus 2, minus 4 plus 2 is minus 2. When the common ratio is minus 4, you're looking for the second term from 3 by 4 to go to 12. Right? Let's solve this one. Wonderful question, really tough, but there's a very simple, juicy way of doing this. I'm going to do it by the juiciest method possible. I'll give you the starting step for doing the more rigorous method, but not going to get into that. Right? X and y are positive real numbers satisfying x plus y is 102. Then the minimum possible value of 2601 into 1 plus 1 by x into 1 plus 1 by y. Talk about positive real numbers. And the best way to go about it is pick two extremes. Put x is 0.1, y is 101.9. Or x is 1, y is 101. Another extreme, put x is 51, y is 51. You're through. Let's do that. Let's put x is 1, y is 101. We worry only about this. 1 plus 1 by 1 into 1 plus 1 by 101. This is one possibility. Or we're talking about 1 plus 1 by 51 into 1 plus 1 by 51. This is barely more than 1, but this is 2. It's 2 into 1 point something. Both of these are barely more than 1. And so this is going to be way greater than this. Or we want to find the minimum possible value. The way to go about it, plonk x as 51, y as 51, both equal, we are good to go. How do we do that? Let's look at that. Put x as 51, so looking at 2601 into 1 plus 1 by 51 or 52 by 51 into 52 by 51. 1 plus 1 by 51 is 52 by 51. 51 into 51, funnily enough, is 2601. 52 into 52, you should find that. But I happen to know that it is 2704. So the textbook way of doing this, trying to find the maximum way of this, maximum range for this, all of that is tricky. But the quick and dirty way, we're told that both are positive real numbers. Stick both of them as equal, stick both of them far apart, and then see where you land up. Both of them far apart takes us to a larger number. Equal takes us to a very small number. Go for the small number, you're good to go. The other way of doing this, x plus y is 102. I'm going to anchor around the midpoint. So I'm going to say x is 51 plus k, y is 51 minus k. So we've incorporated that constraint with a single variable. So you can say 2601 into 1 plus 1 by 51 plus k into 1 plus 1 by 51 minus k, and simplify. You'll get an expression in terms of k. You have a look at it, you'll be able to find where it goes to maximum, where it goes to minimum, and then you're good to go. The textbook method works like this. You won't have to differentiate or anything, you can still find the answer. It's not rocket science. That method also takes you to the answer reasonably quickly, but this is far better. Plonk in one extreme, plonk in the other extreme, you're good to go. If x and y are non-negative integers such that x plus 9 is equal to z, y plus 1 is equal to z, and x plus y less than z plus 5, then the maximum possible value of 2x plus y equals. So to start with, I like the idea of drawing a number line, which you can plot everything there. There is x plus 9 is z, this is plus 9, y plus 1 is z, so y is here. All three are linked. When I started doing this, then I realized I don't even need to draw the number line because all three can be captured with the same variable. Right? So here we have x plus y, which is x plus 8 less than x plus 9 plus 5, or 2x plus 8 is less than x plus 14. or x is less than 6. Lovely. The maximum possible value of 2x plus y, higher x is, higher y will be. We know that they are non-negative integers. X is less than 6. The x can be 5. If x were 5, then y would be x plus 8, 13. 2x plus y, 2 into 5 plus 13. 10 plus 13, 23. That's the maximum. I started off doing this, but I realized that all three are part of the same variable. Becomes a very simple question. But there is one question on functions. Let's look at this. X square plus ax plus b. F of x is x square plus ax plus b. G of x is f of x plus 1 minus f of x minus 1. F of x is greater than or equal to 0 for all real x. And g of 20 is 72, the smallest possible value of b. This is a brilliant starting point. So let's define g of x first. F of x plus 1 minus f of x minus 1. So this is x plus 1 whole square plus a times x plus 1 plus b minus of x minus 1 whole square plus a times x minus 1 plus b. We subtract one from the other. There will be a plus ax that will get cancelled, plus a minus a, subtract that, you will get 2a, plus b minus b, this will go off. X square plus 2x plus 1, x square minus 2x plus 1, this will be 4x. We know g of 20 equals 72. Let's plug that in. G of 20 is 4 into 20 plus 2a. This is 72. 4 into 20 is 80. 80 plus 2a is 72. So 2a is minus 8 or a is minus 4. Lovely. Now let's come back to the remaining part of the question. A is minus 4. We want to find the smallest possible value of b. So x square minus 4x plus b. This is f of x. We know f of x is greater than or equal to 0. What does this mean? This means that this number can be expressed as a square plus something, which is when it will be greater than or equal to 0. X square minus 4x plus 4. This can be written as x minus 2 the whole square. X square minus 4x plus 4 is x minus 2 whole square. So this will be plus b minus 4 greater than or equal to 0. Or b should be at least 4. Fine, wonderful question. First we find the expression for g of x. Then we plug in g of 20 is 72 and find a. Then come back to this expression. When you go to that expression, we say it's x square minus 4x plus b. We know that's always greater than or equal to 0. That means it can be reduced as a perfect square, square of a quadratic, x minus a whole square, something of that form, plus a positive number or a non-negative number. So we can deduce what b will be by completing the square of that expression. So the smallest value b can take is 4. This is a lovely, lovely question, wonderfully challenging question. Let's look at this one. In how many ways can a pair of integers x comma a be chosen such that x square minus 2 mod x plus modulus of a minus 2 is equal to 0? Lovely question, because this can be framed as an equation in mod x. And so the wonderful idea. And so now think about this. So we have mod x square minus 2 mod x plus a positive number is equal to 0. The beauty here is x square mod x square minus 2 mod x plus 1 equal to 0 is a nice square of a quadratic expression. How do I say that? So mod x minus 1 whole square is x square minus 2 mod x plus 1. This can be equal to 0 when mod x is equal to 1, but it cannot, this number cannot be more than 1. So straight away we know that this constant term, if it were more than 1, we have no solution. It is positive. If they are more than 1, we have no solution. We know we are talking about integers, or modulus of a minus 2. Modulus of a minus 2 can be 0 or it can be 1. Nothing else is possible. Fine. So I'm going to look at both possibilities. Let's say that's equal to 0. So now we have mod x the whole square minus 2 mod x is equal to 0. Mod x into mod x minus 2 equal to 0, or x could be 0, x could be 2, x could be minus 2. For all of these possibilities, a equal to 2 works. So there are three possible solutions here. X and a, 0, 2, 2, 2, minus 2, 2. Three possibilities work. Now let's go to the other scenario where we say mod x minus 1 whole square is equal to 0. And so mod x minus 1 whole square is 0. This means mod x is 1. X could be 1 or minus 1. This is the scenario when modulus of a minus 2 is 1 or a is 3 or a is 1. A minus 2 is 1 or a minus 2 is minus 1. Both are possible. Now, it could be x is 1, a is 3, x is 1, a is 1, or x is minus 1, a is 3, x is minus 1, a is 1. Four possibilities exist. All four are possible. Here we have three possibilities, here we have four, totally 7. Wonderful question, delightful question from the idea of completion of squares. We start off with that and then isolate that the constant term can only be 0 or 1. Plug in the constant term to be 0, find all possible solutions. Put the constant term to be 1 and find all possible solutions. Be rigorous. Remember, you're dealing with modulus of x. Remember, you're dealing with modulus of a minus 2. Find wonderful questions with the delightful 7 answers. For real x, the maximum possible value of x by square root of 1 plus x power 4. These kind of questions, trick 1 in the book. Whenever there's a square root sitting here, see if you can simplify this expression to have some kind of symmetry. What do I mean by that? There's an x on top and then the square root and 1 plus x power 4. 1 and x power 4 are far away and x is in the middle. This is x power 1, x power 0, x power 4. We're all over the place. But if you simplify this, make one very simple change. Divide by x in the numerator and denominator. So numerator is x by x. Denominator is 1 plus x power 4 by x square, because inside the square root. Right? X by x is 1. 1 by square root of 1 by x square plus x square. Lovely. Once you do this, you're through. We've already seen this in a couple of questions. X plus 1 by x is either greater than or equal to 2 or less than or equal to 1 minus 2. 1 by x square plus x square is always greater than or equal to 2. Right? So I'm going to start with this. X square plus 1 by x square is greater than or equal to 2. Or square root of x square plus 1 by x square is greater than or equal to root 2. 1 by square root of x square plus 1 by x square is less than or equal to 1 by root 2 or the maximum possible value 1 by root 2. The first thing, divide numerator and denominator by x. Numerator gets divided by x, denominator gets divided by x square inside the root. Then modify this. You need to be able to see this expression as this expression. We know how x square plus 1 by x square behaves. Therefore, we know how square root of x square plus 1 by x square behaves. Therefore, we know how 1 by square root of x square plus 1 by x square behaves. So, this is greater than or equal to 2. This is greater than or equal to root 2. 1 by this is less than or equal to 1 by root. The number of integers that satisfy the inequality x square minus 5x plus 7 whole power x plus 1 equal to 1. And so, x square minus 5x plus 7 whole power x plus 1 equal to 1. When can this happen? When can an exponent be equal to 1? Very simple idea. First up, 5 power 0 is 1. Anything power 0 is 1. So this goes to 0, we strike jackpot. And so that's one approach, one starting point. Another thing, 1 power anything is 1. 1 power 3, 1 power 5, 1 power 100, all of those are 1. So that's useful. These two, everyone will find. There's one other possibility. You could have minus 1 whole power 4 equal to 1. Minus 1 raised to the power an even number is 1. Minus 1 power 3 is minus 1. But minus 1 square, minus 1 power 6, minus 1 power 8, all of those are 1. So the three possibilities we need to account for. One, we've got to say the power goes to 0 and then simplify and see if it works. Then say the expression is plus 1, worry about the power. Then expression is minus 1, worry about the power being an even number. And let's do all three. First of all, power going to 0, so x is minus 1. That is a possibility. We substitute minus 1 here, minus 1 whole square is 1, minus 5 plus, so that works, 1 plus 5 plus 7 whole power 0, that will work. So x equal to minus 1 is one obvious possibility, we have it in the bag. Let's go to the next. X square minus 5x plus 7 is equal to 1, or x square minus 5x plus 6 equal to 0, x minus 2 into x minus 3 is equal to 0, or x could be 2 or 3. If we put x as 2 or 3, this will become cube or power 4, 1 cube, 1 power 4, both of them work. So x equal to 2 works, x equal to 3 works, x equal to minus 1 works. Now let's go to the final set of possibilities. X square minus 5x plus 7 is equal to minus 1, or x square minus 5x plus 8 is equal to 0. So number of integers that satisfy the equality, x square minus 5x plus 8 equal to 0, you have to split minus 5 in order to get a product of 8. X square minus 5x plus 8 equal to 0. I don't think there are integer values that satisfy this, because it's not something that splits easy. It's 2 into 4 or 1 into 8. Minus 2 into minus 4, minus 1 into 8, minus 8 don't work here. So there's no integer solution possible here. So 2 and 3 work, minus 1 works. There are 3 solutions possible. Generally, as a rule of thumb, you'll have to worry about this possibility also. In this case, it doesn't matter.
F of x plus y is f of x into f of y, and f of 5 is 4. What is f of 10 minus f of minus 10 equal to? All these questions, f of x plus y is f of x into f of y. If you add a number, the number does not change. Think about a number like that. There is x plus y here, put y equal to 0. F of x plus 0 is f of x into f of 0. F of x is f of x into f of 0. Wonderful. Or f of 0 is 1. Assuming f of x is not 0. F of x is not 0, that much we know. F of 0 is 1. So f of 5 is 4. F of 5 plus 5 is f of 5 into f of 5. Or f of 10 is 4 into 4, which is 16. F of 10 plus minus 10 is f of 10 into f of minus 10. F of 0 is 16 into f of minus 10, or f of minus 10 is 1 by 16. So you're looking for 16 minus 1 by 16. It should be this. 1 by 16 is 0.0625. Even if you didn't know that, from the choices you can get there. Let m be positive integers if x square plus mx plus 2n and x square plus 2nx plus m equal to 0 have real roots in the smallest possible value of m plus n. Have real roots. So b square minus 4ac should be greater than or equal to 0. So m square minus 8n is greater than or equal to 0. 2n the whole square minus 4m should be greater than or equal to 0. Or 4n square minus 4m is greater than or equal to 0. N square minus m greater than or equal to 0. M square minus 8n greater than or equal to 0. Lovely. We have this. After this, let's not do this algebraically. It's a pain. Find m square is greater than or equal to 8n. N square minus m greater than or equal to 0. From now on, we want m plus n to be as small as possible. We put n are positive integers, you put n equal to 1. Right? Then m square should be greater than or equal to 8. It should be 3 or more. If you put m as 3, then n should be 2 or more. So n equal to 1 does not work. Wonderful. So if you put n equal to 1, it doesn't work, because then both conditions cannot be satisfied. Put n equal to 2. N square is 4. 4 minus m greater than or equal to 0, or m is
4 or lesser. M square minus 8 into 2 greater than or equal to 0. M square minus 16 is greater than or equal to 0. M is 4 or more, or M could be 4. N equal to 2, M equal to 4 works. It just works. This side becomes 0, that side becomes 0. Both times the real roots are equal, but it works. 2 plus 4 is 6. Nothing else will work. That much we know. If we put N equal to 1, it doesn't work. N equal to 2, M is 4, the best case scenario, and it just works. We can confidently mark this. Do not go about this algebraically. Plug in a few values, see where it takes us. It's a beautiful question, nice and tough. Fine, so let's write this down. We have log 30 to the base A is capital A. Log 5 by 3 to the base A is minus B. Log A to the base 2 is 1 by 3. This means log 2 to the base A is 3. And A cube is 2. And so there's something that gives us links 30 to A, 5 by 3 to A, and 2 to A. Right? We want to find log A to the base 3. If we find log 3 to the base A, we are through. If we know this, we know this. But this fine. So we know the link between A and 2. We need to find the link between A and 3. Right? If we can find the link between kind of 2 and 3, we may be through. One look at the choices tells us that A plus B is involved everywhere. So there's something to go from there as well. So how do we get A plus B? If we subtract this from this, I'll get A plus B. Why am I doing that? We know that log M minus log N is log of M by N. So log of 30 by 5 by 3 we can get, which is log of 30 into 3 by 5, which is log 18 to the base A. 18 is a combination of 2's and 3's, so I like that. Let's get that. So log 18 to the base A, this minus this is A plus B. How do we simplify this? Log 18 to the base A. Log 18 to the base A is log 9 to the base A plus log 2 to the base A, or 2 times log 3 to the base A plus log 2 to the base A. Lovely. Log 18 to the base A is A plus B. Log 2 to the base A is 3. So A plus B is 2 times log 3 to the base A plus 3, or log 3 to the base A is A plus B minus 3 by 2. We are looking for log A to the base 3 is 2 by A plus B minus 3. 2 into 4 into 8 into 16 divided by log 4 to the base 2 whole square. Log 4 to the base 2 is 2. Log 8 to the base 4. This is log 8 by log 4. Both to the base 2 is 3 by 2. Log 16 to the base 8 is log 16 by log 8. I can select the base to be 2. This is 4 by 3. So this won't calculate only the denominator. We'll come to the numerator. 2 square into 3 by 2 cube into 4 by 3 power 4. 2 into 2 into 3 by 2 into 3 by 2 into 3 by 2 into 4 by 3 into 4 by 3 into 4 by 3 into 4 by 3. The 3 3's get cancelled. 2 2's get cancelled. This is 2. So now let's plug in the numerator. 2 into 4 into 8 into 16 divided by 2 into 4 into 4 into 4 by 3. That 3 goes here. 2 into 4 is 8. 4 into 4 is 16. So it is 2 into 4 into 3. 8 into 3, 24. Very routine question. Should be knocking it off the park. Let k be a constant. The equations kx plus y equal to 3 and 4x plus ky equal to 4 have a unique solution. For unique solution system, a1 by a2 should be not equal to b1 by b2. That's all we need to do. K by 4 is not equal to 1 by k. K square is not equal to 4. K should not be equal to plus or minus 2, or modulus of k not equal to 2. It's a 45-second question. You need to know this property. If you're preparing for the exam and you don't know this property, then that is the issue. Beautiful question. I really like this question. The area and square units enclosed by the lines x equal to 2, y equal to modulus of x minus 2 plus 4, and the x-axis and y-axis are equal to. Wonderful. X-axis is this, y-axis is this. X equal to 2 is a line parallel to the y-axis. So we've got this. These three we have in the back. 0, 0, x-axis, y-axis. We can somehow get this. We are through. I'm going to get this slowly, methodically. If we get this diagram shape, we are through. Fine. So for that, I'm going to go step by step. I'm going to draw y equal to mod x, because I know that y equal to x is a line like this. Y equal to mod x is a line like this. It will be 0 at x equal to 0. And this is y equal to mod x. Now I want to do y equal to modulus of x minus 2. Think about it. This will go to 0 when x is 2. Or this is nothing. Shifting it to the right. Y equal to mod x is like this. Y equal to modulus of x minus 2 will be like this. How will y equal to modulus of x minus 2 plus 4 be? Add 4. 1, 2, 3, 4. It will be a line like this. Now take that to our original diagram. So this is 2, 0 and then 2, 4. You are looking at a line like this. This point is 2, 4. You put x is 2, y will be 4. That's a bottom for this. You're looking at a curve like this. This distance is 2 units. This distance is 4 units. There's a straight line. The angle is 45 degrees. The modulus of x line. This is 2. This is 2. This area is half into 2 into 2, 2 square units. This area is 2 into 4, 8. 8 plus 2, 10. If you know y equal to mod x, you should have a sense of y equal to modulus of x minus 2. If you know y equal to f of x, you know y equal to f of x plus 4. Just take it higher. Then you visualize the shape. Think of the trapezium. Think of a right angle triangle and a rectangle. Then you're through. x1 is minus m minus 1. xm is xm plus 1 plus m plus 1. For every positive integer m. Let's do this. All of these questions, a simple pattern should emerge. x1 is minus 1. x1 is x2 plus 2. Minus 1 is x2 plus 2. x2 is minus 3. x2 is x3 plus 3. Minus 3 is x3 plus 3. x3 is minus 6. x1 is minus 1. x2 is minus 3. x3 is minus 6. x4 is x3 plus 4. Sorry, x3 is x4 plus 4. Minus 6 equals x4 plus 4. x4 is minus 10. Beautiful pattern emerges. You take the minus out. This is 1, 3, 6, 10. 1, 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4. And then stick a minus in between. x100 is sum of all numbers till 100 with a minus 1 before that. Minus into 100 into 101 by 2 minus 5050. Lovely.
Slot 3 quant. Beautiful question. Nice challenging question. Took me a long time to solve this. I did not go for it in the exam, but it's a beautiful question nevertheless. Let's look at this. 14 power A is 36 power B equals 84 power C. What is 6B times 1 by C minus 1 by A equal to? And so there's some 1 by C, there's some 1 by A. A lot of these questions kind of get simplified if you take log on both sides. Right? So, but there's links A, B and C. I'm going to say, let's call this as K. Right? Beautiful. So 14 power A is equal to K. What does it mean? 14 raised to the power something is K. So what does that mean? This means log
k to the base 14 is a. Log k to the base 36 is b. The very definition, log k to the 36 is b, that means 36 power b is k. Log k to the base 84 is c. But we're not dealing with a, b and c, we're dealing with a 1 by c, 1 by a and all that. So let's see, can we flip this? Log 14 to the base k. Log k to the base 14 is a, log 14 to the base k is 1 by a. Log 36 to the base k is 1 by b. Log 84 to the base k is 1 by c. Lovely. Multiple advantages here. We're dealing with base k. So therefore that is very useful. And we want to find 1 by c minus 1 by a. So let's forget this for the time being. To 1 by c minus 1 by a. This is equal to log 84 to the base k minus log 14 to the base k. 84 by 14 is 6. This is log 6 to the base k. Log a minus log b is log of a by b. Brilliant. So log 6 to the base k is 1 by c minus 1 by a. Log 36 to the base k is 1 by b. Log 36 to the base k is nothing but 2 times log 6 to the base k. Now we are practically to log 36 to the base k is 2 times log 6 to the base k. 6 square is 36. And so 36 to the base k is 1 by b, or we know, I'm going to go to the next slide, 1 by b equals is 2 times 1 by c minus 1 by a, or 1 equals 2b times 1 by c minus 1 by a. What is 6b? 3 equals 6b times 1 by c minus 1 by a. Wonderful, beautiful. The key thing here, we plonk all 3 to be equal to k. And then you realize that if 14 power a is equal to k, that means log k to the base 14 is a. Or log 14 to the base k is 1 by a. Why are we chasing 1 by a? Because this 1 by a is sitting here. We get 1 by a and 1 by c in terms of log expressions, and then do one minus the other. Therefore, we get a sense of 1 by c minus a, 1 by a. We go that far, we straight away get that this is linked to 1 by b. And then we are through. Beautiful question, nice tough question. Classic question where the expression you're looking for, if you go looking to find it, then the question becomes simpler. You want to find 1 by c, you want to find 1 by a. You want to do 1 by c minus 1 by a. So go chasing that. It should fall in place. X square plus 2x minus 15 by x square minus 7x minus 18 is negative if and only if. Effectively solve for this inequality. This is less than 0. X square plus 2x minus 15 is, oops, it is x plus 5 into x minus 3 divided by x square minus 7x minus 18 minus 9 plus 2 x minus 9 into x plus 2. It should be less than 0. And we're going to think about this as roots on a number line. So draw the number line. This minus 5 works. Let's put 0 here. Minus 5, minus 2, 3 and 9. These are the turning points for this. So if x were greater than 9, then this all would be positive. The expression will be positive. X were less than 9 but greater than 3, then x minus 9 would be negative. These 3 are positive. So here the expression would be positive. Here the expression would be negative. The moment I hang on to this, everything else also falls in place. In this range it will be positive. This range it will be negative. This range it will be positive. Imagine this below minus 5. Each of these terms is negative. Negative and negative, positive, negative, negative, positive, positive by positive, positive. So here it won't work. Here the inequality does not hold good. The inequality we are solving for is this expression less than 0. Right? So where does it work? It works from minus 5 to minus 2 and 3 to 9. Minus 5 to minus 2, 3 to 9. Perfect. All less than, no less than or equal to business. It's clearly negative. So life is easy. Minus 5 to minus 2, 3 to 9. Find all the roots. Roots are turning points and then we are done after that. The number of integers n that satisfy the inequalities modulus of n minus 60 less than modulus of n minus 100 less than modulus of n minus 20 is very interesting. First thing we need to know is if you have 2 points on the number line, x and y, then the distance between these 2 points is modulus of x minus y or modulus of y minus x, one of the two, doesn't matter. Right? So now we're going to treat this as this inequality and then this inequality. Then, so let's say modulus of n minus 60 less than modulus of n minus 100. So let's put 60 here and 100 here. So distance modulus of n minus 60 less than modulus of n minus 100. That is, if I have n, distance from 60 is less than distance from 100. Right? Or think about this, if n were here, distance from 60 would be less than distance from 100. If n were here, here, throughout it will work. There will be the turning point will be at 80. Modulus of 80 minus 60 is equal to modulus of 80 minus 100. So where will it work? Where will it hold good? It will hold good when n is less than 80. N can be anywhere here. Modulus of n minus 60 be less than modulus of n minus 100. Because 40 minus 60 modulus is 20, 40 minus 100 modulus is 60. So this tells us n is less than 80. Let's attack this one. So for this, we're thinking about 100 and 20. We know straight away that the turning point is 60. Distance from 100 is less than distance from 20. Or this number is closer to 100. Or n should be greater than 60. This one works when n is less than 80. That one works when n is greater than 60. We're looking for numbers greater than 60, less than 80. 61 to 79. 19 different numbers. That's an answer. 61, 62, 63, 64 till 69. Clearly we are looking at integers, not a range. So 19 different integers work. 61 through to 79. Right? The key point here is if you have 2 points x and y on the number line, the distance between the 2 points is modulus of x minus y, which is nothing but modulus of y minus x. Both are same. 5 minus log square root of 1 plus x to the base 10 plus 4 log 1 minus x to the base 10 equals that. So 5 minus log to the base 10 of square root of 1 plus x plus 4 log to the base 10 of square root of 1 minus x equals, this can be broken as log of 1 by square root of 1 plus x into 1 by square root of 1 minus x. Or this side is minus log of square root of 1 plus x minus log of square root of 1 minus x. Log AB is log A plus log B. Log of 1 by A is minus log A. Log of 1 by B is minus log B. 1 by B is B power minus 1. The idea we're using here. So I can move some logs this side or everything that side. I can shift something around. Minus log of 1 plus x minus log of 1 plus x. These two will get cancelled. Or 5 equals minus log square root of 1 minus x minus 4 log square root of 1 minus x. 5 equals minus 5 log of square root of 1 minus x or log of square root of 1 minus x to the base 10 is minus 1 or square root of 1 minus x is 10 power minus 1, which is 1 by 10. 1 minus x is 1 by 100. X is 99 by 100. We want to find 100x. 100x equals 99. Methodically solve this. We're using two ideas. Log AB is log A plus log B. Next idea, log of 1 by A is minus log A. Right, so log 1 by A is minus of log A. Right. Log AB is log A plus log B. A basket of 2 apples, 4 oranges and 6 mangoes costs the same as a basket of 1 apple, 4 oranges and 8 mangoes. 2A plus 4O plus 6M equals 1A plus 4O plus 4M, or a basket of 8 oranges and 7 mangoes equal to 8 oranges plus 7 mangoes. Then the number of mangoes in a basket of mangoes that are the same cost as the other. We have to get each in terms of the other. Let me see which equation works best. There's no apples at all in this. That should be a help. 8 oranges plus 7 mangoes. I'm going to double this. I'm going to have 8 oranges and 7 mangoes. 6 plus 4, 10, 4 plus 4, 8. Now let me see. Both have 4 oranges, so I'm going to use these two. Cancel the 4 oranges part. And then say 2 apples plus 6 mangoes equals 1 apple plus 4 mangoes. Or an apple equals, let me just do 2 apples plus 4 oranges plus 6 mangoes. 1 apple plus 4 oranges plus 8 mangoes. Luckily, now this is 8. I made that mistake. It should be 8. An apple equals 2 mangoes. Lovely. That is helpful. An apple is 2 mangoes. We can plug that here. So 1 apple, 2 mangoes plus 4 oranges plus 8 mangoes is 8 oranges plus 7 mangoes. This is 4 oranges plus 10 mangoes is 8 oranges plus 7 mangoes. 3 mangoes equals 4 oranges. An apple is 2 mangoes. We can get everything in terms of mangoes. Let's do this. Apple is 2 mangoes. Orange is 3 mangoes is 4 oranges, or 1 orange is 3/4 of a mango. Then the number of mangoes in a basket of mangoes that has the same cost as the other basket. Essentially represent everything in terms of mangoes. 2 apples, 2 into 2 mangoes, plus 4 oranges, 4 into 3 by 4 mangoes, plus 6 mangoes. That is the cost of the first basket. This is 4 mangoes plus 3 mangoes plus 6 mangoes. 7 plus 6, 13 should be the answer. Simple dealing with linear equation. There's 4 oranges in 2 of these. Knock that off. Oranges go off. We have an equation in apples and mangoes. Get apples in terms of mangoes. Plug that in the next one. Get everything in terms of mangoes. We are through. R is a constant such that x modulus of x square minus 4x minus 13 equals R has exactly 3 distinct roots. There's the value of R is. I made a mess of this question, so I'm going to take revenge on this. Not that it's worth something. So x square minus 4x minus 13. It looks like it cannot be factorized. It cannot be. It is not required that we factorize this. Fine. So the idea is it has exactly 3 roots. One is, suppose this were equal to say 10. What am I doing? I'm saying this is equal to plus 10 gives us a solution. This equal to minus 10 gives us a solution. That means plus 10 will give us 2 roots, minus 10 will give us 2 roots. What's happening here? We have only 3 roots. It is telling us that put us plus 10, you'll get 2. Put us minus 10, you'll get only 1 root. Or the discriminant goes to 0. Or the other way around. That's what this question is saying. Right, so let's simplify this then. So let's complete this square. X square minus 4x plus 4 is x minus 2 whole square minus 17 equals R, or modulus of x minus 2 whole square minus 17 equals R, or x minus 2 whole square minus 17 equal to R, x minus 2 whole square minus 17 equals minus R. This is what you're solving for effectively. Or x minus 2 whole square equals R minus 17, or x minus 2 whole square equals minus R minus 17. This will give us 2 roots. This could give us 2 roots. One of these 2 gives us only 1 root. X is only 2. That's effectively what we're trying to solve for. When will that work? One of these has to go to 0. If x were 17, this will go to 0. X were minus 17 will go to 0. So the value of R 17 works. Done. This goes to 0. X minus 2 whole square is 0, has only 1 root, x equal to 2. There, if x is 17 with some other value, I don't know whether that works. Let me just check that out. X is 17 takes us to 0, or x minus 2 whole square minus 17 equals minus 17. Minus R minus 17, minus 17, minus 17. Let me just check this. If we put a 17, very interesting. It should go to 0. This goes to 0. X equal to 2 works. x equal to 2 will work. Is there a scenario where this goes to minus 17 at all? X minus 2 whole square minus 17 equals minus 17. Sorry, it should be minus r plus 17 minus r plus 17. R equal to 17 works. R equal to minus 17 also works. One of those will give 2 roots. The other will take care of itself. So there are 3 roots possible only when x is 17. This works. This is r plus 17 minus r plus 17. 3 roots are possible when r is 17. x0 is 1. x1 is 2. xn plus 2 is 1 plus xn plus 1 by xn. So x2 is 1 plus x1 by x0. 1 plus 2 by 1, which is 3. x2 is 3. x3, 1 plus previous term divided by this. 1 plus 3, 4 by 2, 2. x4, 1 plus 2 divided by this. 1 plus 2 by 3. This is 1 plus 3 by 2. x5, 1 plus 1 by 2. 2 by 2, 1. x6, 1 plus 1 by 1. 2 by 1, 2. And so on. And there's some pattern here. The next 2021 is equal to, very interesting. Each term is generated by the previous 2 terms. That much I know. This is generated by plugging in something here. This is generated by plugging in something here. This is generated by plugging in a rule here. The moment a pattern recurs, after that it will become a cycle. So if I see a 2, 3 somewhere, this 2, 3 generates a 2, that 2, 3 will generate a 2. And so x7, 1 plus 2, 3 by 1, 3. x8, 1 plus 3, 4 by 2, 2. 1, 2, 3, 2, 1, 1, 2, 3, 2. 2, 3, 2 or 1, 2, 3, 2, 1, 1. 1, 2, 3, 2, 1. 1, 2, 3, 2, 1. 1, 2, 3, 2, 1. The moment I have a 1, 2, everything else will repeat. A 1, 2 generates a 3, a 2, 3 generates a 2, a 3, 2 will generate a 1, a 2, 1 will generate a 1. So the moment 2 elements repeat, everything will repeat after that. So this goes in cycles of 5. And so x0, 1, 2, 3, 4, x5, 1, 2, 3, 4, x 2021, at least a reminder 1 on division by 5. It should be here, the second step of the cycle. The digit is 2. The mistake I did, I did all this. And then I said, cycles of 5, I assume that x2, so you're starting with x1, starting with x0. So something to be careful about in the last step also. We're starting with x0. The answer is 2. Log of this whole thing to the base 2 minus 2 is 0. Or log of this whole thing to the base 2 is 2. Or 3 plus log to the base 3 of 4 plus log to the base 4 of x minus 1 is 4. 4 is 2 square. I'm taking this 2 that side and putting it as 2 square. I can take this 3 this side. 4 minus 3 equal to 1. I'll remove this log to the base 3 completely. Means there's remaining 4 plus log to the base 4 of x minus 1 is 3 power 1, which is 3. Or log of x minus 1 to the base 4 is minus 1. Or x minus 1 is 4 power minus 1, which is 1 by 4. Or x is 1 plus 1 by 4, which is 5 by 4. It's a t-tag question, but you're asked for 4x. X is 5 by 4. 4x is 5. X square minus xy minus x is 22. And y square minus xy plus y is 34. X is greater than y. Let's do this. X square minus xy minus x is 22. Y square minus xy plus y is 34. X is greater than y, that much we know. Let's see if we can do something. Let's add these two. Let's see where that goes. So this is x square plus y square minus 2xy minus x plus y equals 56. x minus y whole square minus of x minus y is 56. X minus y into x minus y minus 1 is 56. Very nice. X minus y into x minus y minus 1, two numbers differing by 1 is lesser. 8 into 7 is 56, or minus 7 into minus 8 is 56. Nicely done. We want to find x minus y. X is greater than y. That means x minus y is positive. So we cannot have minus 7 into minus 8. X minus y should be 8. 8 is there. The choice is done. Adding these two, it opened block straight away. Three positive integers x, y, and z are in arithmetic progression. Very nice. If y minus x is greater than 2, x positive integers x, y, z equals 5 times x plus y plus z. X plus y plus z is 3y, middle term. It can be y minus d, y plus d, or x, y, z is 5 into 3y, or x into z is 15. It could be, hey, 3 into 5 or 1 into 15. We know y minus x is greater than 2. The common difference is more than 2. So z minus x should be more than 4. This is out. Or z is 15, x is 1, y is 8. Z minus x is 15 minus 1, which is 14. Yeah. Middle term into 3 is sum of 3 terms. This is an arithmetic progression. For all real values of x, the range of the function x square plus 2x plus 4 by 2x square plus 4x plus 9. X square plus 2x plus 4 is x plus 1 whole square plus 3. 2 times x square plus 2x x square plus 4x plus 9 by 2. Or think of this as 2 times x square plus 2x plus 1 plus 7. 7 by 2, taking 1 here and keeping the 7 that side. Or I can rewrite this expression as x plus 1 whole square plus 3 by 2 times x plus 1 whole square plus 7. And x plus 1 whole square plus 3 by 2 times x plus 1 whole square plus 7. Or x plus 1 whole square plus 3 2 times x plus 1 whole square plus 3 plus 1. Sorry. Plus 2. Sorry. 1 second. Plus 1. And so I'm writing the same numerator, replicating it in the denominator, and then plonking a plus 1 outside of it. Wonderful. So x plus 1 whole square plus 3, I'm going to call it as k. This is k by 2k plus 1, where k is x plus 1 whole square plus 3. Right, so wonderful. So minimum value k can take is 3. This is 3 by 7. If k is any more than 3, then this number will keep getting bigger and bigger. K by 2k plus 1. So by 100 by 2 into 100 plus 1. 1000 by 2 into 1000 plus 1. A million by 2 into million plus 1. This 1 loses significance slowly. And so this number, the larger its value, the most significant point will be when k is as small as possible. If k becomes larger and larger, the 1 starts to lose significance. So it becomes effectively 1 by 2. If you put k as a billion, billion by 2 billion plus 1 is half, practically half. And so this number will go to half when k is very high. What is the smallest value it can take? In k is 3 by 7. Smallest it can take is 3 by 7. Largest it can take is 1 by 2. It cannot quite be 1 by 2. This is the answer. Complete the square. Create the expression after completing the square. Replicate the numerator expression in the denominator as much as possible. Then attack this question. So this becomes k by 2k plus 1, where k is this equation. You can even divide this by k and say 1 by 2 plus 1 by k. Dividing this entire thing, numerator by k, denominator by k. It effectively depends on 1 by k. If 1 by k is large, this fraction will be small. 1 by k is small, this fraction will be large. So the smallest value k can take is 3. Put 3 there, we'll get the smallest value of the expression. Largest value it can take is infinity, or as close to infinity as possible, which case will be 1 by 2. It can be 3 by 7, it cannot be 1 by 2, 3 by 7 to 1 by 2. 2.25 less than or equal to 2 plus 2 power n plus 2 less than or equal to 202. For all the possible integers n satisfying this, the number of integer values of this. Let's first find n that satisfy this. 2.25 less than or equal to 2 plus 2 power n plus 2 less than or equal to 202. Remove this 2. 0.25 less than or equal to 2 power n plus 2 less than or equal to 202. 0.25 is 1 by 4, which is 2 power minus 2. This can be 2 power minus 2. 1 by 4 is 2 power minus 2, or n plus 2 could be minus 2, or n could be minus 4. Minus 4 plus 2 is minus 2. 2 power minus 2 is 0.25, that was. N could be minus 3. It could be minus 2, minus 1, 1, 2, 0, 1, 2, 3, 4, all of this. 2 power n plus 2 should be less than or equal to 202. 2 power 6 is 64. 2 power 7 is 128. 2 power 8 is 256. N plus 2 cannot be 8. N plus 2 could be 7, or n could go up to 5. Or satisfying this equation, n could be minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, all of that. Now let's look at this. 3 plus 3 power n plus 1. N going from minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. You can go till 5. Obvious one, this will work, 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 this will work. 3 power minus 1 plus 1 is 3 power 0, that will also work. Minus 2 plus 1 is 3 power minus 1, which is 1 by 3, that will not be an integer. These won't work. 5 positive integers, 0 and minus 1, 6 values of n will work. Sorry, 7 values of work. 1, 2, 3, 4, 5, 0, minus 1, 7 different values. For real number x, the condition modulus of 3x minus 20 plus modulus of 3x minus 40 equal to 20. And wonderful. I'm going to first simplify this and say modulus of x minus 20 by 3 plus modulus of x minus 40 by 3 equal to 20 by 3. Divide by 3 throughout, make life simpler for ourselves. We're dealing with x. What are we going to do? We know that if you have 2 points P and Q, distance between them is modulus of P minus Q, which is nothing but modulus of Q minus P. Right? Not P and 9 is P and Q. Now we have 20 by 3 and 40 by 3. The distance between them should be 20 by 3. Let's think about this. I'm going to plonk 20 by 3 on the number line, 40 by 3 on the number line. Nice. Now x to this, x to that should add up to 20 by 3. This distance is 20 by 3. 40 by 3 minus 20 by 3. Or x has to be a point in between these two. If it is here, this distance plus this distance is 20 by 3. If it is here, this plus this will be way more than that. Our x is between 20 by 3 and 40 by 3. This is where x should lie. Right? So now let's come to the question. So 20 by 3 less than x less than 40 by 3. 6.67 less than x less than 13.33. Obviously that's not there in the choices. But the question says for a real number x necessarily holds if 6 less than x less than 11 won't work. Because x by point x equal to 6.1, it won't work. 7 less than x less than 12, this could work. 10 less than x less than 15 won't work. X could be 14.2, it won't work. 9 less than x less than 14 won't work. X could be 13.9, it won't work. This is a subset of this. Therefore, that will work. Choice B, B for Bombay. One of the roots of the equation ax square minus bx plus c equal to 0 is 2 plus root 3. And the other root should be 2 minus root 3. A, B, C are rational numbers. A not equal to 0. B equal to C cube. Okay, sum of the roots is minus B by A. In this case, it's B by A, which is 4. Product of the roots is C by A, which is 2 plus root 3 into 2 minus root 3, which is 1. Or C equal to A. B equal to 4A. And B equal to C cube, or 4A equal to A cube, or 4 is A square. A is plus or minus 2. We want to find modulus of A, which is 2. Done. If 2 plus root 3 is a root, the other root is 2 minus root 3. Roots come in conjugate pair if we have rational numbers as coefficients. That's the first part. Ax square plus bx plus c equal to 0. Sum of the roots is minus b by a. Product of the roots is c by a. Done. Get through. For a sequence of real numbers x1, x2, x3 till xn, if x1 minus x2 plus x3 minus till all the way till here, n square plus 2n for all natural numbers n, then the sum x49 plus x50. All these questions, simple rule of thumb, find x1, find x2, find x3. Get through. x1 should be 1 square plus 2 into 1, 1 plus 2, 3. x1 plus x2 or x1 minus x2 minus x2 is 2 square plus 2 into 2, which is 8. x1 minus x2 plus x3 is 3 square plus 2 into 3, which is 9 plus 6, 15. This thing minus x4 is 4 square plus 2 into 4, which is 16 plus 8, 24. Nice. x1 is 3, x1 minus x2 is 8. 3 minus x2 is 8, or x2 is minus 5. x1 minus x2 is 8. Add x3, we get to 15, or x3 is 7. x2 is minus 5. x1 is 3. From 15, we subtract x4 to get 24. 15 minus x4 is 24, or x4 is 15 minus 24, which is minus 9. Nice, we've got ourselves a beautiful pattern. 3 minus 5, 7 minus 9, 11 minus 13. Alternate plus and minus, just a series of odd numbers. Then we sum x49 plus x50 equals. Very interesting. x49 plus x50. x1 plus x2 is minus 2. x3 plus x5 is minus 2. x3 plus x4 is minus 2. x5 plus x6 will be minus 2. Every pair of adjacent numbers that we're adding up will add up to minus 2. 3 minus 5 minus 2. 7 minus 9 minus 2. 11 minus 13 minus 2. So we keep on adding and getting the total to be minus 2 for each chunk. So x49 plus x50 is also equal to minus 2. Done. Get the numbers, see the pattern, plonk in, we are through. For a real number, if log a to the base 15 plus log a to the base 32 by log a to the base 15 into log a to the base 32 is 4. This is of the form a plus b by ab. I'm going to carve this out separately. 1 by log a to the base 32 plus 1 by log a to the base 15 is equal to 4. The first term by the whole denominator, second term by the whole denominator. The first time log a to the base 15 will get cancelled. Second time log a to the base 32 will get cancelled. 1 by log a to the base 32 is log 32 to the base a plus log 15 to the base a is 4. Nice. Or log of 32 into 15 to the base a is 4. Or a power 4 is 32 into 15, 480. A is 4th root of 480. Where should it lie? 4 power 4 is 16 square, 256. 5 power 4 is 625. 3 power 4 is 81. A is between two. A power 4 is between these two. A should lie between 4 and 5. 3x plus 2 mod y plus y equal to 7. X plus mod x plus 3y equal to 1. We want to find x plus 2y. First I said, look, can I add these two equations and get x plus 2y? Can I subtract one from the other and get x plus 2y? Tough, because there's a mod y here and a mod x here. They're not going to go away in a hurry. Right? So what do we have to do? One beautiful thing. So very simple idea. Mod a equal to a if a is greater than 0 equal to minus a if a is less than 0 equal to 0 when a is 0. And so we can use that idea. Then when x is positive, mod x will be x. When x is negative, mod x will be minus x. You can form different equations, then solve them. So we'll have to solve for x positive, y negative, x negative, y positive, both positive, both negative. We'll get 4 sets of simultaneous equations, solve them, and then the solution we get should satisfy this criteria. If it does, then we have an answer, then we can plug it. I said I have to solve the simultaneous equation 4 different variants. Now that is tricky, that's a pain in the neck. Maybe that's what they want us to do, which is fine, but then it's going to take time. One other thing that we can notice, x plus mod x, x plus mod x, x plus mod x, if we add x and mod x, it is going to be 0. X plus mod x will be 0 when x is negative. And so maybe there is something there. So what do? First of all, I'll put x as negative, that is these two, because then this goes to 0, and then see where that takes me. So if x is negative, this goes to 0, 3y is 1, y is 1 by 3. If y is 1 by 3, x is negative works, we are through. Let's go there to the first equation. 3x plus 2 mod y plus y is 7, y is 1 by 3. So 3x plus 2y plus y is 3y, y into 3 into 1 by 3 is 1, 7, 3x is 6, x is 2. This doesn't work. If I put x is negative, y is 1 by 3. If I put y is 1 by 3, I get x is 2. That doesn't work. So x is negative is not possible. Right? Now I have only 2 equations, both positive, both positive, x positive and y positive, x positive and y negative. Both positive, I'll have 3x plus 3y is 7 and 2x plus 3y is 1. I subtract 1 from the other, I'll get x is 6. If x is 6, 6 plus 6 is 12, 12 plus 3y is 1, 3y is minus 11, doesn't work. Y will have to be negative. X is positive, y is positive, does not yield any solution. X is negative, does not yield any solution. X positive, y negative. So we are looking for x positive, y negative. That is 3x minus 2y plus y is 7 and x plus 3y is 1. 3x minus y is 7, 2x plus 3y is 1. Multiply this by 3, 9x minus 3y is 21. Add these two, 11x is 22, x is 2. When we plug in x is 2, we should get y as negative. If we don't get y as negative, there's no solution. Done, game over. When x is 2, let's plug this in. 2 plus 2 is 4, plus 3y is 1. 3y is minus 3, y is minus 1. 2 comma minus 1 works. Then x plus 2y. 2 plus 2 into minus 1. 2 minus 2 is 0. This works. There is perhaps some juicy solution sitting here somewhere, but I don't know. We have brute forced it. We get the answer. We roll with it. So consider a sequence of real numbers x1, x2, x3 such that xn plus 1 is xn plus n minus 1 for n, all n greater than or equal to 1. x1 is minus 1 and x100 equal to. Start with n greater than or equal to 1. So let's say xn equal to 1. So x2 equals x1 plus 1 minus 1. x3 equals x2 plus 2 minus 1. x4 equals x3 plus 3 minus 1. So x1 equals minus 1. x2 is x1 plus 0. So x1 is minus 1. x2 is also minus 1. x3 is x2 plus 1, which is 0. x4 is x3 plus 2, which is 2. x5 is x4 plus 3, which is 5. x6 is x5 plus 4, which is 9. x7 is x6 plus 5, which is 14, and so on. And there are two ways of doing this. One is to write this equation down and then say, hey, I'm going to write all the way till x100 equals x99 plus 99 minus 1 plus 98. Beautiful set of equations. One where if you add all of these equations and add all of them up, so and there's an x2 here, x2 here, x3 here, x3 here, x4, x4, all the way to x99, everything will get cancelled. We will get quite simply x100 to be equal to x1 plus 0 plus 1 plus 2 all the way till 98. We know how to do this, so we can plug that in. What is the other way? We can find a pattern in these numbers. That's brilliant as well. 2, 5, 9, 14, very interesting. If you add 1 to these numbers, 1, 3, 6, 10, 15, that's very interesting. This just sum up to one natural number, sum up to two natural numbers, sum up to three natural numbers, sum up to four natural numbers, sum up to five natural numbers. x7 is sum up to five natural numbers minus 1. x6 is sum up to four natural numbers minus 1. x100 would be sum up to 98 natural numbers minus 1. x100 would be sum up to 98 natural numbers plus x1, which is minus 1, or x100 is equal to 1 plus 2 plus 3 all the way till 98 minus 1. This we know. This is 98 into 99 by 2 minus 1. 99 into 49 minus 1. Whatever that number turns out to be. 9 9s are 81, 1 8, 9 4s are 36, 441, 441, 1 5 8, 4851 minus 1, which is 4850. Lovely, lovely, lovely question. I got this wrong a number of times, not just once, a number of times. I simply didn't grab onto the funda. This xn plus 1 equal to xn plus n minus 1, beautifully carved out. So be very careful with the detail. Make sure this is marks in the back. If you focus and get the detail right, it should be doable. The number of distinct pairs of integers m, n satisfying this inequality. Wonderful, wonderful question. I really struggled with this one. First thing to know is mod a less than mod b is same as saying a square less than b square. One implies the other. That's the first step to do. That means we can say 1 plus mn the whole square is less than m plus n the whole square, or 1 square plus m square n square plus 2mn is less than m square plus n square plus 2mn. Nice, so far so good. This 2mn gets knocked off on both sides. 1 plus m square n square minus m square minus n square is less than 0, or 1 minus n square minus m square plus m square n square is less than 0. 1 minus n square minus m square times 1 minus n square is less than 0, or quite beautifully 1 minus m square into 1 minus n square is less than 0. Nice. We're looking at distinct pair of integers. Product of two numbers is less than 0. Either this is negative, this is positive, or the other way around. Right? So either this is negative and this is positive, or this is positive and this is negative. The beauty of this is 1 minus m square is negative. That is reasonable. Lots of numbers. 1 minus n square is positive. 1 square is 1. N can't be 1. It will become 0. 2, 3, 4, 5, it won't work. Only possibility where 1 minus n square is positive is when n equal to 0. Only possibility where 1 minus m square is negative is when m is 0. So m equal to 0, n greater than 1 works. If m or n were 1, this won't work, it will become 0. If m is 0, n greater than 1 works. Or n equals 0, m greater than 1 works. Nothing else is possible. If m and n are both more than 1, both will become negative, product will become positive. If either of them is 1, product will go to 0. That doesn't work. So one of them should be 0, other one should be greater than 1. So m0, n greater than 1, or n0, m greater than 1. That's a possibility. Now let's come back to this question. This is not n greater than 1. This is mod n greater than 1, mod m greater than 1. Because we're talking about n square. So plus 1 works and minus 1 work, plus 2 works and minus 2 will work. Plus and minus 1 will not work, plus 2 and minus 2 will work. Modulus of m plus n less than 5. This is an interesting thing. So let's attack that. Modulus of m plus n less than 5. If m is 0, mod n less than 5. When m is 0, mod n less than 5, n has to be greater than 1, be 2, 3, 4. N could be plus or minus 2, plus or minus 3, plus or minus 4. Exact opposite. If you put n equal to 0, we have mod m less than 5. We know mod m has to be more than 1. M could be plus or minus 2, plus or minus 3, plus or minus 4. So 0, 2, 0, minus 2, 0, 3, 0, minus 3, 0, 4, 0, minus 4. 6 possibilities, plus 6. 12 possibilities. Super tough question. Really tough question. So it's kind of question which says, okay, I'm not touching this. We square this, then we get somewhere. And still there's a couple of steps to go. And wonderfully tough question. F of x is x square minus 7x and g of x is x plus 3. Then the minimum value of f of g of x minus 3x. F of x plus 3 minus 3x. We need to minimize this. This is x plus 3 whole square minus 7 times x plus 3 minus 3x. Let's find this. X square plus 6x plus 9 minus 7x minus 21 minus 3x. This is x square. 6x minus 7x is minus x minus 4x minus 12. Simple completion of square. X square minus 4x plus 4. This is x square minus 4x plus 4 minus 4 minus 12. This is x minus 2 the whole square minus 16. We want to find the minimum possible value of x minus 2 whole square minus 16. That can happen when x minus 2 whole square goes to 0. The value will be minus 16. Complete the square. Think of it as a square plus a balancing term. We are through. Freebie. For natural numbers x, y and z, if xy plus yz is 19 and yz plus zx is 51, y into x plus z is 19 and z into x plus y is 51. We told very clearly that x, y and z are natural numbers. 19 can only be broken as 1 into 19 or 19 into 1. It cannot be 19 into 1. X plus z cannot be 1. X plus z is 19. Y is 1. Plug that in here. So z into x plus 1 is 51. This is not 51 into 1, x cannot be 0. Not 1 into 51, x is not 50, that we know. 3 into 17, 17 into 3, x plus z is 19. So x, z into x plus 1. This could be 17 into 2 plus 1. 17 plus 2 is 19, that works. You put z as 3, x equal to 16. Then x plus z is 19, 3 into 17 also works. So we could have a scenario where y is 1, x is 2, z is 17, or y is 1, x is 16, z is 3. So this is 17 into 3 or 3 into 17. Both ways it works. So it could be z is 17, x is 2 could work, or x is 16, z is 3 could work. Minimum possible value of x, y, z, multiply this is 48, this is 34. Product is lower in this case, which is 34. Lovely, done, true. Let a, b, c be non-zero real numbers such that p square less than 4ac. And f of x equal to ax square plus bx plus c. Beautiful. Ax square plus bx plus c is f of x. And b square is less than 4ac. When b square is less than 4ac, that means no roots are there. Discriminant is less than 0. The set S consists of all integers m such that f of m is less than 0. Then the set S must necessarily be a beautiful question. Fine. So I'm going to do this very differently and say let's draw the graph of this. So y-axis and x-axis. Ax square plus bx plus c is f of x. It will be a curve, right? It will be a parabola. It will be something like this. It could be here, it could be here, it could be here, it could be here, anywhere. And if it cuts the x-axis, then that means f of x goes to 0. That means if I put f of x is equal to 0, I have roots. There is some x for which y equal to 0, f of x equal to 0. But f of x cannot be 0 because this has no real roots. How do I know that? That is given. That means our beautiful looking parabola is got to be something that does not touch the x-axis. It's completely above the x-axis. Which means, if you think about it, what is the set of all integers such that f of m is less than 0? This is less than 0. Never. So set S should be an empty set. Except the curve could be like this, or quite brilliantly it could be like this. In which case, for all integers it will work, or for no integers it will work. So f of x is either always greater than 0 or is always less than 0. This can never go to 0. It's either always greater than 0 or always less than 0. That means if you put any set of all integers where it will be less than 0, it could be never. In this case, f of m will never be 0. Set of all integers where it goes to 0 is a null set. In this case, set of all integers where it goes to 0 is all possible integers. So set of all integers or the empty set, either the empty set or set of all integers. That's the right answer. Absolutely delightful question, especially if we can reframe this as a graph, as a diagram. If you know that a is negative, you have a curve like this. A is positive, you have a curve like this. Ax square plus bx plus c. If a is positive, then the curve is U-shaped. If A is negative, it's parabola shaped. It's umbrella shaped. Both cases it's a parabola. So it's like an umbrella, like an inverted U. It's a U. If specifically a curve like this has no roots, then this curve cannot touch the x-axis. That means it is either completely above the x-axis U-shaped or completely below the x-axis umbrella shaped or inverted U-shaped. So in this case it will be a null set, in this case it will be all sets. The largest real value of a for which the equation modulus of x plus a plus modulus of x minus 1 equal to 2 has an infinite number of solutions for x. Nice simple question. And so we have x here and 1 here. This is modulus of x minus 1. Modulus of x minus 1 is nothing but the distance between x and 1. It has an infinite number of solutions. Modulus of x minus 1 plus modulus of x plus a equal to 2. We'll think about x plus a, this, as modulus of x minus a. And so it will have infinite solutions. So if minus a were here, x could be here, put x equal to 2. And so now think about it. When will it have infinite solution? First of all, between 1 and minus a, the distance should be not 5 or 15 or 20. It should be small, right? Because this is modulus of x minus 1, this is modulus of x plus a. If minus a were 100, this distance itself is 99. It has infinite number of solutions. That gives us one beautiful getaway. It tells us that x should sit between 1 and minus a. We have 1 here, minus a here. This distance should be 2. x being anywhere here, this plus this will be 2. Or minus a could be here, this distance being 2, x being anywhere here, this distance plus this distance would be 2. And that is the kind of scenario we're looking for. And otherwise there will be a unique number of solutions, so values for which it will work. And an infinite number of solutions, we're basically saying we should be able to say x can be anywhere between 1 and a, and this will work. Anywhere between 1 and a, it will work. The distance will be 2. That means x is banged in between 1 and a. And the distance between 1 and a is 2. Sorry, not 1 and a, 1 and minus a. Or minus a could be 3, minus a could be minus 1. A is 1 or a is minus 3. Both of these will be possible. So we're either thinking x lies between 1 and 3 or thinking x lies between minus 1 and 1. So a is minus 3 or a is 1. Largest real value is 1. Minus 3 is not available. 1 works. So we're basically looking at a to be 2 units from 1. The distance between x and 1 is given. If 1 and a were 2 units apart, then x can be anywhere in between. This will hold good. We'll have an infinite number of solutions. And so the more algebraic way of doing it, saying I denote the turning points as minus a and plus 1. We know that mod x equal to x if x is greater than or equal to 0, into minus x if x is less than 0. We're basically saying I can say this x plus a plus x minus 1 equal to 2. That is one possibility. Where this is positive, this is positive. Or minus x minus a minus x plus 1 equal to 2. That both are negative. Or x plus a plus 1 minus x equal to 2. Or minus x minus a plus x minus 1 equal to 2. You solve for this, we get 2x equal to 3 minus a. We get 2 solutions. We get minus 2x equal to 1 plus a, we get 2 solutions. You solve for this, a plus 1 equal to 2, a is 1. You solve for this, we get minus a equal to 3, a is minus 3. If a were 1, if a were minus 3, any x will hold good here. That's what we are solving for. Therefore, a could be 1 or minus 3, largest value is 1. That's the algebraic brute force way of solving it. And again, a beautiful method, but the longer method works better. The visual method works better. For any real number x, let box of x be the largest integer less than or equal to x. If sigma n equal to 1 to n, sum of 1 by 5 plus n by 25 equal to 25, then n is. Understand these kind of questions, so I brute force them. What do? I put n equal to 3 between box of 1 by 5 plus 1 by 25 plus 1 by 5 plus 2 by 25 plus 1 by 5 plus 3 by 25. This is 0, 0, 0. This will be 0. When will this fellow is the largest integer less than or equal to x? That is, this greatest integer of 0.99999 is 0. Of 1.00001 is 1. Greatest integer of 1 is 1. When does it become 1? 1 by 5 here, this should be 4 by 5. If n were 20, that's when it will go to 1. Or if I put capital N equal to 20, 1 by 5 plus 1 by 25, 1 by 5 plus 2 by 25, 1 by 5 plus 3 by 25, all of them will be 0. 1 by 5 plus 20 by 25 will be 1. So if capital N were 20, this whole sigma thing, whatever this is, that will be 1. That's when it goes to 1. We want it to be 25. What will I do? So it has to be more than 20. Maybe I'll use 21 also. And this is 1 by 5. 1 by 5 plus 20 by 25. Greatest integer of this is 1. 1 by 5 plus 21 by 25. Greatest integer will be 1. Why? Slightly more than 1. True. This is 1 by 5. This should become 2. So I'm going to solve for 1 by 5 plus x by 25 equal to 2. X by 25 should be 9 by 5. X should be 45. When x goes to 45, it will become 2. Till then, it will be 1. I put 25, 26, starting from 20, 20, 21, 22, 23, 24, 25, 26, 27 till 44 will be 1. So I suppose I put, therefore now if I put capital N equal to 44, I am adding from N equal to 1 to 44. 1 to 19 there is nothing. 1 by 5, 1 by 5 plus 20 by 25. 1 by 5 plus 21 by 25. All the way till 1 by 5 plus 44 by 25. All of these give us 1, 1, 1, 1, 1 each. How many terms are there? 25 terms are there. If I put 45 by 25, it will go to 2. If I put n equal to 45, from 45 onwards, 45, 46, 47, all the way till 69, it will be 2. It will keep adding 2 to each sum. How many terms are there? 25 terms are there. Or when n equal to 44, the summation equal to 25, n is 44. Beautiful question. So how will this work? Suppose we had to do this as a function. We call this f of n. And so f of 1, f of 2, f of 3, all the way till f of 19 would be 0. F of 20 would be 1, f of 21 would be 2, f of 22 would be 3, f of 22 would be 4, f of 44 would be 25. F of 45 will become 27, 29, keep adding. When does it become 25? It becomes 25 and n is 44. Greatest integer function is a beautiful function. A square plus ab plus a is 14. B square plus ab plus b is 15. These questions are painful. The only thing that's giving my sanity here is a and b being natural numbers. That's very nice, beautiful to get. What do? We add both of these. Get a square plus 2ab plus b square plus a plus b is 42. Or a plus b whole square plus a plus b is 42. A plus b into a plus b plus 1 is 42. We put a plus b as x into x plus 1 is 42, or consecutive natural number. 6 into 7 is 42. A plus b is 6. This cannot be 3 and 3, because then these two will give us the same answer. A appears to be smaller. This is a square and a, this is b square and b. It becomes double. So a appears to be smaller. That's all. Put a as 2. Put a as 2, b as 4. 2 square plus 2 into 4 plus 2. 4 plus 8 plus 2. 14. Yep, that works. A is 2, b is 4. That should work. So what is 2a plus b2 into 2? 4 plus 4, 8. If we add these two, we get a plus b is 6. 3, 3 doesn't work. 2, 4 should work. And then we are through. We can solve this. We can say a is 6 minus b, substitute that here, get that quadratic, solve and get a. That's the other more algebraic method. We can snap out of it and simplify this. For any natural number n, suppose the sum of the first n terms in arithmetic progression is n plus 2n square. If the nth term of the progression is divisible by 9, then the smallest possible value of n is n plus 2n square. What I'm going to do, sum up to n terms is n plus 2n square. What will I do? I'll find sum up to one term. This is 1 plus 2, which is 3. And sum up to two terms. 2 plus 2 into 2 is 4, 4 into 2 is 8, 2 plus 8 is 10. Sum up to three terms. 3 plus 2 into 9 is 18. This is 21. Sum up to four terms is 4 plus 2 into 16 is 32. This is 36. Or the first term is 3. Second term is 10 minus 3 is 7. Third term is 21 minus 10 11. Fourth term is 15, and so on. Done. First term, sum up to one term, two term, subtract this minus this, that's the second term. This minus this, that's the third term. This minus this, that's the fourth term.
So we've got our sequence. If the nth term of the progression is divisible by 9, the smallest possible value of n is 3, 7, 11, 15 didn't work, 19, 23, 27, this works, 1, 2, 3, 4, 5, 6, 7, 7th term works. Find S1, S2, S3, S4. With that we have found term 1, term 2, term 3, term 4. With that we know the AP. Write down the AP. One term is multiple of 9. Get f of x equal to modulus of x minus p modulus of plus modulus of x minus 100 plus modulus of x minus a minus 50. Distance between x and a, distance between x and 100, distance between x and a plus 50. The maximum value of f of x becomes 100 when a is equal to. Very nice. So let's put 0, a, x, 100. So first of all, the maximum value possible in this function, this is modulus of x minus a, this is modulus of x minus 100 or 100 minus x, either way it won't matter. And then modulus of x minus of a plus 50. A plus 50 we are subtracting x, or from x we are subtracting a plus 50. And so this is the function. F of x is modulus of x minus a plus modulus of 100 minus x plus modulus of x minus a minus 50. When will this be maximum? For a given a, right? For a given a, this is 100 minus a, will be maximum when x is 100, because x minus a minus 50 is remaining, or a plus 50 minus x is remaining, one of these two. And so a plus 50 could be so small that x minus a plus 50 is remaining, or a plus 50 is large but x is even larger. From x to a plus 50, that distance is remaining. That is the remaining distance that we need to calculate. Finally, we need to include distance between x and a plus 50. Nice. This is built in, always equal to 100 minus a. Maximum distance between x and a plus 50, that will be the maximum of 100 plus x. Distance between x and a plus 50 plus 100 minus a is equal to f of x. 100 minus a is this, and this adds up to 100 minus a. Right? And distance between x comma a plus 50 plus 100 minus a is f of x. The maximum possible value of f of x becomes 100 when a is equal to. So maximum possible value of f of x becomes 100. So that means distance between x and a plus 50. Remember, a plus 50 could be higher than x, or x could be higher than a plus 50. And so when x is higher than a plus 50, the maximum value would be when x is 100. And so, and a plus 50 is some value. We find that out and come back. When a plus 50 is less than x, a plus 50 is this side, distance between x and a plus 50 is once again when x is 100, when a plus 50 is higher than x, when x is lesser and lesser. Right? That's when this happens. Now the maximum distance between x and a plus 50, a and a plus 50 lie somewhere, x is more than a, if it is less than a plus 50, I put x at a, that's when that distance will be 50. That's the maximum I can have. Put x at a, distance between x and a plus 50 can be as high as possible. X cannot go below a. So the maximum difference between x and a plus 50 is 50. That's the maximum possible. And so it cannot be more than 50. Because x cannot be less than a, that much we know. A and a plus 50 distance is 50. If x were greater than a plus 50, then we'll have 0, a plus 50, x. Then x and a plus 50 cannot have a distance of 50. Why? Because x, if a plus 50 were 50, x would be 100. That's not possible, because a plus 100 will be more than 100, because 0 less than or equal to a. So the maximum distance, this value maximum would be 50 when x is at a, and a to a plus 50 distance is 50. So this maximum is 50, or when the maximum goes to 100, 100 is equal to 50 plus 100 minus a, or this maximum is when a is equal to 50.
When we have a scenario where 0, 50, 100 and x is in between 50 and 100, in that case, the maximum value of f of x will be 100 minus a plus x minus of a plus 50. In which case, when x is 50, that's when the maximum will reach out to 100. Absolutely delightful question. Super difficult, super tough. Right? So we have to reframe this. Modulus of p minus q is the distance between p and q on the number line. That's a funda. You grab onto that, bunch of these questions become that little bit more doable. And that's something that we should look to grab onto. On day 1, there are 100 particles in a laboratory experiment. On day n, where n is greater than or equal to 2, 1 out of every n particles produces another particle. The total number of particles in the lab experiment increases to 1000 on day 1. Then day m, then m equals. Nice. This day 1, day 2, day 3, day 4, day m. And day 1, there are 100. What are the additions that happen? On day 2, 1 out of every 2 particles produces another particle. So on day 2, 100 to start with, half of 100 gets added. Half into 100. 50 get added. We'll have 150. Nice. What happens on day 3? We have 1 by 3, 1 by n. When n is 3, 1/3 of particles get added. What gets added? 1 by 3 into 150, which is 50. This becomes 200. Day 4, what gets added? 1 by 4th of 200, which is 50. This becomes 250. 1 by 5 of 250, 300. 1/6 of 300, 350, and so on. Or, quite simply, every day 50 particles get added. We start with 100. Somewhere down the line, we're going to hit 1000. 50, 50, 50, we keep adding every day. We have to add 900, or we add for 18 days. Number of times we add is 900 by 50. 50 added each day. 900 is 1000 minus 100. We started with 100, we need to add 900. 900 by 50 is 18. 18 times we add. On day 1, we have 100. Day 2, we add 50. Day 3, we add 50. 18 days we add. Our total number of days is 19. Very nice, juicy question. This description part is tricky, but otherwise the question is very simple. A lot of these questions put D1, D2, D3, D4, track, see, visualize, then we can simplify. The average of a non-decreasing sequence of n numbers, A1, A2, A3 till An is 300. If A1 is replaced by 6A1, the new average becomes 400. And the number of possible values of A1 is a nice, beautiful question. A non-decreasing sequence. What does it mean? It means A1 is less than or equal to A2, less than or equal to A3, less than or equal to A4, all the way till An. Something to keep in mind. We know that A1 plus A2 till An divided by n is 300. A1 is replaced by 6A1. 6A1 plus A2 till An divided by n, average will be higher, average is 400. Nice, excellent. Or A1 plus A2 till An is 300n. We'll rewrite it like this. Remove this. Say, hey, this is 300 times n. Say, this is 400n. Or if we subtract one from the other, we have 5A1 equals 100n, or A1 is 20 times n. Nice, brilliant. Now is where this question gets interesting. This part kicks in. A1 is 20n. A2 should be greater than or equal to 20n. A3 should be greater than or equal to 20n. Each of these entities is at least 20n. The smallest they can be is 20n. Right? And we know A1 plus A2, A3 till An is equal to 300n. Each of them is at least 20. Should be adding up to 300. You put all of them as 20. It's a minimum possible scenario. In that situation, adding up to 300, let's find what value n can take. Or if you say 20n into n, all of them are equal, we get to 300n. Or n is 30 by 250.
If n were 15, then each of the quantities could be 20n. And adding all of them up, we'll get 300n. Brilliant. That means if n were 16, a1 being 20n, get even 20, 20, 20, 20, 16, 20n. It's an extreme scenario. It will still add up to 320n. That's not possible. The maximum value n can take is 15. So n is the maximum value n can take. N is 15, we can find a1. a1 is 15 into n. We can find that. Can n be 14? Yeah, n can be 14. a1 would be 280. 14 into 20, 280. Adding the first 14 terms would be, average would be 300. Sum would be 300 into 14. We can find different combinations, it will work. N can be 14, 13, 12, all the way till 3, 2, 1. Just want to check the extreme condition, n equal to 1. If n were 1, there's only one term, then a1 is 300. 6a1 equal to 400. This is not possible. This doesn't work. So n cannot be 1. But everything else will work. N equal to 2. a1 plus a2 is 600. a1 is 2 into 15. Which is 30. a2 can be the remaining. This will work. Nothing wrong. So this can work. So a1 plus a2 being 600, n equal to 2 will work. From 15 all the way till 2 will work. 14 different values. N equal to 1 will not work. That doesn't work. So 14 different values. Absolutely beautiful question. Brilliant question. Let R and C be real numbers. If R and minus R are roots of 5x cubed plus cx square minus 10x plus 9 equal to 0, then C equals. Nice question. 5x cubed plus cx square minus 10x plus 9 equal to 0. Then the roots are R and minus R. Let the third root, the three roots, a cubic equation, the third root be P. Sum of the roots will be R plus minus R plus P equals minus C by 5. Minus of this by 5. Product of the roots taken 2 at a time, which is R into minus R plus RP minus RP equals minus 10 by 5 minus 2. Product of the roots R into minus R into P equals minus plus minus 9 by 5. Using these three equations, we should be able to find a value for C. Sum of the roots taken 2 at a time, 3 at a time. So R plus minus R is 0, P is minus C by 5. RP minus RP is 0, minus R square equals minus 2, R square equals 2, R is root 2. Here we have minus R square into P equals minus 9 by 5. Cancel off the minus. R square is 2. 2P equals 9 by 5. P is 9 by 10. We know P is minus C by 5. 9 by 10 equals minus C by 5. Or C equals minus 9 by 2. Nothing, no rocket science here. To manage the equations, manage some algebra, be comfortable with R minus R and P, sum of the roots, product of the roots taken sum of the roots taken multiplying 2 at a time, 3 at a time. Be careful with minuses and pluses, then we are through. Suppose for all integers x, there are two functions f and g such that f of x plus f of x minus 1 equal to 0 and g of x equal to x square. If f of x square minus x equal to 5, the value of f of g of 5 plus g of f of 5 is tough question. Let's simplify this. All integers x. So f of x plus f of x minus 1 equal to 1. That's what this is. G of x equal to x square, that is very easy. Nice. So I'm going to write a few equations. F of 2 plus f of 1 equals 1. F of 3 plus f of 2 equal to 1. F of 4 plus f of 3 equal to 1. And so on.
f of 2 plus f of 1 is f of 3 plus f of 2. Both of them have f of 2. Both are equal to 1, or f of 1 should be equal to f of 3. Both of these have f of 3, f of 2 should be equal to f of 4. Beautiful. F of 2 plus f of 1 is nothing but f of 2 plus f of 3. Both are 1. This plus this equals this plus this. F of 2 is common, or f of 1 is equal to f of 3. Between these two, f of 3 is common, f of 2 is equal to f of 4. Or we just extrapolate it beautifully. We'll get a wonderful equation, which is f of 1 equal to f of 3 equal to f of 5 equal to f of 7 equal to f of 9, and so on. Exactly same approach. We have f of 2 equal to f of 4 equal to f of 6 equal to f of 8, and so on. All even numbers, f of that will be same. All odd numbers, f of that will be same. Nice. We have f of x square minus x equal to 5. What am I going to do? I'm going to put x equal to 1. F of 1 square minus 1 equal to 5. F of 0 is 5. F of 2 square minus 2 is equal to 5. F of 2 is 5. 3 square minus 3 is f of 6, that is 5, or all even numbers. F of all even numbers is 5. So one part of the equation we have got all of these fellows are equal to 5. Nice. Now let's say this. F of 2 plus f of 1 is 1. F of 2 plus f of 1 is 1. This is 5. 5 plus f of 1 is 1. Or f of 1 is minus 4. Or we have a brilliant equation. F of even integer is 5. F of odd integer is minus 4. Brilliant. Now what do we need to find? We know g of x equal to x square. That is nice and comfortable. We want to find f of g of 5 and g of f of 5. F of g of 5 is f of 25. We want to find f of 25 plus g of f of 5. F of 25 is an even number. 25 is an odd number. F of 25 is minus 4. G of f of 5. F of 5 is an odd number. F of 5 is an odd number. So f of 5 will be minus 4. It is g of minus 4, which is minus 4 whole square. So it is minus 4 plus 16, which is 12. F of 25 is minus 4, f of 5 is also minus 4, both odd numbers. And so we know f of 25 is minus 4. G of f of 5 is g of minus 4, which is x square, minus 4 the whole square, 16, minus 4 plus 16. Beautiful question, delightful question. Not heavy duty function theory algebraically, but tons of common sense and very comfortable with putting numbers and playing with them and writing equations. That basic comfort level with writing this and then drawing this link and then saying, hey, all odd numbers are same, all even numbers are same. That is super important. The number of distinct integer values of n satisfying this is, and so this by this should be less than 0. Right? That means you could have a scenario where it is positive by negative or negative by positive. Nice. So what am I going to do? I'm going to think about when does this become positive and negative? When does this become positive and negative? I'm going to solve for 4 minus log n to the base 2 greater than 0. Okay. Or log n to the base 2 is less than 4. 2 power 4 is 16, n less than 16. N is less than 16, this is positive. N is equal to 16, this is 0. N greater than 16, this is negative. Same funda, this one. 3 minus log n to the base 4 greater than 0. Log n to the base 4 is less than 3. N less than 4 cube, 64. And so, if n is less than 16, this is positive. If n is less than 64, this is positive. So I'm going to break our world into 3 parts. Less than 16, 16 to 64, greater than 64. Nice. Less than 16, this is positive by positive. Greater than 64 will be negative by negative. This is negative, this is definitely negative. What happens at 16? At 16, this goes to 0. What happens at 64? At 64, this goes to infinity or undefined. So it is less than 0. So I'm worrying about 16 to 64. In this case, the denominator is positive, numerator is negative. This is the range we are looking for. 64 to 16, but without counting 16, without counting 64. Or 17, 18, 19, 20, 21, all the way to 63. The first 63 natural numbers, subtract the first 16, 47. 17 to 63, all the numbers included. 17, 18, 19, 20, 21, all the way to 63. Break it down to the three regions. Think about negative by positive, positive by negative. Here it is both positive, here it is both negative. In between it works for us. That's the first step. Then be careful about, hey, am I counting 16? Am I counting 64? Is it less than 0 or less than or equal to 0? I'll be a little careful with doing the math. Then you're through. All numbers from 16 to 64 or between 16 and 64 without counting 16, without counting 64. The number of integer solutions of the equation x square minus 10 whole part x square minus 3x minus 10 equal to 1 is a very beautiful question. First of all, something power 0 is 1. 1 power anything is 1. So what do we now need to do? We have to solve for this going to 1 or this going to 0. Get those values, substitute in the other part, and then see if it is logical, whether it makes sense. And so what I'm going to do, I'm going to solve two different equations. I'm going to say x square minus 3x minus 10 equal to 0. Get the answers. I'm going to find x square minus 10 equal to 1 and get the answers. And then think about simplifying this. Nice. So x square minus 3x minus 10 is 0, or x minus 5 into x plus 2 equal to 0. X is 5 or x is minus 2. If it are 5 square minus 10 whole power 0, that will be 1. If it are minus 2 square is 4 minus 10 minus 6 power 0, that is 1. So 5 works, minus 2 works. Nice, brilliant. 1 power anything is 1. That is super interesting. So we'll say x square minus 10 is 1, x square is 11, x is plus or minus root 11. The two possible values, this could be root 11, in which case that will be some irrational thing. Do we need to worry about it? I don't need to worry about it at all, because in this case, we talk about integer solutions. X equal to plus root 11 minus root 11 simply doesn't work. If something per something is 1, either this base should be 1 or that number there should be 0. Put base equal to 1, solve. The exponent should be 0, solve, we are through. Have I completed everything? No, I have not. There's one more possibility here, which is minus 1 square is 1, minus 1 per 4 is 1, minus 1 per an even number is 1. So there is a possibility of that happening, in which case I have to verify that. So I'm going to solve for x square minus 10 equal to minus 1, or x square equal to plus 10 minus 1, which is 9. That means x is equal to plus or minus 3. I got this far, but I cannot be sure that this will work, because for plus 3 and minus 3, my exponent should be an integer. More than that, it should be an even number. If it's an even number, then I am happy. But minus 1 per 101 will be minus 1. Minus 1 per 94 will be plus 1. So to substitute x equal to plus 3 minus 3, I have to verify whether it turns out to be an even number. Let's do that. This is x minus 5 into x plus 2. I put 3 minus 5 into 3 plus 2, which is minus 2 into 5, which is minus 10. Yeah, that works. I put minus 3 minus 5 into minus 3 plus 2, minus 8 into minus 1 equal to 8. This also works. Both are even numbers, both work. Therefore, x could be 3 or minus 3. We already got that x could be 5 or minus 2. So we have 5, minus 2, 3, minus 3. For 3 and minus 3, this goes to minus 1. That's an even number. We are very happy. For 5 and minus 2, this goes to some number that goes to 0. We are happy. 4 different values are possible. Beautiful question. Consider the arithmetic progression 3, 7, 11, 15, 19, etc. plus 4 plus 4 plus 4. And let a n denote the sum of the first n terms of this progression. Then the value of 1 by 25 summation times n equal to 1 to 25 times a n is. Very nice. We'll do the brute force method. So the progression is 3, 7, 11, 15. First term is, first term is 3, common difference is 4. Sum up to n terms is n by 2 times 2a plus n minus 1 into d. This is n by 2 times 2 into 3, 6 plus n minus 1 times 4. This is 4n minus 4, n by 2 times 6 plus 4n minus 4. 4n, this becomes 4n plus 2. This is n by 2 times 4n plus 2 or n times 2n plus 1. When n is 1, this is 1 into 3, 3, yeah. When n is 2, this is 2 into 5, 10, yeah, that works. Or an is n times 2n plus 1. We want to do sigma an and then do a 1 by 25 of it. 1 to 25 times, then divide by 25. So what do? I do summation an of 2n square plus n. 2 times sigma n square plus sigma n. 2 times n into n plus 1 into 2n plus 1 by 6 plus n into n plus 1 by 2. Into this I substitute n equal to 25 and then divide by 25. We have a 1 by 25 outside. Or this is just n. I'm going to do for 1 to 25. Or put n equal to 25 and do a 1 by 25. N is 25. So cancel 125 completely. 2 by 6 is 1 by 3. N plus 1 into 2n plus 1 by 3 plus n plus 1 by 2. Where n is 25, 26 into 51 by 3 plus 26 by 2. This is 13. 26 into 17. 17 6 are 102. 210. 17 into 2 is 34 plus 10. 44. 442 plus 13, which is 455. Just pure unadulterated raw brute force. I tried to do it by more elegant method. I didn't go anywhere. I didn't get anywhere. I thought I'll do 3 plus 7, 3 plus 7 plus 11, 3 plus 7 plus 11 plus 15, all of that. If I do sigma 1 to 25 an, my first term gets added 25 times, second term gets added 24 times, third term gets added 23 times, all the way to the 25th term, which just gets added 1 time. And then I divide by 25. I didn't go anywhere. I didn't get anywhere with that. I decided, look, I'm not doing any cute thing. Brute force it, get to the answer. F of x be a quadratic polynomial in x such that f of x is greater than or equal to 0 for all real numbers. And so, nice. So f of x is greater than or equal to 0 for all real numbers. It's something like this, curve like this. Right? So a curve that is completely above the x-axis, where it doesn't touch it. Because if f of x were 0 for some number, it will touch the x-axis. It will cut the x-axis. Wherever it goes to 0, it will cut the x-axis at those points. This is a graph like this. F of 2 equal to 0. Okay, f of 2 is equal to 0 and f of 4 is equal to 6. So f of 2 is equal to 0. What does it mean? I remove this. And I say, okay, this is not flying above the x-axis. It is touching the x-axis. F of at 2, it goes to 0. Okay? Or this has two roots, both at 2. This cuts off at 2. Or this is of the form x minus 2 whole square. It's a curve x minus 2 whole square. Now, f of 4 is 6. I thought it was x minus 2 whole square. I was very happy. I got f of 4 equal to 6. F of 4 is 2 minus 2 whole square, which is 4. It's not 6. And I said, look, it's not x minus 2 whole square. This is a curve which is k times x minus 2 whole square. It cuts at 2. It touches at 2. So there's two real roots, both at 2. This is from x minus 2 into x minus 2. X minus 2 whole square. Not just x minus 2 whole square. K times x minus 2 whole square. Right? That is this curve. Nice. F of 4 is 6. So k times 4 minus 2 whole square is 6. K times 4 is 6. K is 6 by 4, which is 3 by 2. Or our curve f of x is 3 by 2 times x minus 2 whole square. This will have f of x greater than or equal to 0 for all real values. This will have f of 2 equal to 0. This will have f of 4 equal to 6. Everything gets satisfied. F of minus 2 is equal to, so it's 3 by 2 times minus 2 the whole square minus 4 square, 3 by 2 into 16, 3 into 8, 24. The understanding of what that means, that f of x is greater than 0, that means flying above the x-axis. F of x is greater than or equal to 0, it could be flying or touching. It does completely greater than or equal to 0, but with 1 point equal to 0, that means it has real and equal roots, both roots being 2. It is of the form x minus 2 whole square. What do I mean of the form x minus 2 whole square? K times x minus 2 whole square. I wrote this down as x minus 2 whole square and I was like, this doesn't work. Like, no, it is a multiple of x minus 2. Suppose k is any integer such that the equation 2x square plus kx plus 5 equal to 0 has no real roots, and the equation x square plus k minus 5x plus 1 equal to 0 has two distinct real roots for x. Then the number of possible values of k's. The first one discriminant should be less than 0. Second one discriminant should be greater than 0. Not even greater than or equal to. When we attack it. For the first one, it is k square minus 4 into 2 into 5 is less than 0. That is k square is less than 40. So we're talking about 36 is the perfect square. We're talking about integers. So k goes from minus 6 to plus 6. We have 13 values with us here. Most likely 13 is not the answer because we have one more condition here. And the equation x square minus plus k minus 5x plus 1 is equal to has two distinct real roots. So k minus 5 the whole square is greater than 4. It's not even greater than or equal to 4, it is greater than 4. B square minus 4ac is greater than 0. And so k minus 5 the whole square is greater than 4. What values could this be? We have to simplify this. I think we can even substitute from there and then try it out. K minus 5 whole square or k minus 5 should be greater than 2, or k minus 5 is less than minus 2. K less than minus 2 plus 5 less than 3, or k greater than 7. K greater than 7 won't work. K less than 3 will work. K equal to 3 won't work. So we're talking about from 2 downwards the whole thing will work. Talking about 2, 1, 0 and then minus 1 to minus 6. Minus 6 to minus 1, 6 values. 0, 1, 2, all of them work. You put k equal to 0, 0 minus 5 the whole square, yeah, 1, 2, yeah, it works. So 9 values here, we're done. Discriminant greater than 0, discriminant less than 0, discriminant greater than 0. Simplify, we are through. Just integer solution, that's something we need to be careful about. The minimum possible value of x square minus 6x plus 10 by 3 minus x for x less than 3. Very, very nice question. This is not factorizable. Something is not factorizable. Factorizing is trick 1 in quadratic equation. Trick 2. Immediately after that is the idea of completion of squares. I'm going to write that number as x square minus 6x plus 9 plus 1 by 3 minus x. This is x minus 3 whole square plus 1 by 3 minus x. X minus 3 whole square, 3 minus x whole square, both are same. And so this is 3 minus x the whole square plus 1 by 3 minus x. We told very clearly that x is less than 3. So we can say x minus or 3 minus x is greater than 0, we can say 3 minus x equal to k. This becomes k square plus 1 by k, or k plus 1 by k. K plus 1 by k is either greater than or equal to 2 or less than or equal to minus 2. It cannot be less than or equal to minus 2 because we know x is less than 3, k is positive. And if k is positive, so the minimum possible value is 2 done through. We can rewrite this like this and then rejig this like this, we are through. Let r be a real number and f of x equal to 2x minus r if x is greater than or equal to r, and r if x is less than r. Very interesting. Equation f of x equal to f of x holds for all real values of x where blah 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 blah. And so let's do this. R be a real number, f of x equal to r if x is less than r. Let's say if this is r, so the graph will be x, f of x equal to r till here equal to 2x minus r. So at r it will become r. After that it keeps increasing. This is a graph like this. This is f of x. Nice. F of x equal to f of x holds good for all real values of x where x is less than or equal to r, x is greater than or equal to r, x is greater than r. So I'm worried about this because whenever f becomes greater than r, I'm in trouble. And so I don't really like this because if I put f of phi r, f of x equal to 2x minus r, 2 into phi r minus r, 10r minus r, 8r. F of 8r, 16r minus r is 15r. After this, f of x starts flying, becomes more and more. And so greater than or equal to r, greater than r, I don't like these two. F of x will not be equal to f of x. F of phi r is large. F of large as in f of phi r is 8r. 2 into phi r minus r. 2 into phi r minus r is 9r. Sorry. F of 9r is 2 into 9, 18 minus 1, 17r. It will keep becoming bigger. So at r, f of r is equal to r. That I know. F of r is equal to r. And so f of any number less than that, f of r by 2 is r. F of r is r. So I know that this won't work, this won't work. This work. X not equal to r doesn't work because greater than r doesn't work at all. It starts flying away. So this work, the diagram is super useful. Imagining it diagrammatically is super useful. Greater than r doesn't work. It starts flying away. So we come back and simplify it. Square root of 7 by 5 whole power 3x minus 5 is equal to 875 by 2401. 4a by b power 6x minus y equals 2a by b power y minus 6x. Seems like a rather tough question, but it's actually not. And so 4a by b for all non-zero real values of a and b. And so this, I know 2401 is a power of 7. That really helps. 49 square is 2401. So this is 7 power 4. And I was looking for this being a power of 5, which it was not. But 875 I know is 1000 into 7 by 8. And so this number can be written as 125 into 7 by 7 power 4. Or this is 5 by 7 whole cube is equal to 7 by 5 whole power 3x minus y by 2, square root of 7 by 5. And so this is 5 by 7 whole cube, this is 7 by 5 power this. So this number is 7 by 5 power minus 1 is 5 by 7. 7 by 5 power minus 2 is 5 by 7 whole square. So this becomes minus of this and it should become equal to this. So I can rewrite this as this is 5 by 7 whole power y minus 3x by 2 minus of that is equal to 5 by 7 whole cube. Beautiful question because you have to crack that thing. Or y minus 3x by 2 is this, y minus 3x is equal to 6. Y minus 3x by 2 is equal to this. This question I got confused because there's a 4a by b here and a 2a by b here. But this says for all non-zero real values of a and b, for all values this is equal, or this should be 0, this should be 0. Both should go to 0. Therefore, anything power 0 is anything power 0. It goes to 1, doesn't work. It goes to 2, it doesn't work. for all values of non-zero values of a and b. So there's going to be an a and b remaining. Even if I put a and b to in some form the power to be equal, there's a 4 and 2 remaining. The only thing that will work is 0. 6x minus y should be equal to y minus 6x equal to 0, or y is equal to 6x. 6x minus 3x is equal to 6. 3x is 6, x is 2, y is 12. X equal to 2, y equal to 12 satisfies all of this. Value of x plus y is 2 plus 12, 14. If 3 plus 2 root 2 is the root of the equation ax square plus bx plus c equal to 0, and 4 plus 2 root 3 is the root of the equation ay square plus my plus n equal to 0, where a, b, c, m, n are integers, then what is the value of this thing? Very simple. If 3 plus 2 root 2 is a root, then the other root is 3 minus 2 root 2, and the conjugate pair. If 4 plus 2 root 3 is a root, 4 minus 2 root 3 is a root. What is the sum of the roots? The first one, the roots are 3 plus 2 root 2 and 3 minus 2 root 2. So minus b by a is equal to 6. Right. What is the product of the roots? Product of the roots is c by a. 3 plus 2 root 2 into 3 minus root 2 root 2. 3 square minus 2 root 2 square. 3 square is 9, 2 root 2 square is 8. 9 minus 8 is 1. Second one, the roots are 4 plus 2 root 3 and 4 minus 2 root 3. Sum of the roots is minus m by a. This is 4 plus 4, 8. Product of the roots is n by a. 4 into 4 is 16 minus 2 root 3 into 2 root 3. 2 square into 3, 12. 16 minus 12 is 4. Nice. We need to do b by m. So what is b? B is, everything can be written in terms of a. B is minus 6a, c equals a, m is minus 8a, and n is 4a. B by m is minus 6a by minus 8a, which is nice, which is 3 by 4, plus c minus 2b, which is a minus minus 6a, divided by n, which is 4a, minus 2b, a minus 2 into minus 6a, minus 6a into 2. Let me make it very clear, there's some ambiguity here, minus 6a into 2. Lovely. This is 3 by 4. A minus minus 12a is a plus 12a, 13 by 4. So 3 by 4 plus 13 by 4. This is 3 by 4, that is 13 by 4. 3 by 4 plus 13 by 4 is 16 by 4, which is 4. It all worked out rather well for us. Thank you. Nothing but the understanding that roots come in conjugate pairs, and the idea that sum of the roots is minus b by a, product of the roots is c by a. Plonk it in, get through. Let's like this. 16x by y, 16x by y plus 49y by x. We rewrite this like this. Let's say x by y is k, then y by x is 1 by k. So this number is 16k plus 49 by k. Fine, so nice, wonderful. So I can say 16k plus 49k by 2 is greater than or equal to square root of 16k into 49 by k. Arithmetic mean of these two is greater than or equal to geometric mean of that. Or subtract that and make create a perfect square and then simplify that. And so this is assuming k is positive. If k were negative, it will be correspondingly the other way around, going down. And so 16k plus 49k by 2 is greater than or equal to this. Cancel this. This is 4, that is 7, greater than or equal to 28. 16k plus 49 by k is greater than or equal to 56. Or 16k plus 49 by k less than or equal to minus 56. If k were negative, I can establish this. Right, so it's either greater than or equal to 56 or less than or equal to minus 56. So greater than or equal to 56, this is possible. Less than or equal to minus 56, this is possible, this is possible. This here is not possible. So I have a scenario where 16k plus 49k by 2 is greater than or equal to square root of ab, then simplify it accordingly. And so very much like everybody knows this rule, which is say y plus 1 by y is greater than or equal to 2 or less than or equal to minus 2.
This is very much like that. Very much like that. Just a slightly changed numbers. Nothing more than that. Fine. So 16x by y, 49y by x. Very much we're writing it as 16k plus 49 by k greater than or equal to 56, less than or equal to minus 56. That's what we're doing. And so simplifying it like that, rewriting it, rejigging it like that. The average of all 3-digit terms in the arithmetic progression, 38, 55, 72, etc., etc., etc. Plus 17, plus 17, plus 17. I'm going to call this as 34 plus 4, 55 plus 4, 68 plus 4, 102 plus 4 will be our first term. Right, so how do we find our last term? We take 999 divided by 17, see what is remaining, goes 5 times 85, 149. Can it go 9 times? No, it cannot. It go 8 times, 136. Remaining is 13. So that is 17 into 58 is 986. We've got that much. So the last term here is going to be 986 plus 4. The first term is 106. The last term is 990. We have a bunch of terms in between. How many terms are there in between? We can find that this is 58th term. This is 17 into 6. 58 minus 5 is 53 terms are there. To be honest, we don't need all of that because we want to find only the average of this term. Sum of all of these terms are going to be n by 2 into first term plus last term. Average of all of this is going to be n by 2, the first term plus last term, divided by n. Square root of 5x plus 9 plus square root of 5x minus 9 is 3 times 2 plus root 2, then square root of 10x plus 9 equal to 5. I struggled. Again, I struggled with this. Then I got cute and I said, look, can I do some jugad thing? I said, look, there's somebody setting the paper. It's possible that this gets mapped to this and this gets mapped to this. Hey, it is possible. So square root of 5x plus 9 is 6. Square root of 5x minus 9 equal to 3 root 2. 5x plus 9 should be 36. 5x plus 9 is 36. 5x is 27. 27 minus 9 is 18. Square root of 18 is 3 root 2. That is indeed right. It is true. So 5x is 27. We are through. Right? This is a cheating method. Right? So every now and then it really helps. But I'm not going to give you the solution based on this method. From an exam context, you need to be street smart and say, look, maybe whoever is setting the question has put this as this, put this as this, and said, look, let's jump around and play. It need not have been like this. The answer, this could have been 4 minus 2 root 2, and this could have been 2 plus 2 root 2, whatever, 2 plus root 2 to add everything up and bring it back together. And so it need not have worked. In this case, it works. I just map this to this, map this to this, it worked, I'm through. And I can find the answer. Obviously, I can't do it like this. The textbook method is to say, hey, square this, and then find that and simplify. Fine. So that's another beautiful method which Venkatesh friend pointed out to me. It's a beautiful method. This is a plus b. If I multiply that with a minus b, I'll get a square minus b square. Brilliant. So I'm treating this as a plus b. Root of 5x plus 9 plus root of 5x minus 9. Root of 5x plus 9 is a. Root of 5x minus 9 is b. I'll multiply by root of 5x plus 9 minus root of 5x minus 9. This will be equal to 5x plus 9 minus of 5x minus 9. Minus 5x plus 9. The beauty here is this side has x disappearing. This is 18. And this we know is 3 times 2 plus root 2 into this is 18, which is brilliant because first of all we cancel the 3, this is 6. So this expression, square root of 5x plus 9 minus square root of 5x minus 9, which I'm going to call it as a and minus b from now on,
That is nothing but 6 divided by 2 plus root 2. Multiply by 2 minus root 2, divide by 2 minus root 2. 2 plus root 2 into 2 minus root 2 is 4 minus 2, which is 2. This by this is 3. So a minus b is 3 times 2 minus root 2. A plus b is 3 times 2 plus root 2. Which is all very nice. Add these two, we get 2a equals 6 plus 6, 12, or a is 6, or square root of 5x plus 9 is equal to 6, or 5x plus 9 is 36, or 5x is 27. What do we need to find? Square root of 10x plus 9, 10x is 54, square root of 10x plus 9 is square root of 63, which is 3 root 7. Obviously, we came back at the same point. Square root of 5 plus 9 is 6. If you remember, this is where we started and said, look. So obviously, the cheating method or just plumping for it or just having your wits to just try out something sometimes works magically well. Not foolproof, not elegant, not perfect, not the way to learn this thing. But as you get some practice, understand that it's a competitive exam and you can poke around and get some answers. Super powerful. It's like a proper superpower. You get a couple of questions by cheating, then. But cheating, I don't mean taking a bit of paper and copying the answer. Cheating is like not doing it rigorously from first principle, but finding some jugaad to do, go from answer choices or plugging in some values and trying it out. Right? So probably cheating is probably a very strong word. And you understand what I'm saying. Right? So poke around. This is very nice saying. Poke around and find out. Right? So like that. And I'm using the word poke around for politically correct reasons. Nice. So this is a good question, super tough. The other method for this is square this. You'll get an expression which is 2 root of 25x square minus 9. Bring everything to one side, square again, you'll get it. I did that method by substituting 5x equal to k. It's 5x, otherwise if you're dealing with 25x square, you can deal with k square, simpler. Numbers are simpler, juicier. Square once, bring everything to one side, square again, k square gets cancelled, solve, get k, get to 5x, k to 10x, simplify. If x and y are positive real numbers such that log of x square plus 12 to the base x is 4 and log of x to the 3 times log of x to the base y is 1, then x plus y equals. Nice. First of all, that equation gives us x square plus 12 equals x power 4, or x power 4 minus x square plus 12 equal to 0. X power 4 equals x square plus 12. So x power 4 minus x square, minus 12 equal to 0. 12 can be broken as minus 3 and plus 4. So this will nicely, beautifully become x power 4 minus 4, x square minus 4 into x square plus 3 equal to 0. X square cannot be minus 3, so x square is 4, x is plus or minus 2. That's what we get from there. It cannot be minus 2 because the base is x, therefore x is 2. Nice, we just solved that quadratic equation in x square, simplify, we get x is 2. Then 3 log x to the base y is 1, so y power 1 equals x cube. Y is x cube, x is 2, y is 8. We want to find x plus y, 8 plus 2, 10, 10. It seems like a very tough question, but it's not. Frame that expression in terms of exponents, solve for a quadratic in x square, we get x square is 4. X is plus or minus 2, it cannot be minus 2 because there is a base x sitting there, x is only 2. This one straight away gives us y equal to x cube, we are through. Number of integer solutions to the equation 2 power mod x into x square plus 1 equals 5x square. Nice question. First of all, we realize there is mod x here, there is x square here, there is x square here. If x equal to k works, x equal to minus k will work. If positive works, negative will work. If plus 2 works, minus 2 will work. If plus 11.3 works, minus 11.3 will work. Right? We can treat this as a quadratic in mod x or an equation in mod x. That way we can cancel everything merely. Understand that mod x, the whole square, is nothing but x square. So if we say mod x equal to y, 2 times y square plus 1 is 5y square. I can cancel a y. I can cancel a y, keeping in mind that y could be 0. 0 works. And then we have, oopsie, 2y square plus 2 equals 5y. 2y square minus 5y plus 2 equal to 0. So 2y square minus 4y minus y plus 2 equal to 0. 2y into y minus 2 minus 1 into y minus 2 is 0. So y is half or 2. There's already a 0 that's possible. 0, half and 2, that works. This is y, which is mod x. So x could be plus or minus half, plus or minus 2 or 0. 5 different values are possible, but the question says number of integer solutions. Plus or minus half won't work. Minus 2 plus 2, 0. 3 different values. So 3 values of x work. Alpha and beta will be the two distinct roots of the equation 2x square minus 6x plus k equal to 0, such that alpha plus beta and alpha beta are the distinct roots of the equation x square plus px plus p equal to 0. Then the value of 8 times k minus p is equal to alpha plus beta and alpha beta are distinct roots. Alpha and beta are distinct roots of this equation. So alpha plus beta is minus b by a minus of minus 6 by 2, which is 3. Alpha beta is k by 2. Alpha beta and alpha beta are distinct roots of this equation. So 3 plus 3 comma k by 2 are distinct roots of this equation. So 3 plus k by 2 equal to minus p. 3 times k by 2 is equal to plus p. I'm going to substitute that here. 3 equals minus p minus 3k by 2. So minus p is minus 3k by 2 minus k by 2. Or 6 equals minus 4k. K equals minus 3 by 2. 3k by 2 is p, or p equals 3 into minus 3 by 2. Sorry, 3 by 2 into minus 3 by 2, which is minus 9 by 4. 8 times k minus p. When you're doing 8 times minus 3 by 2 minus 9 by 4. 8 times 9 by 4 minus 6 by 4. 8 times 3 by 4. 8 times 3 by 4 of 8, which is 6. 8 into 3 by 4, which is 6. Just brute force this. Sum of the roots is minus b by a, product of the roots is c by a. Plug that in, keep solving it, we are through. X cube plus 2r plus 1 x square plus 4r minus 1 into x plus 2 equal to 0 has minus 2 as one of the roots. The other two roots are real, then the minimum value. We've got x equal to minus 2 as one of the roots. So I thought, nice, let me just plug equal to x equal to minus 2, see where it goes. Maybe we'll be able to solve for r, and that r is the answer. You get r equal to 4, that's the answer. Minimum non-negative integer value. R has only one value, we are through. Substitute x equal to minus 2 here, we have minus 8 plus 2r plus 1 into 4 plus 4r minus 1 into minus 2 plus 2 equal to 0. Solve for r, we are through. Right? Oops. Minus 8 plus 8r plus 4 minus 8r plus 2 equal to 0. 4 plus 2 is 8. So minus 8 goes off. 8r minus 8r is 0. So this equation works, but quite lovely, we get that this is independent of r. We cannot solve for r. What it's telling us is that that giant expression has x plus 2 as a factor, or x equal to minus 2 works no matter what value of r we take. So we hit a dead end here. Not solving for r and getting something. But you're on to something. We go to the next step and say, hey, we have x cube plus 2r plus 1 times x square plus 4r minus 1 times x plus 2. For this expression, x plus 2 is a factor. Substitute p of minus 2, that is 0, or minus 2 is a root, x plus 2 is a factor. So let's factorize this. Then x square goes here. This is x cube plus 2x square. We subtract this, 2r x square will come, plus x square minus 2x square. So 2r minus 1 times x square plus 4r minus 1 times x. We bring down the next term. We have an x here, you have to have 2r minus 1 x square. So plus 2r minus 1 times x. So what do we get here? 2r minus 1 times x square plus 2 into 2r minus 1, which is 4r minus 2 times x. We subtract this. This goes away completely, just like how this went off. 4r minus 1 minus of 4r minus 2. 4r goes off, minus 1 plus 2. This is x plus 2. So plus 1, this gives us an x plus 2. Quite lovely. This expression can be written as x plus 2 into this expression. Now this expression, x square plus 2r minus 1 times x plus 1, has two real roots. They could be just two, the other two roots are real. And so super lovely. So I have an expression which is x square plus 2r minus 1 times x plus 1 equal to 0. This has real roots. Two roots are real. That means b square minus 4ac should be greater than or equal to 0. We solve that, we get an inequality in R that we can solve here through. So b square is 2r minus 1 the whole square, 4r square minus 4r plus 1 minus 4 into 1 is greater than or equal to 0. Or 4r square minus 4r minus 3 is greater than or equal to 0. We should be able to factorize this. 4 into minus 3 is 12, minus 6r plus 2r will work. So 4r square plus 2r minus 6r minus 3 is greater than or equal to 0. 2r to 2r plus 1 minus 3 into 2r plus 1 is greater than or equal to 0. 2r minus 3 into 2r plus 1 is greater than or equal to 0. So x is either r is greater than or equal to 3 by 2 or r is less than or equal to minus r. Outside of the two roots, we want the minimum possible non-negative integer value. So this side is out, negative. It should be greater than or equal to 3 by 2, greater than or equal to 1.5. So minimum integer value is 2. Super tough question, super time consuming. We take this big polynomial, divide it by x plus 2, get a quadratic expression. That quadratic expression has real roots, discriminant should be greater than or equal to 0. Plug in the discriminant value, get a quadratic inequality in R, and then say R should be less than or equal to minus half or greater than or equal to 3 by 2. Then we look for the minimum possible non-negative integer value. So less than or equal to minus half, we forget about it. Greater than or equal to 1.5. 2 is the smallest possible positive integer value, non-negative integer value. Answer 2. For some positive and distinct real numbers, there is x not equal to y not equal to z. 1 by root y plus root z is the arithmetic mean of root x plus root z and root x plus root y. Then the relationship which will always hold true is y, x and z are in arithmetic progression, root x, root y, root z are in arithmetic progression, x, y and z are in arithmetic progression, root x, root z, root y are in arithmetic progression. And so all are arithmetic progression, which is very nice. Very happy with that. Sometimes they give AP, GP, HP and bore the hell out of us. Root y plus root z is a meaning of root x plus root z and root x plus root y. Z and y are symmetric. That means x should be in the middle. So I'm already thinking the sequence should be y x z or z x y. One of the two. So x should be in the middle. This is possible. This is not possible, this is not possible, this is not possible, this is our answer, none. Obviously, in an exam context, I am trying to be street smart in doing this. But now when we are solving it, we are going to try to see if this can work. Right? The two approaches to it, we have guessed it, and then plug it in. Y, x and z are in arithmetic progression. So say, hey, I could take x, y and z to be 1, 2, 3, 2, 3, 4, 3, 4, 5 and then validate this. That's a possibility. Or take x as y as x minus d, x, z as x plus d, and then simplify this and see where it takes you. Those are the approaches that we can take because we know that this looks like the answer. With other three, x is not even in the middle. I can eliminate that. Right? Otherwise, what do? We know that root y, 1 by root y plus root z, 1 by root x plus root z, 1 by root x plus root y are in arithmetic progression. How do we know that? Because that middle term is the arithmetic mean of these two. This number is this plus this by 2. Or if I think about it differently, root x plus root z, root y plus root z, root x plus root y are in harmonic progression. Reciprocals of these are in AP, or these three are in HP. The definition of harmonic progression. If you have A, B, C in A something B in harmonic progression, should be the harmonic mean, which is 2AB by A plus B. Or we can say root y plus root z equals 2 times root x plus root z into root x plus root y divided by A plus B, this plus that. 2 root x plus root y plus root z. We cross multiply and then just see where it takes us. Root y plus root z whole square, which will be y plus z plus 2 root yz plus 2 root xy plus 2 root zy equals 2 times root x into root x is x plus root xy plus root zx plus root zy. Nice, this is equal to that, which is nice. 2 root yz, 2 root xy, 2 root zy, 2 root xy, 2 root zx, 2 root zy. Nice and symmetric on both sides. So what am I going to do? I'm going to just knock this off. Or y plus z equals 2x. Y plus z by 2 is equal to x. X is the arithmetic mean of y and z, or y, x and z are in arithmetic progression. Choice 1, choice A. I struggled long and hard to establish this. It took me a while to punt the answer, verify the answer, substitute with x plus 2x minus d, then do brute force in several layers, then come to this solution. So it's not one solution which is like this. This is not how I thought about it. I arrived at it after like long struggle. Any non-zero real numbers x, y such that y not equal to 3 and x by y less than x plus 3 by y minus 3 will satisfy the condition. X by y less than y by x, no, not required. So first instinct for me was to say, hey, numerator is increasing, denominator is decreasing. This will happen as long as we don't have to go into negative territory. And so suppose I say take 10 by 7, this will become 10 plus 3 by 7 minus 3. If both are positive, that will naturally happen. This is x and y are positive, x plus 3 and y minus 3 are positive. X is greater than 0, y is greater than 3, this will always hold good. First instinct. Right? I'm saying, okay, no, but these choices are really weird. So let's get down slightly algebraically on this. Let me remove this and attack this. So what am I going to do? I'm going to say x by y minus x plus 3 by y minus 3 is less than 0. xy minus 3y minus xy minus 3x by y into y minus 3 is less than 0. xy minus 3x minus xy minus 3y. I made a mistake here. I will fix that. Should be y. So xy gets knocked off. Minus 3x minus 3y by y into y minus 3 less than 0. 3 can knock off, so I know I have that x plus y by y into y minus 3 is greater than 0.
Now I can think about y into y minus 3 being greater than 0, this also being positive, y into y minus 3 being less than 0, this also being positive. Y into y minus 3 when will be greater than 0? When y is negative or y is greater than 0. So y less than 0 or y greater than 3, x plus y greater than 0, this will work. Or y between 0 and 3, x plus y less than 0, this will work. Either both should be positive or both should be negative. Okay. Now let's look at the choices. X by y less than y by x, not required. I can have a scenario where I said 10 by 7, x is 10, y is 7, or x is 7, y is 10, both will hold good. It's not required. If y is greater than 10, then minus x is greater than y, x plus y less than 0, no. Here this will become, this x plus y less than 0, it should be greater than 0, it doesn't work. If x is less than 0, then x plus y greater than 0, x plus y greater than 0, x less than 0 has got nothing to do with x less than 0, x plus y greater than 0, then we should have a condition with y. Not this, not for sure. I mean, cannot be sure about this, we can come back to it. X plus y greater than 0, y less than 0, nice. X plus y greater than 0 and y less than 0, yep, this will work. This holds good, then that will good. Any non-zero numbers x and y will satisfy the condition. If this holds good, then that will hold good. X less than 0, x plus y greater than 0 will work. Sorry, y less than 0, x plus y greater than 0 will work. Possible values of x satisfying the equation. I really struggled with this function. I thought I could split this, do a solve for a quadratic, so multiplied these two. So 2 power 4x square plus 2x plus 30 is the product of these two, and then 2x square plus x plus 16. This is 2x square plus x plus 16. So I can break this as 2 power 2x square plus x plus 15, and then 2 power 2x square plus x plus 15. If I add these two, 2x square plus x plus 15 plus 2x square plus x plus 15 is 4x square is 2x square plus x plus 16, this into 2, that will be this. If I multiply these two, I will get 4x square plus 2x plus 30, yes, that works. I struggled long and hard for this. I tried to factorize this, but exponent rules work differently. If I multiply these two, I get this 4x square plus 2x plus 30. Product of splitting the middle term, this into this should be equal to 2 parts of writing this. And so both of these parts are equal, or I can now say I can extract this out of this. Let's say both of these parts are equal, or this is some kind of perfect square type thing. This is of the form x minus y the whole square. This is 2xy, this is x square minus 2xy plus y square, or 2 power 2x square minus 2 power x plus 15 the whole square. If I think about that, 2 power 2x square whole square is 2 power 4x square minus 2 into 2 power 2x square into 2 power 2x plus 15 no, only x plus 15, I'm squaring this, sorry. Plus 2 power x plus 15 the whole square. I'm just verifying this. This becomes 2 power 2x plus 30, that works. This stays as 2 power 4x square, this works. This becomes minus 2 power 2x square plus 2x plus 15 plus 1. 2x square plus x plus 15 plus 1
should be x plus 15 plus 1. I made a mistake there. 2x square plus x plus 16. Yes, this works perfectly. Or our expression is this. This is nothing but 2 power 2x square minus 2 power x plus 15 the whole square equal to 0. These two should be equal, so we're basically saying 2x square minus x minus 15 is equal to 0. Product is 30, difference is x, so 2x square minus 6x plus 5x minus 15 equal to 0. 2x into x minus 3 plus 5 into x minus 3 equal to 0. 2x plus 5 into x minus 3 is equal to 0. X is minus 5 by 2 or plus 3. Sum of all possible values of x satisfying the equation. All possible values of x minus 5 by 2 plus 3, which is half. Hopefully half is there among the choices. Yes, indeed it is there. Let a, b and m be m and n be natural numbers such that a greater than 1, b greater than 1. If a power m plus into b power n is 144 power 145. The largest possible value of n minus m. Very, very interesting. So a power m into b power n is 2 power 4 into 3 square whole power 145. Or it is 2 power 580 into 3 power 290. First cut I thought, hey, a should be 2, b should be 3, or b should be 2, a should be 3. And so that is a nice and simple question. Largest possible value of n minus m. Have n as high as possible, m as low as possible. We are through. So I can say this is equal to a could be 3 power 290 and 2 power 580. This is work. N is 580, m is 290, n minus m is 580 minus 290, 290. We have to pause a second. And so we have not been told that a and b are prime. So this number 2 power 580 can be written as 4 power 290. This can be written as 9 power 145. This can be written as 8 power 145. This can be written as 145 9 power 5 whole power 29. So many different combinations are there. A and b need not be 2 and 3 or 3 and 2. Doesn't work like that. Now let's see. We want n to be as high as possible. So it really helps if we put b as 2. That is the maximum value we can go to. N max is 580. Let's plonk n as high. Put it in there. M should be minimum. So I can say, I can think of it as 9 power 145. M could be 145. Or 9 power 5 whole power 29. N could be 29. Or, quite interestingly, I can think of it as 3 power 290 whole power 1. Or M minimum is equal to 1. N max is 580. M minimum is 1. This could go as high as 579. Beautiful question. We're basically taking the lesser of the two primes, stick it under B, maximize N, larger of the two prime, but don't really chase the prime. Plonk A as the entire 3 power 290, M will be 1. So 579 is the answer. For some positive real number x, if log x to the base root 3 plus log 25 to the base x by log 0.008 to the base x is equal to 16 by 3, then the value of this. Log a to the base b by log c to the base b, this is log of 25 to the base 0.008. 0.008 is 8 by 1000, which is 1 by 125. So, or this is log 5 square to the base 5 power minus 3, which I can reimagine it as log 5 square by log 5 power minus 3, both to the base 5. Or this is 2 by minus 3, minus 2 by 3. So the middle expression is minus 2 by 3, or log x to the base root 3 minus 2 by 3 is 16 by 3. This goes this side, becomes 18 by 3, which is 6. Log x to the base root 3 is equal to 6. X is root 3 power 6, which is 3 cube. Now what is log to the base 3 of 3 into 3 cube square to 3 power 6, or log to the base 3 of 3 power 7? This is 7. Answer should be 7. Nice and simple. If you know logarithm properties, we're through. Romping. Let k be the largest integer such that the equation x minus 1 whole square plus 2kx plus 11 equal to 0 has no real roots. If y is a positive real number, then the least possible value of k by 4y plus 9y is fine. Doable question. Expand this. This becomes x square minus 2x plus 1 plus 2kx plus 11 equal to 0, which is x square plus 2k minus 2, 2 times k minus 1 times x plus 12 equal to 0. This has no real roots, so discriminant is less than 0. B square minus 4ac is negative, or b square is less than 4ac. 4 times k minus 1 whole square is less than 4 times 12. K minus 1 whole square is less than 12. K be the largest integer such that this works. So k minus 1, I'm thinking about positive integers because that works better. K minus 1 could be 3. K minus 1 should not be 4. 4 square is 16, 3 square is 9. K minus 1 is 3, or k is 4. I don't have to worry about k being minus 2, minus 3 because we're looking for the largest integer. K equal to 4. Y is a positive real number, the least possible value of k by 4y plus 9y. So 4 by 4y plus 9y. 1 by y plus 9y. This is greater than or equal to a plus b is greater than or equal to 2 times a plus b by 2 is greater than or equal to square root of ab. Arithmetic mean is greater than or equal to geometric mean. Positive real number, we can plug in arithmetic mean, geometric mean. We are finding arithmetic mean, geometric mean of 1 by y and 9y. A plus b by 2 is greater than or equal to square root of ab. A plus b is greater than or equal to 2 times square root of ab. 2 times 1 by y into 9y. Square root of 9 is 3. This is greater than or equal to 6. The least possible value is 6. We are using the idea that a plus b by 2 is greater than or equal to square root of ab. Arithmetic mean of two positive real numbers is always greater than or equal to geometric mean of two positive real numbers. As long as we're talking, as long as both are positive and real. So am is greater than or equal to gm. We're plugging that idea in and getting 6. P square plus q square minus 29 equals 2pq minus 20 equal to 52 minus 2pq. Then the difference between the maximum and minimum possible values of p cube minus q cube. A lovely question. What do? We take this and say p square plus q square minus 29 equals 2pq minus 20, or p minus q whole square equals 49. This is minus 20, not 49, just 9. Oops. Just walked into that one, didn't I? P minus q is plus or minus 3. What do we have here? Next equation is p square plus q square plus 2pq equals 29 plus 52, or p plus q whole square equals 81. P plus q is plus or minus 9. Nice. Maximum and minimum possible value of p cube minus q cube. The difference between the maximum possible value of p cube minus q cube and the minimum possible value of p cube minus q cube. Pain. We need to maximize p, minimize q, and then minimize p, maximize q, and then do p cube minus q cube. Fine. It's a pain because there are multiple values going to be possible. What I'm going to do, I'm going to just brute force it. I'm going to say p plus q equal to 9, p minus q equal to 3, p plus q equal to minus 9, p minus q equal to 3, p plus q equal to 9, p minus q equal to minus 3, p plus q equal to minus 9, p minus q equal to minus 3. 2p is 12, p is 6, 6 minus q is 3, q is 3. 2p is minus 6, p is minus 3, minus 3, q is minus 6. Here 2p is 6, p is 3, p minus q is minus 3, q is 6. 3 plus 6 is 9. 2p is minus 12, p is minus 12, q is, p is minus 6, q is minus 3. P cube minus q cube. What is the maximum and minimum possibility of p cube minus q cube? P cube minus q cube maximum, p max and q min. 6 cube minus 3 cube will come. Minus 3 whole cube minus 6 whole cube. I think both will be same. We are looking at 216 minus 27. P cube minus q cube. This is minus 27 minus 216. This is 27 minus 216 minus 216 minus 27. Fine. So the maximum possible is 16 minus 7 is 9, 189. This will also be 189. I think this will be, these two will be minus 189. So maximum possible is plus 189. Minimum possible is minus 189. The difference is 189 into 2. 190 into 2 is 380, which is 378. If x is a positive real number such that x power 8 plus 1 by x power 8 is 47, then the value of x power 9 plus 1 by x power 9. Standard question, nothing dramatic about this. X power 8 plus x power 1 by 8, 1 by x power 8. It all depends on this one funda. When you use a different variable, y plus 1 by y, the whole square is y square plus 1 by y square plus 2 into y into 1 by y. So we have y plus 1 by y, we can get y square plus 1 by y square. Y square plus 1 by y square, we can get y power 4 plus 1 by y power 4. And then one step more is this. We've got that. But how do we go to this? What's happening here? And so suppose we have y plus 1 by y whole cube. This is y cube plus 1 by y cube plus 3 times y into 1 by y into y plus 1 by y. Nice. So we have this and this, we've got this. So this is the method. So you can do the same thing for y minus 1 by y whole square. Y minus 1 by y whole square is y square plus 1 by y square minus 2. So the whole funda is, we're just going to use this to carve this entire thing open. So let's go step by step. After we crack the method, it's a painful question because very time consuming. And so let's go step by step and say, hey, x power 4 plus 1 by x power 4 whole square is x power 8 plus 1 by x power 8 plus 2. 47 plus 2 is 49. X power 4 plus 1 by x power 4 is therefore 7 because it cannot be negative. 7 square. Done. So far so good. So now we say, hey, nice. So x square plus 1 by x square, the whole square, is x power 4 plus 1 by x power 4 plus 2. Remember, we got this as 7. 7 square is 49. 47 plus 2. So 7 plus 2 is 9. X square plus 1 by x square could be 3 or minus 3. It's x square plus 1 by x square. It cannot really be minus 3. Therefore, x square plus 1 by x square is 3. 3 square is 7 plus 2. So far so good. Also x is a positive real number. I had completely forgotten that, but doesn't matter. So far so good. So x plus 1 by x whole square is x square plus 1 by x square plus 2. X plus 1 by x whole square is 3 plus 2 5, or x plus 1 by x is root 5. So x plus 1 by x is root 5. Nice, beautiful. So we take x plus 1 by x, the whole cube, it's x cube plus 1 by x cube plus 3 times x plus 1 by x. 3x into 1 by x, x plus 1 by x. This is root 5. Root 5 cube. Root 5 into root 5 into root 5. 5 root 5 equals x cube plus 1 by x cube plus 3 root 5. Or x cube plus 1 by x cube is 2 root 5. Plug that back in here. X cube plus 1 by x cube whole cube is x power 9 plus 1 by x power 9 plus 3 times x cube plus 1 by x cube. This is 2 root 5. 2 root 5 the whole cube. So 2 root 5 into 2 root 5 into 2 root 5. 2 root 5 into 2 root 5 is 2 into 4. 4 into 5, 20. 20 into 2 root 5, which is 40 root 5 equals, this is what we need to find, plus 3 times 2 root 5. 3 times 2 root 5 is 6 root 5. 40 root 5 is something plus 6 root 5, or this something is 34 root 5. Hopefully that's there among our choices. Yes, it is there. That is the right answer. Now, once you know that we are manipulating x plus 1 by x, x square plus 1 by x square, x power 4 plus 1 by x power 4, going from x plus 1 by x to x cube plus 1 by x cube, we know that framework. Then this is doable. Still a pain, still time consuming, because you go from power 8 to 4 to 1, 1, 3, 9. So x power 8 to x power 4 to x square to x1, 3 steps, 3, 9, 2 more steps here, 5 steps of manipulating to get here. So it's a painful question even after we crack the method straight away. Let n and m be two positive integers such that there are exactly 41 integers greater than 8 power m and less than 8 power n, right? Which can be expressed as powers of 2. Okay, nice. So 8 power m greater than 8 power m and less than 8 power n. So 41 integers that can be expressed as powers of 2. Fine. So this is 2 power something, 41 different values. Nice. Then the smallest possible value of n plus m is, nice. So 8 power m and 8 power m, 8 power n, in between these two, bunch of powers of 2 are sitting there. Right? First of all, this is 2 power 3m less than 2 power something less than 2 power 3n. So between 3m and 3n, between say 9 and 36, and some 2 values. Fine. So 3m and 3n, how many different values can there be? So let's say we're looking at numbers from say 2 power 9 less than 2 power something less than 2 power 21. How many values can n take? 10, 11, 12 till 21. 21 minus 9 is 12. So there can be 12 different values. There can be 11 different values. Nice. So it's a very important adjustment, because otherwise this 41 won't come. When I did this question, I did 3n minus 3m and say 3 times n minus m. How is it going to be 41? It's not 3 times n minus m. It is 3n minus 3m minus 1, because it is in between. It's greater than this and less than that. So now we get quite beautifully 3n minus 3m minus 1 equals 41, or 3 times n minus m is 42. N minus m is 14. What are the smallest values of m plus n? N minus m is 14. All we need to m and 2 be two positive integers. So m could be 1. M is 1, in which case n is 15. 1 plus 15, 16. Done. Once we find the difference, plugging it in is far simpler. Doable question. For some real numbers a and b, the system of equations x plus y equal to 4 and a plus 5 times x plus b square minus 15 times y equal to 8b has infinitely many solutions for x and y. And then the maximum possible value of ab is, fine. So super pleased with this question because I skipped it in the end because I didn't even understand this question. Fine. So x plus y equal to 4, a plus 5 times x plus b square minus 15 times y equal to 8b. This has infinitely many solutions. Infinitely many solutions for x and y. a1 by a2 equal to b1 by b2 equal to c1 by c2. Plug that in, we should get somewhere. So we get a, I'm going to divide this by this. A plus 5 by 1 equals b square minus 15 by 1 equals 8b by 4. Just 2b. b square minus 15 equal to 2b minus 2b equal to 0. So b square minus 2b minus 15 is 0. So b minus 5 into b plus 3 equal to 0. So b is either 5 or minus 3. A plus 5 equal to 2b. b is 5 or minus 3. So a plus 5 is 10, in which case a is 5. A plus 5 is minus 6, in which case a is minus 6 minus 5 minus 11. A is 5 if and b is also 5. A is minus 11 if b is minus 3. What is the maximum possible value of AB? Either 5 into 5, 25, or minus 11 into minus 3, 33. 33 is larger, answer is 33. Once we plug in A1 by A2 equal to B1 by B2 equal to C1 by C2, we're through. My brain was so scrambled even by the time there was a third or fourth question because I'd seen too many X and Y. I didn't even pick that. I just had to skip this question and carry on. I should have come back to it, didn't pick it second time around. For real number X, if 1 by 2 log to the base 3 of 2 power X minus 9 by log to the base 3 of 4, log to the base 5 of 2 power X plus 17 by 2 by log to the base 5 of 4 are an arithmetic progression. First of all, log A to the base B by log C to the base B is log A to the base C. And so I'm going to simplify this and say the terms are 1 by 2, log 2 power X minus 9 to the base 4, log 2 power X plus 17 by 2 to the base 4. They are in arithmetic progression. That means this plus this equals 2 times this. So half, I'm going to write this as log 2 to the base 4, that is half. Excuse me, log 2 to the base 4, which is half, plus log 2 power X plus 17 by 2 to the base 4 equals 2 times log of 2 power X minus 9 to the base 4. So it's like 2 power X minus 9, 2 power X minus 9 to the base 4. So this plus this, I'm going to put a bracket around this because it's very confusing, is equal to that. Now this becomes a far simpler question. So because 2 into 2 power X plus 17 by 2 equals 2 power X minus 9 the whole square. 2 into 2 power X plus 17 by 2 equals 2 power X minus 9 the whole square. I'm going to call 2 power X as Y. So this is Y minus 9 the whole square. 2Y plus 17 equals Y minus 9 the whole square. 2Y plus 17 is Y square minus 18Y plus 81. So Y square minus 20Y, 81 minus 17 is 64. So this is Y minus 4 into Y minus 16 equal to 0. Y is 4 or 16. So 2 power X is Y. So 2 power X equal to 4 or 16, or X could be 2 or 4 plus or minus, not plus or minus, either 2 or 4. No plus or minus business, sorry. If X were 2 power X would be 4. 4 minus 9 is a negative number. I don't have to worry about it. I shouldn't be worrying about it. Therefore, 2 is not possible. So X has to be 4. Because 2 power X minus 9 has to be positive. 2 power X plus 17 by 2 has to be positive. Therefore, we know that X is 4. So now we need to find the common difference. Let's do this. Half log of 2 power 4 is 16. 16 minus 9. 7 to the base 3 by log 4 to the base 3, whatever this is. I don't even have to find the third term because I want to find a common difference. I'm going to do this minus this. So half, log 7 to the base 4. This I can write it as log 2 to the base 4. This minus this is a common difference. So log 7 to the base 4 minus log 2 to the base 4, which is log of 7 by 2 to the base 4. That is the common difference. This is 7, even though it looks weird. 7 by 2 to the base 4 is a common difference. Hopefully that's among the choices. Indeed it is. Let n be any natural number such that 5 power n minus 1 is less than 3 power n plus 1. Then the least integer value that satisfies 3 power n plus 1 less than 2 power n plus m for each n. And so it's one of those beautiful questions. I got caught out by this. Beautiful because it looks severely algebraic. There's an n and an m and then there are powers and all that. 5 power n minus 1 less than 3 power n plus 1. And so that's not algebraic at all. It's just numbers, nothing more than that. What I'm going to do, let me say n equal to 1. I'm going to think about 5 power n minus 1. I'm going to think about 3 power n plus 1. And so 5 power 0 is 1, 3 square is 9. I'm going to write powers of 5, 1, 5, 25, 125, 625 and so on. 9, 27, 81, 243, 729 and so on. 5 power n minus 1, 3 power n plus 1. Each term is the previous number into 5. Each one is previous number into 3. This starts off bigger than this. Somewhere this fellow is going to catch up. I'm multiplying by 5. I get bigger and bigger and bigger. Sooner than if this is multiplied by 3. This question hinges on where does this sequence overtake this sequence. That's it. That's a starting point. We grab onto that, we get through that much quicker. I put n equal to 1. Didn't work. This is lesser. Lesser, 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 lesser. But the moment we come here, you can even sense it is going to work. 625, 729 is very close. I multiply this by 3. I don't even have to find the number. It is some 2187. I don't care. This is greater than this. N equal to 1, 2, 3, 4, 5, 6. From 6 onwards, 5 power n minus 1 is greater than 3 power n plus 1. And so till 5, this holds good. 5 power n minus 1 less than 3 power n plus 1. N could be 1, 2, 3, 4 or 5. One of these. Right? 1, 2, 3, 4, 5 all works. From 6 onwards, 5 power 4 is greater than 3 power 6. This fellow overtakes. We know that 5 power n minus 1 is less than 3 power n plus 1. N is 1, 2, 3, 4 or 5. Now come to the second part. The least integer of m that satisfies 3 power n plus 1 less than 2 power n plus m. Right, nice. So n could be 1, 3 square less than 2 power m plus 1. N could be 2, 3 cube less than 2 power m plus 2. We want to find the least integer value of m that satisfies this. We have to find the least value of m here, 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 all the way till n equal to 6. 3 power 6 less than 2 power m plus 6. Okay. 3 square 9, 9 less than 2 power m plus 1, 9 less than 16. For this case, m is 3, 2 power 4. 3 cube is 27, this should be 32. M plus 2 is 32, m plus 2 is 5, m is 3. Straight away I sense that, look, I don't need to do every number, I'll go here. And 3 power 6 is 3 square whole cube, 9 cube, 729 less than 2 power 10, m plus 6 is 10, m is equal to 4. Somewhere it goes from 3 to 4, it is 3 or 4. I can kind of figure that out. I can guesstimate that because I'm going to have 3 power 4 less than 2 power m plus 2, 81. The next number is 128. 128 is, 3 power m plus 3. 128 is 2 power 7, m is 4. Right? So 3 power 6 is 729 less than 2 power 10. This is m plus, n plus m, m is 5, it should be m plus 5, it's not 4, m is 5. Sorry about that. So the value of m that satisfies this for all such n is the smallest possible value for everything should be at least 5. The answer, the least value m can take is 5. It's a beautiful question because there is practically nothing that we solve algebraically in this question. We're not solving a quadratic, we're not solving a cubic, we're not solving some exponential logarithm, fancy stuff, nothing. We basically look at this question and go, let me substitute lots of values, see where this falls in place. And beautiful question because of that. A quadratic equation x square plus bx plus c equal to 0 has two real roots. The difference between the reciprocals of the roots is 1 by 3 and sum of the reciprocals of the squares of the roots is 5 by 9. Then the largest possible value of b plus c. Incredibly complicated question. We have the roots to be alpha and beta. We know alpha plus beta is minus b. Alpha beta is c. Sum of the roots is minus b by a. Product of the roots is c by a. A is 1. We've got this. Right? So, if alpha and beta are not comfortable with, call it p and q. Right? So let's not go all Greek and Latin. I've started with this, so I'm going to continue with that. Difference between the reciprocals of the root is 1 by 3. 1 by alpha minus 1 by beta is 1 by 3. Or 1 by beta minus 1 by alpha, it doesn't matter. The sum of the reciprocals of the square of the roots is 5 by 9. 1 by alpha square plus 1 by beta square is 5 by 9. In a second, I'm just going to stick a pause on it. 1 by alpha square plus 1 by beta square is 5 by 9. I can work with this better because this can be simplified in these terms. So this becomes alpha plus beta, the alpha square plus beta square by alpha square beta square is 5 by 9. Is alpha plus beta the whole square minus 2 alpha beta. Alpha plus beta the whole square minus 2 alpha beta by alpha square beta square is 5 by 9. Is b square minus 2c by c square. B square minus 2c by c square is 5 by 9. Right, so we've got alpha plus beta the whole square. If you think about alpha minus beta the whole square, this is alpha square plus beta square minus 2 alpha beta, or this is alpha minus alpha plus beta the whole square minus 4 alpha beta. So alpha minus beta the whole square is b square minus 4c. So we have 1 by alpha minus 1 by beta, it is beta minus alpha by alpha beta is 1 by 3, or beta square minus beta minus alpha the whole square by alpha square beta square is 1 by 9. Why am I going towards beta minus alpha the whole square? That's what I can get. Like, no, I can get alpha plus beta the whole square, alpha minus beta the whole square, because alpha square plus beta square, alpha square plus beta square minus 2 alpha beta plus 2 alpha beta, all of the manipulations I can do. So I've got alpha plus beta and alpha beta. So I can get alpha square plus beta square, alpha minus beta the whole square. I have an alpha minus beta here, I square that. So if alpha minus beta the whole square or beta minus alpha the whole square, both are same. So we have beta minus alpha the whole square, that is b square minus 4c by c square to be 1 by 9. B square minus 2c by c square is 5 by 9. B square minus 4c by c square is 1 by 9. I can subtract one from the other. The b square term will disappear. So I have b square minus 2c minus b square plus 4c by c square, or I have 2c by c square to be equal to 4 by 9. I'm subtracting from 1, I'm subtracting 2. B square minus 2c minus of b square minus 4c by c square. B square disappears, 2c remains, 2c by c square is 4 by 9. This goes away, 2 by 9. This goes away. 1 by c is 2 by 9, or c is 9 by 2. I've got c equals 9 by 2. Then what do I have? I can substitute in either equation, b square minus 2c by c square. B square minus 2c by c square equals 5 by 9. This is c square, I multiply this by c square. B square minus 2c is this into 9 by 2 into 9 by 2. B square minus 9 equals 5 into 9, 45 by 4, or b square equals 45 by 4 plus 36 by 4, which is 81 by 4. or B is plus or minus 9 by 2. Either 9 by 2 or minus 9 by 2, one of the two. So C is 9 by 2, B is plus or minus 9 by 2. We want the largest possible value of B plus C, 9 by 2 plus 9 by 2, just 9. Right? So I have a feeling that there could be some juicier manipulation of this. I'm yet to come upon it. But I know that it is not too simple, it's too much simpler than this. It's a pain in the neck. It's a round goose, kind of proper wild goose chase to isolate each of these and find that classic tough question. Simple framework of quadratic equation, but super difficult as a question. A n equals 46 plus 8n, B n equals 98 plus 4n, two sequences for natural numbers n less than or equal to 100. Then the sum of all terms common to both the sequences. Right? A1 46 plus 8 54, A2 62, A3 is 70, and so on. B1 is 102, B2 is 106, B3 is 110, and so on. This goes in step size of 8, this goes in step size of 4. We have to find sum of all terms common to both of them, n less than or equal to 100. The 100th term here is 46 plus 800, 846. The 100th term here is 400 plus 98, 498. So the common part will get cut off here. I won't go beyond 498. And so this goes in steps of 8, that goes in steps of 4. So if there is one common term, there should be, given they have given us this question, then from then on, that number plus 8 will be part of the sequence. So I'm going to say, how do I find the common term? We have to go all the way till 102, 106, 110. I'm going to brute force it. 70, 78, 86, 94, 102, 110. 110 is there, 102 is there. So my new sequence, the common sequence, will start with 102. I'm going to say C1 is 102, C2 is 110, C3 is 118, C4 is 126, and so on. Till Cn, which could be 498, could be, may not be. 498 need not be an element in this sequence. This goes step size of 8. This is 96 plus 6. This is 104 plus 6. So each number here is the form 8k plus 6. 498 is set of the form 8k plus 6. I'm going to take 498 divided by 8 or 6 times 48, 18, 2 times. No. It is 8k plus 2. So 498 will not be an element here. 494 will be. One term before. So B100 is not a part, B99 is a part. So 494 is there. How many elements are there in the sequence? This is the first term, 102 plus n minus 1 into 8 is 494. Or n minus 1 into 8 is 494 minus 102, which is 392. Or n minus 1 is 392 by 8, 32 gives us 4, which is 49, or n is 50. 50 terms common in this sequence, starting with 102, going all the way till 494. Sum of all those terms is 50 by 2 into 110 plus 494. Sum of all those terms, 102 plus 494, not 110. Or this is 50 by 2. I'm keeping it as 50 by 2, not taking it as 25. Add these two, 2 plus 4, 6, 9 sitting here, 596. So let's divide this first of all. 596, 600 by 2 is 300. This is 298. 50 into 298, or 100 into 149. Which is 14900. Hopefully that there among our choices is there. Done. The value of 1 plus 1 plus 1 by 3 times 1 by 4 plus 1 plus 1 by 3 plus 1 by 9 times 1 by 16 plus 1 plus 1 by 3 plus 1 by 9 plus 1 by 27 times 1 by 64, and so on is tough one and a proper pain in the neck. We need to figure out a way. There's a GP inside which another progression is being tagged on. So 1 plus 1 by 3 is 4 by 3, 4 by 3 into 1 by 4, 1 by 3. 1 plus 1 by 3 plus 1 by 9, you have to figure that out, 9 plus 3 plus 1, 13 by 9 into 1 by 16. Not very friendly. I thought numbers will get cancelled and give us some very sweet thing. That is not happening. So what am I going to do? I'm going to say, hey, I'm going to take the first terms in this sequence. Attack them first. So first terms is 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 and so on infinitely. Then second term 1 by 3 into 1 by 4 plus 1 by 3 into 1 by 16 plus 1 by 3 into 1 by 64 and so on. Next terms of the sequence 1 by 9 into 1 by 16 plus 1 by 9 into 1 by 64 and so on. Nice. What I'm going to do, I'm going to treat this first one, that's a GP, infinite GP, with first term being 1 and common ratio being 1 by 4. I know how to plug this in. I'm going to think of this as sum 1, sum 2, sum 3 and so on. I'm going to first find out sum 1, not sum 1, sum 1, right? A by 1 minus R, 1 by 3 by 4, 1 minus 1 by 4, 1 by 3 by 4 is equal to 4 by 3. Nice. Next, what are we going to do? We're going to say, okay, nice, so far so good. Let's do sum 2. The first term is 1 by 12, 1 by 3 into 1 by 4, first term is 1 by 12. The common ratio is again 1 by 4. And so 4, 16, 64. The 1 by 3 remains the same. 4 becomes 16, 16 becomes 64, 1 by 4. 1 by 12 by 3 by 4. 1 by 12 into 4 by 3 or 1 by 9. The next term, the first term is 1 by 9 into 1 by 16. Common ratio is again 1 by 4 by 3 by 4 and so on. Now if you notice, sum 2 we calculate in a very convoluted fashion. The common ratio is the same. The first term is 1 by 12. There is a 1 by 3 and a 1 by 4. Here the first term is this first term into 1 by 3 into 1 by 4. Or if you think about it, S1 is 4 by 3. S2 is 4 by 3 into 1 by 12. S3 is 4 by 3 into 1 by 12 into 1 by 12. This is again a geometric progression, again an infinite progression, again one with first term 4 by 3 and common ratio 1 by 12, or sum of this whole thing is 4 by 3 by 1 minus 1 by 12, 4 by 3 by 11 by 12, or 4 by 3 into 12 by 11, which is 16 by 11. Hopefully that's there among our choices. Yes, it's there, it's the right answer. Suppose f of x comma y is a real valued function such that f of 3x plus 2y comma 2x minus 5y is 19x. For all real numbers x and y, the value of x for which f of x comma 2x is 27 is pain. F of x comma 2x is 27. Something to start with. This has two variables. This has only one. But remember, this one, the ratio of these two is 1:2. What I'm going to do, I'm going to just say, hey, this whole idea that f of x comma 2x is 27 works in the scenario there is some x and the second part of that is twice of that. I'm going to say this formula works beautifully, involves only x, and this comes to 27. I can manipulate everything in terms of x. If I can make this 1:2 condition satisfied here, I'm going to forget everything else and then say, hey, 3x plus 2y into 2 equals 2x minus 5y. If I can make this work, then this is of the type f of k comma 2k. Then I can substitute 19x, solve for this, get everything going. Right? Find convoluted method, but let's approach this. So 6x plus 4y equals 2x minus 5y. 4x equals minus 9y. X equals minus 9 by 4 times y. Y equals minus 4 by 9 times x. Nice. So what I'm going to take this and substitute this here. F of 3x plus 2 times minus 4 by 9x, comma 2x minus 5 times minus 4 by 9x equals 19x. Or f of 3x minus 8 by 9x, 27 by 9x minus 8 by 9x, comma 18 by 9x plus 20 by 9x equals 19x. Or f of 19 by 9x, comma 38 by 9x equals 19x. We know f of x comma 2x is 27. We know f of 19 by 9x comma 38 by 9x is 19x. We want to find f of x comma 2x equals 27. This ratio is 1:2, this ratio is 1:2. We say 19 by 9 comma 38 by 9x is 19x. What is the f of x comma 2x is 27. So I want this to be x, this to be 2x. I'm going to treat this slightly differently. I'm going to say f of 19 by 9, just to simplify this, 19 by 9k plus 38 by 9k is 19k. So treat it very differently. This into 2 is this. Suppose I put k as 9 by 19, 9x by 19. Hypothetically, 9x by 19. K is 9x by 19. Why am I doing this? Because I'll get x, f of x comma 2x. K is 9x by 19. So 9x by 19, 9x by 19, 9x by 19. So this goes away, this goes away, this goes away, this is 2, this goes away, 9x. We get f of x comma 2x is 9x. Just reframing that equation. F of x comma 2x is 9x. So this is 9x. 9x is equal to 27. X is 3. F of 3 comma 6 is 27. You plug it back here, this will be satisfied, this will be satisfied, all of that will be satisfied. Painful question, tough question.